Okay, please take a seat. Fantastic. I'm going to keep this super short. Welcome to the summer meeting for the International Economics and Geopolitics Group. Somewhat regrettably, the area isn't getting any less relevant. It's very active in the real world, and it's very active in research, so I'm very grateful that you're all here. I'm Matteo Maggiori, my co-organizer is Jesse Schrager, is here. Since the group spans many areas, what I would like to do is have everybody introduce themselves very, very briefly, state your name and affiliation, and then we'll proceed to the first presentation. Let me thank Jim for allowing us to have these meetings, and also for supporting the whole area. And finally, let me remind you that the NBER Code of Conduct for the conference applies to this group as well. Again, I'm Matteo Maggiori from Stanford.
Ernest Liu, Princeton.
Jesse Schrager, Columbia.
Chris Clayton, Yale.
Peter Rosendorf, New York University.
Lena Mosley, Princeton.
Steve Redding, Stanford.
Alan Charles, Stanford. Ron Messina, Chicago. Jonathan Elliott, Johns Hopkins.
Yogi Burke,
Timothy Meyer, University of Philadelphia Institute.
Nicholas Bessler, University of British Columbia.
Harvard Kings.
Emily Winter, Dartmouth.
Nicholas Borwick, Ralph Johnson, Notre Dame.
Christoph Travesh, Key Institute.
Alberto Mahmoud, Grady.
Michael Bordeaux, Western University.
Miles Davis, Davis. J.O. Glenn, Harvard Business School.
Bruno Pellegrino from UF.
Alexei Makarian, MIT.
Henry Young, University of Michigan.
Jonathan Engel, Columbia.
Federico Checo, Michigan.
Giovanni Raggi, UF.
Benjamin Kaka, CTV.
Matthew Benoit, Berkeley.
David Shore, Delaware.
Cecilia Filer, Yale.
Alba Baviera,
Matthias Weich, Harvard.
Jesse Shapiro, Harvard.
Francesca Zanenti, Oxford. David Young, Harvard.
Stephen Schoen, Harvard.
I think we have a few people there at the back.
Sorry, Zach is last name from that. Excellent, Michigan State. U.S. on
That's Nick Worthington.
Michael Buccinacci, Key Institute. German, Martina, New York.
Fantastic. Thank you. So the first paper is a network approach to geopolitics, and Ernest Liu will be presenting.
I have my own clip here.
Works.
Not working.
No? Let's use mine. No. Okay, great. Thanks very much for having this paper on the program. It's new work with Steve, Bennett, and David. The entire team is here, so we look forward to discussions afterwards. We're going to talk about a network approach to geopolitics. Our starting point is simple. That is to recognize geopolitical issues are rarely bilateral in nature. They almost always involve coordination, collaboration, strategic influence over a network of countries. Examples abound. So going back to the Cold War, the West and the Soviets fought for influence over African and Southeast Asian countries. When Russia invaded Ukraine, very quickly it became a coordination problem across 2 continents over sanctions, arms, energy. And more recently, when Trump turned up the rhetoric of acquiring Greenland, within days, France and Germany reacted, and soon after, a coalition of 8 European countries issued a joint response to stand behind Danish sovereignty. The common thread in all of these issues, in fact, most of international issues we talked about or read about in the news, involve coalitions of countries trying to influence each other, influence third parties to coordinate, to interact, and to shape foreign policy. So we are, in this paper, hoping to provide a framework to think about geopolitics using this network approach. In this talk, we're going to first start with a model where countries will choose policies or take policy actions to trade off between the alignment of their action and their own domestic or national interest, as well as the alignment between their actions and the action of their allies over an interaction network. Prior to countries taking these policy action choices, they can make costly investment to influence one another to shape other countries' incentive in taking different actions. So in this setting, influence propagates through the network. I can try to influence Steve to take a higher or a lower action. Other countries who try to coordinate with Steve, their action in equilibrium will also be affected. So bilateral influence will have cascading effects. This model enables us to view geopolitical actions in the data as an equilibrium outcome. So we're going to go to the data and try to recover this geopolitical network using revealed preferences. We're going to validate the network we recover with external data, with variables that we think should relate to bilateral relationships. And the main payoff of having such a framework is to perform geopolitical counterfactuals. Take an international issue. Say China is contemplating taking military actions in the South China Sea. Which are the countries that China would most like to influence? And what would happen to regional outcomes, say between the conflict between Israel and Iran, when China switches its preferences and take a stance that's closer to the US? How would that affect the action of countries around the world? So we can do that types of counterfactuals with this framework. So let me start by describing the model. Formally, there are n countries connected by a graph, G, of international relations. This graph, G, it's a matrix. To start, we're going to assume this graph is symmetric for expositional simplicity. So the graph or the network is a weighted undirected graph. We're going to interpret this network as capturing long-standing bilateral relations, alliances, economic dependence. Given the network, there's an international issue that arises. Each country has some domestic interest or national interest over an international issue, and then they can choose a political action. So concretely, as an example, every country may have their own interest in whether to restrict China from having access to advanced semiconductor technologies, and whether they actually restrict, that's the action. Their own interest in restricting, that's the object theta. Each country can exert costly influence over any other country to change their action. So the US may want to pressure the Netherlands and Japan to stop exporting their technology to China. Okay? We're going to study a game of perfect information, and for now, we're going to focus a single international issue, whereas when we go to the data later, we're going to recognize that many issues arise. So to summarize, G is a network of bilateral relationships, theta are draws of international issues. Closing down of Hormuz, Iran-Israeli conflict, each of these instances would be separate copies of this issue. We're going to study the model with a single issue, and assuming that in the data there are many issues being drawn when we take the model to the data. Okay. Let me first introduce the model without foreign influence. So without influence, the model is a very simple network-based beauty contest game. Every country I is choosing an action to minimize the distance between its action and its own domestic interest, as well as between the distance of its action and the neighbor's action. So in this beauty contest, the solution would be every country just the action is a weighted average of its own domestic interest and the action of its network neighbors. Of course, if Steve's action affects my action, and Steve's action may affect David's action, and so on, so because of network interaction, In equilibrium, the action of every country is a weighted average of its own interests, the interests of its neighbors, neighbors, and so on. That's the beauty contest. Okay. We're going to introduce foreign influence or bilateral influence to this game. Influence is bilateral in nature. Every country in the world can choose to influence every other country, and influence will be a number. It can be a positive number or a negative number. So in terms of payoffs, the first line is just the beauty contest payoff. The third line here is the cost of country I exerting influence on other countries. Country I can influence K to take a higher or lower action. So this influence can be positive or negative. There's a quadratic cost scaled by a parameter kappa of how costly it is to exert influence. The second line specifies how a country having received foreign influence changes its incentive of taking different actions. So when some countries ask me to take a higher action, other countries ask me to take a lower action, on net, the net influence country I receives is this summation over all the influence received from different origins, M. If the net influence is positive, country I has incentive to take a higher action relative to beauty contest, vice versa, if the net influence is negative. The timing of the model is every country first chooses how much to influence each other, and then the game move on to a stage where they take influence as given and play a modified beauty contest game under perfect information. So I'm going to solve the model via backward induction. First, given bilateral influence in place, what action do countries take? The best response looks very much like the beauty contest best response. Every country's action is just the beauty contest component plus the net influence received. So if I receive a lot of influence from foreign nations to take a higher action, my action would be exactly the total net influence received on top of the beauty contest solution. But of course, because other countries try to coordinate with me, these influence will have global effects. So if I influence country K, other countries trying to coordinate with K, other countries will change their actions as well. And that's the consideration that give rise to the ex ante influence stage, where every country is choosing the set of influence it can exert. Philippines may want to influence the US, not because Philippines cares about coordinating with the US, but because Philippines cares about coordinating with China, and China coordinates with the US. So those are the considerations that go into these first order conditions that give rise to the following. I have greater incentive to influence Steve if my neighbors act out of line with me and those neighbors listen to Steve. That's what this first order condition says. So put all of that together, we have the equilibrium. Equilibrium is a vector of actions across countries, which is equal to a matrix times the vector of domestic interest across countries. So every country here, the action is a weighted average of the national interests of other countries around the world. So US action depends on the national interests of US, China, its allies and enemies, and so on. And how the action of different parties how the preferences of different parties influence each other's action is encoded by this matrix L, which depends on the network, and it depends on the cost of influence. Okay? So the model has intuitive properties. If we shut down influence by making the cost of influence go into infinity, the model goes back to a beauty contest game. Conversely, if we make influence as cheap as possible, well, cheap influence homogenizes the world in the sense that all actions taken by countries converge to the global average of their domestic interest. Okay? So equilibrium has the following implication. How important a country is, how powerful it is, how pivotal it is, depends both on the network and the issue, which captures disagreement across countries. This is how important are countries to each other in terms of coordination, who's allies. This is the set of this is an issue that captures disagreement across countries. So US may be the most important and the most central and pivotal along an issue that mainly loads on the conflict between US-China, but US may be on the peripheral, not that important, on localized conflicts, say between India and Pakistan. So same network, different issues, different set of pivotal countries. Okay? So that's the model. I'm going to show you one theoretical implication of the model before we go to the data. The implication is the following. We would like to understand what kind of disagreements across countries lead to great divergence in actions across countries, and what kind of disagreements get smoothed out by coordination among countries. Okay. The right mathematical object to look at to answer that question are the eigenvectors of this network. Intuitively, each eigenvector corresponds to a distinct geopolitical cleavage, a particular mode of disagreements across countries. So to give you some example, when we go to the data, one eigenvector would capture the east-west divide, where US loads on one side, China, Russia loads heavily on the other side. A second eigenvector may capture north-south divide, a third may capture regional conflict between India and Pakistan, a fourth may capture Iran-Israeli, and so on. Those eigenvectors form an orthonormal basis of all possible international issues across this set of countries. And any vector that capture disagreements across countries can be written as a linear combination of those eigenvectors. So when China is contemplating taking over Taiwan, there's a national interest that encodes each country's own preferences over that particular issue. Are you on the side of China or are you on the side of US-Taiwan? That issue can be written as a linear combination of east-west divide, north-south divide, and so on. Okay. Given this representation, the equilibrium action is the same linear combination over those geopolitical cleavages. It's just that disagreements along certain cleavages gets turned up and amplified when they become disagreements in actions, whereas other cleavages gets toned down. And that scaling factor depends only on the eigenvalue of that eigenvector in determining the network. Okay? So these eigenvalues are properties of the network that says how important is a cleavage for determining the network. These can be formalized, but intuitively that comes from the following interpretation mathematically. So eigenvectors is a basis of cross-country disagreements. And high eigenvalues, those are eigenvectors that capture disagreements where network neighbors tend to agree with each other and loads all the disagreement across blocks of weakly connected countries. So in a world where US is very strongly connected with Canada and Europe, China is very strongly connected with Russia and Iran, a high eigenvalue, an eigenvector that captures issues where US and its allies all agree with each other, China and its allies all agree with each other, but taking the other side, that eigenvector will have a high eigenvalue. Conversely, small eigenvalues, those eigenvectors capture issues where neighbors tend to disagree. So a geopolitical cleavage that captures disagreements between US and France or Canada will have a small eigenvalue. Well, when neighbors tend to disagree, but they want to coordinate with each other, their actions will not be so different, because differences in domestic interest will be suppressed by coordination. On the other hand, when neighbors agree, but across blocks there's disagreement, neighbors all try to coordinate with each other. US coordinates with France and Canada taking one side, China coordinates with Russia and Iran on the other side. That results in an echo chamber that lead to big differences in actions. Okay? That's the theoretical insight coming out of this. So given the model, if we can measure the network G, we can do a bunch of counterfactuals. So one way to go forward would be to perhaps specify a priori what G should look like. Say G, or the network, is the bilateral trade relation, or G is determined by who's in NATO versus not. Once you have G, you can run counterfactuals to look at what are the kind of issues that make certain country pivotal. Given a particular set of preferences across countries, who would China or US would like to influence the most, and so on. We are not going to specify G a priori. Instead, we're trying to learn G from revealed preference using the following strategy. We start from the observation that in the real world, countries act on many international issues. Every other week, there's some geopolitical news that come out. Across countries, there may be some covariance in their preferences, in their domestic interest. There seems to be strong alignment between France and Germany, and so on. So given a covariance of countries' domestic interests over international issues, that would generate a covariance that's potentially observable of countries' actions across international issues. With the following intuition: if Steve and I share very strong correlation in our domestic interests, but we always act in polar opposites, that means we cannot be very strongly connected. Conversely, if Jesse and I have always the opposite interests, but we always act very similarly, then we must be very strongly connected, either directly or indirectly. Okay? So we're going to learn about network connection based on observing how correlated countries are in their preferences or domestic institutions versus how similar they act at the international stage. So to operationalize that strategy, we need to impose one assumption. To us, the restriction is natural, that the same cleavage, the same set of eigenvectors that organize the network also organize how interests covary, based on the fact that allies may have systematically similar or dissimilar preferences due to shared media, ideology, or history. Formally, the assumption is graph stationarity, meaning the variance-covariance matrix where the issues are drawn for domestic interests have the same eigenvector as a network. This assumption is empirically testable in the sense that it imposes no empirical restriction besides the fact that cross-country covariance in preferences and in actions, they share the same principal component. So we provide some evidence of that when we go to the data. Under this stationarity assumption, we can recover the network using exactly the intuition that I've mentioned. That is, if one particular leverage, geopolitical cleavage, East-West divide, loads very significantly on their interests. So in terms of cross-country differences in their domestic interests over international issues, it's all loaded on East-West divide. But that divide never shows up in countries' actions. It doesn't explain a lot of variance in how countries covary in their actions. That means that cleavage must not be very important in determining the network. So putting all that together, we can recover the network. Before I show you the data, let me tell you about one extension that's useful in the data. That is, we have so far assumed that G is a symmetric matrix. It's an undirected network, but geopolitics is not. US is more important to Peru than Peru is to the US. So to introduce network asymmetry, we're going to introduce one new object. Each country's structural importance, which is denoted as pi, think of that as bigger countries as being more important. In the model, what it translates to is more important countries have disproportionate impact on their neighbors and they're themselves less sensitive to neighbors' actions. And also it's very expensive to influence structurally important targets, and it's expensive to project influence from less important countries to more important countries. So all of our earlier results go through once we adjust in some weighted sense, even with this extension. So now we're going to take the model to the data. We're going to rely on two main data sources, capturing cross-country covariance in their preferences and covariance in their actions. To measure covariance in actions, we're going to rely on United Nations General Assembly voting data. So if two countries vote very similarly on a set of issues, then two countries, we infer that they have high covariance in actions. For preferences, that's harder to get. So we're going to rely on the VDAM data set constructed by political scientists to score countries based on various dimensions of domestic institutions. Think freedom of press, gender equality, voting rights, and so on. So when two countries share a lot of similarity across a wide range of metrics rating domestic institutions, we view that they have high covariance across, between each other across international issues as well. And in terms of structural importance, we're going to write it as an increasing function of GDP and calibrate it by exploiting asymmetry in outward versus inward influence implied by the model. So with those construction in mind, we're going to show you three sets of empirical results. We have done the joint diagonalization and recovered the network. We're going to describe dominant eigenvector and describe features of the network. We're going to do some validation exercise to show that the network we recover from voting and scores of domestic institutions seem to relate to variables that we think should capture international relations. And then we're going to run some counterfactuals, changing China's preferences towards the US, for example. On this figure, we show you the dominant geopolitical cleavage over time across 6 decades. Now, in the data, there's a very salient east-west divide, where for the first 3 centuries in the data, between 1960s and 1980s, the east-west divide is largely between US and allies versus Russia and its allies. It's the Cold War eigenvector. And for the, after 1990s, it turns into US versus China. Now, the east-west divide shows up as the dominant cleavage, the most important cleavage in determining the network or international relations in all decades except for 1970s. That's the period of détente where denuclearization and de-escalation of Cold War makes that cleavage the second most important, not the most important. Okay? And notice that, 1990, that's right after the fall of Iron Curtain, Russia becomes much less salient in this eigenvector, in this east-west eigenvector, in determining the network. So we have a collection of eigenvectors for each decade. We put the eigenvector together, infer how important they are based on how much they explain covariances in actions versus covariances in preferences. So we construct a network for each decade. This figure is meant to show you that the network seems to be fairly persistent over time, with the exception of 1990s, with the exception of a trend break in the network after the fall of Iron Curtain. So every country's connection seems to be reasonably persistent from decade to decade, except a major reorganization of the network going from the 80s to the 90s. In this geopolitical network, it's a full matrix. We're going to look at 2 particular rows to think about which are the countries that weigh the US very importantly, and which are the countries that weigh China very importantly. If you look across these 2, for the US, we pick up all the usual allies. In North America, in Western Europe, Australia, Japan, and South Korea. The map on China is mostly Southeast Asia, many African countries, some Middle East, and Russia. A more formal validation exercise would be to correlate the network with other variables that we think should relate to international relations. So political distance, distance in political institutions, gravity variables on trade and distance, or whether there are cultural similarities between pairs of countries. The network correlate very strongly with all these measures. And a more powerful exercise of validation is the following. We observe UN votes, right? Countries vote on individual resolutions, yes, no, abstain. We treat those votes as the vector of actions, use the model to invert from those actions the underlying preferences. So when countries vote for or against sanctioning Iran, we take those votes and back out their preferences and the implied influence they would like to impose on all other countries in the world. We collapse those bilateral influence down to country pair by year level, and we show that this model implied influence predict very strongly diplomatic visits, country leader visits. After controlling for country year fixed effect, one standard deviation in greater bilateral influence in that year between that country pair within the model implied roughly predicts 5% more leader visits within that pair. Okay. Finally, the main payoff of the paper is to run geopolitical counterfactuals. So recall that actions depend on network and depends on the set of disagreements. So we're going to show you this is the action across countries represented in color when we load on the dominant east-west divide, the dominant cleavage. So the color of the country indicate whether a country is on one side or on the other side of the cleavage. You see US and allies taking the blue side, China and its ally taking the red side, and so on. So that's the action implied by the dominant cleavage. The counterfactual here is to hold everybody else domestic interest constant but change China's domestic interest to be fully aligned with the US. That's the picture on the map. I want to highlight 3 features. One, even when China's interest is fully aligned with the US, China's action doesn't fully converge to that of the US, because China's action is shaped by the coordination to its allies, and its allies still have the preferences more towards the right. Okay. Second, there's, changing China's preferences changes the actions of a bunch of countries that used to coordinate strongly with China, but the world is not fully homogeneous, because Russia and all these other countries, Iran, they still have preferences. They still have the preferences that remain unchanged. And finally, the more subtle feature is if you look at the color of the US actually take an action that's less extreme. So when China takes its position going from extreme right to the left to align with the US preferences, that actually makes US action less extreme. There's less need of taking extreme action and influence other countries. Okay. So that's the implication of this counterfactual. A different counterfactual we can run is to think about what makes a country powerful. There are various notions of power, right? One notion would be if we perturb a country's own preferences, how much does that perturbation get translated into changes in its own actions? The freedom to express itself despite this geopolitical game that we're playing. A second would be if we change the action of that country, how much does it shift the action of all other countries? How much influence outwards does it project? So China and US line on, are differentially important in those 2 different exercises. Figure on the left, we are shifting each country's preferences one by one and calculate how much does its own action change as we change the preference by the same unit. US has greater freedom to express its own domestic interest than China. But in terms of moving others, China seems to be more influential than the US. When Chinese preferences change, that induces more changes in action on others. So this picture is shown using the dominant geopolitical cleavage as the disagreements across countries. But on disagreements where US and China are no longer the most important or pivotal, this picture would change drastically. Okay. I have 2 minutes. Let me show you a few other implications. One, we can look at which countries received the most influence in the 2010s. So the model, if you believe the model as the data generating process, there's a variance covariance matrix that draw countries' preferences across international issues. We draw from that estimated variance covariance matrix in the world, calculate model implied influence, and look at, in the 2010s, which countries received the most influence from other countries. Syria, Iran, Yemen, Venezuela, these countries are at the center of conflict, seems to be in between or in pivotal bridges between blocks. They seem to receive the most influence. And interestingly, US receives a lot of foreign influence, China not nearly as much. Okay. Another exercise would be to think about through what channel does influence operate. If US wants to influence another country, does most of the influence arise by US pressuring that country itself? Or does US generate most of the influence through indirect network connections? How much of that influence generate through if I try to influence you and you change your action and affect all your allies? Okay. So the black line, if we do this direct versus indirect influence decomposition, on average across countries, 40% influence come from indirect sources. For US, Russia, China, the bigger economies, the hegemons, indirect influence account for lower fraction because they're more directly connected to the rest of the world. Okay, it's time. So let me conclude here. This is a network approach to geopolitics. It's a framework that enables us to think about geopolitical interactions as equilibrium outcomes, and we can perform geopolitical counterfactuals. We're very excited about this new paper. Thank you.
Thanks so much. And the discussant is Chris Clayton.
Okay, it's a pleasure to be here and get to discuss this really cool paper from Ernest and his co-authors. So what's great about this paper is it's got this complicated looking structure to it, but at the end of the day, it's a model that's set up very tractably to give closed form theory. And you can take that closed form theory and use it to look at how each of these different countries strategically influences each other within this beauty contest setup. It goes from there and presents its key decomposition. It shows that once you've got this characterization of not only how countries respond to their neighbors within the beauty contest, but also with how they actually then go and influence each other, you can perform a decomposition, formally it's going to be a spectral decomposition, to actually uncover the underlying geopolitical network from the observed actions that you can see in the data. And then the paper goes from there. That's a lot of these really cool graphs that Ernest showed you, and maps out what these different cleavages look like to see how they trace out over time. So I think it's a really cool and interesting paper. I'm going to start by just giving like a brief overview of the kind of approach that these authors are taking, in case it went a little fast during a short talk, and then give a few comments for where I think some of the exciting places this paper can go. So let me give a simple illustration here. We've got two countries, 1 and 2, so it's going to be much simpler than the more general setup the authors have. They're going to play this two-stage game. In the first stage, each country is going to influence potentially each other country. And in the second stage, each country is going to choose an action. So let me put in two symmetric countries, so I'll just characterize one of them, and then the other is symmetric. Each country has a quadratic loss over divergence of its action from its preferences. It has a quadratic loss of its divergence of its action from the other countries. So this is the beauty contest element to it. And then it's also got the influence capability. Each of these two countries can put what I would usually call a wedge, but there's a lot of interpretations, into the decision problem of the other at a quadratic cost. This is the ex-ante influence game, where they're going to shape each other's ex post actions. Now what's nice about this is this beauty contest model, it can be summarized by a matrix. Here it's a really simple symmetric matrix capturing the weight that each of them puts in the beauty contest on the other's action. And of course in the general theory, this is bad notation, I guess, because they use G for the whole matrix, and I use it for the off-diagonal components. So sorry for that confusion. So let's solve this out. Simple, it's like, this is what's nice, is like, it's, just a couple equations here, but even in the paper, it's all linear quadratic. Once it's all linear quadratic, you can solve it all out with pen and paper. That's one of the fun things, actually, about this paper. Okay, so take the first order condition for the optimal action. You want to align with your own preference, you want to align with your neighbor, and you have some influence put in from your neighbor. Okay, so your underlying action is going to be a weighted combination between your preference, net of the influence put in by the other country, plus the action of your neighbor. Okay, where G is capturing the relative importance of the beauty contest element. So solve it out, nice, you get a weighted average of your preference, net of influence, and your neighbor's preference, net of influence. Then you can go and you can solve out what is this actual influence. Well, the simple envelope theorem in the ex-ante stage, all you care about is derivatives you're taking over your neighbor's action, because you're optimally choosing your own action in the ex post stage. So you get your influence you're placing, depends on, well, cost of influence, and then how much you're shifting your neighbor's action versus how much theirs exceeds yours. So like, what's the intuition here? If your neighbor is taking a larger action than you want to bring them back down towards you so that they align more with your action. And so you're going to do that by putting a tax on their action within this setup. And then you can go connect this, of course, solve, like from here, like you can solve out enclosed forums. It starts to get uglier and uglier, so this is where I decided to stop the solving out by hand. Now, what can we do with this? So we get this nice representation. Let me take the limit where it's super expensive to influence the other country so that we've just got the beauty contest element. And of course, what's great about the paper is it shows that like the simplified version I'm going to do generalizes a lot in terms of the spectral decomposition insight. So I'm really just giving here one example of it. So then we can represent the action vector as a matrix multiplying the vector of preferences. We're scaling for each of these two countries. It's a nice symmetric matrix, combining the weight you're putting on your own preference and the weight through the graph that you're placing on your neighbor's preference. Now what we're going to do is we're going to perform a decomposition of this, re-representing the underlying actions as combinations of the underlying eigenvectors here. Well, what's this intuitively doing? It's intuitively giving us a basis for these underlying actions, telling us how much these actions tend to coincide versus diverge from each other. So for example, if we uncovered here within the basis an eigenvector that looked like 1 minus 1, that would be a kind of cleavage that pulls one country apart from the other one. Here we've got 2 by 2 symmetric matrix, so it's going to be like trivial, the eigenvectors that we get out of it. Once you're in the kind of more general graph, you get much more interesting properties. Now, what's nice here is to go back, remember some of the properties of doing this eigenvector decomposition. If we take a simple linear transformation of the underlying matrix, we preserve the same underlying eigenvectors. And what have they done? Well, in this simple example, all we've done is done exactly that linear transformation of that underlying graph. And so we're going to recover exactly the same eigenvectors from doing the decomposition on the action matrix as we would from doing it on the graph itself. And actually here they're going to be the kind of common vector 1, 1 and the divergent vector 1, minus 1. So it's the common component of the two actions and the divergent component of the two actions. And then it gets much more interesting when you've got a bunch of these countries and a more complicated graph. So the paper's kind of big contribution here, I think, is to not only show this property is more general, but also to then conduct the empirical evaluation that Ernest walked you through very carefully. I have very little comparative advantage on walking you back through the empirical decomposition, so I will have rested on my trust in Ernest to do a really good job showing it to you all. I'm glad I had rational expectations. So let me dive right into my comments. So first question I think really comes to mind. What I like about this paper is that not only is every country able to be potentially have some significance within the network, but also every country can try to influence both themselves. So that's like easy to get hidden in the equation is you can apply influence to other countries, but you can also apply influence to yourself. So think of this as like the differentiation between offensive statecraft, where I try and get another country to change their behavior, and defensive statecraft, where I try and prevent other countries from changing my own behavior. So they've got both of these. It can be like hard to spot in the paper, but they've got both. So on these two components, the ability to be important in the network and to strategically influence others, on the first question, I couldn't agree more. The paper also already documents evidence that these indirect effects via the network are important. And moreover, even if you thought there's kind of a handful of small countries in the world, there's also a ton of small countries in the world. And you add up impact on a ton of small countries, you're going to get to a big impact overall. The second one is where I think the paper has a lot to say on, and I'd be interested to see what it, kind of more on what it has to say. So, for example, let me take, I think Ernest didn't show this, or at least I missed it. This is a cool paper from a cool figure from a counterfactual exercise where they think about, suppose that a country got a change in its preference. How much would that propagate through to its own behavior versus the aggregate impact on its neighbors? So what's cool is you see like the effect on itself. There are some outliers. The US is like very kind of, it changes its preference, it changes its action. But there's a lot of like, of this effect across countries. Like even all these like collection of small, medium, big countries, like Great Britain is in here, they all translate like 25% into that change. Now, it's kind of more spread out when you go on the influence of others. Like China's a big standout. Interestingly, India, US is like, you have to move all the way up here, but it's there. But then you do have a bit of a trail. So my question here, I guess, is like, on defensive statecraft, does my preference or does my ability to shape my own behavior translate to changes in actions? I think unquestionably here we've got kind of good evidence that every country is can kind of shape its own behavior through defensive statecraft. On offensive statecraft, I do think influence here seems to be more concentrated. This isn't quite the right figure to be looking at for that question, because this is like, if there's an exogenous preference shock, what happens? Whereas the offensive statecraft is more, if I start trying to strategically influence, what happens? But it's like a good kind of first pass eyeball at what we might expect. And so the first big set of questions I would really like to kind of hear more from as this paper evolves is, should we think of N as 2, or like a very small n world, as of strategic offensive players, or what I would often call a hegemon, as a good approximation to the world? And this is like really helpful for especially people like me doing applied theory work when I think about how I write and shape models. It's also like got me thinking about, here we've got a model really of the network of actions being taken. That's kind of in some sense different from the model of influence, like the types of policies like sanctions, export controls, military capacity. The underlying network of that component of strategic influence may actually end up looking different from the network of the end actions that are trying to be influenced. I would be, my prior would be the US and China are particularly important within that kind of network of strategic influence. I'd be really interested to know how, it seems like the paper's methodology is well suited to make this type of differentiation. I'd be very curious to hear what it has to say. There's also a lot, we see countries like the EU, like the BRICS, trying to coordinate their strategies, both in terms of their actions and in terms of their influence. I think that kind of idea of a lot of these countries aggregating up their strategic influence to have a large impact may actually have a lot of bite. And so I'd be curious, even though maybe small n is a good approximation to individual countries and their strategic influence, how much actually coordinated influence ends up mattering within the network. Okay, I'm running short on time. So let me do my next 2 comments quickly, and then we can talk more, as will be useful. Second, this is, I think, really a model of an exogenous network structure. I think the paper already provides a bit of evidence that the network is evolving over time. Now, I personally view, at least within the influence network, as there's a lot of endogeneity to this underlying network. Like when we think about kind of underlying externalities like strategic complementarities, US dominance of the financial system, export controls containing technology, a lot of these are, I think, for the purpose of shaping the network so that the US has more power, more influence with it. Like another extreme, if a country puts itself into autarky, it sort of disconnects itself from the network. You can only do so much in one paper, so I think a really great direction to go maybe for the next paper is to really start thinking seriously as we endogenize this network and let countries strategically shape it, how do they affect its evolution? And just like very quickly, this is a beauty contest model. We want both the US to respect its underlying preference and to align with China. I might have written, like, if I had just like done my first pass writing of this model, I might have written this as the US wants its action and it also wants China to take its action. Like this might have been my kind of theory of, say, like export controls to China. The US wants Sweden or the Netherlands or whatever European country to actually go and reinforce its export controls for the purpose of blocking China. I don't know which of these two models is totally right, though, and it depends on the context. It would be great to know kind of what micro-foundations are best represented by each of these two different sets of preferences, as well as to know, like, does the model's decomposition actually go through with this type of setup? Okay, Jesse is telling me to get off the stage, so it's a great paper, and I'm really excited to see where it goes from here.
Thanks so much. And Ernest, you want to just collect a few questions and then answer?
Great.
Sure. Great paper. Thank you. It's not clear to me, well, I think you're assuming separability across these issue sets in both the preferences and the way they're structured. I think you have to do this decomposition. I'm questioning, in practice, I think that's a bit problematic. And one of the ways countries do exert influence is by bundling issue sets. I won't talk about economics without security. So I'm curious, could you talk a little bit about the assumption and how much you need it?
If I understood correctly from the presentation, you sort of observe the issues data and you convert them to recover this network G. I, by the way, got the impression from Chris's discussion that it could also be about observing the geopolitical action scale and inverting those. My comment then is related to Emily's. I think it's sort of not immediately obvious to me that measuring data is easier than measuring G. G is a country by country thing. There are lots of countries, but there are also lots and lots of issues that one could measure and include in that data matrix. The same for geopolitical action.
My comment is related to what Chris said at the end, depending on the context, how you model the micro foundations, because it seems to me that your framework would be great for a series of issues like global public goods or global policies where I have some ideal tie to my data and I would like everybody else to do the same thing as me. And so if I'm more similar, then when you go, I'm more similar culturally or historically, that's a good thing that also the others are similar to me. But in many other cases, it's quite the opposite. Countries that are very similar, who control Jerusalem, right? Or who should be in charge of trading? These are rival goods, but if I'm more similar, we have issues with oppression, I'm more likely to fight over it that I don't want you to do the same thing because it would be like, I want Jerusalem for myself. So it would really, and the third thing that is connected, I mean, between is policy, common policy. I mean, what can, if I wanted to follow my policy, like export policies and so on. So it seems that depending on the context, when you go to the similarity training or similarity, you might find very different outcomes for different data, depending on about private goods, it's about public goods, it's about policies.
Yeah, let me take these. I'm at capacity of keeping track. So first, thanks very much for the discussion. All great comments, especially like the offensive versus defensive statecraft interpretation of the influence. I do want to mention that some of the figure, so how important a country is, whether it's two hegemon versus a bunch of smaller economies, it depends not only on the network but also on the issue. For some of the counterfactual figures where we're showing where we perturb preferences, the US has more freedom to express its own interests and China influence others, that's on the US-China divide. That's the starting point where we perturb preferences. If we start from a different divide, say India-Pakistan conflict, maybe US is not the country that shaped actions the most. So I think that's a feature that we should highlight more in the paper, but great. I think it's important to highlight that in the paper, and we're not doing that enough. We are indeed thinking about a dynamic version of the paper, where this period's influence shapes next period network in some ways, and that's in the works as a follow-up. Emily's question on separability. So I think the language in the poli-sci-IR literature is issue linkage. That is, you have many issues that are jointly negotiated on and taking action. So we have not analyzed that case in this setting, so we don't have much to say about that, but that would be a good direction to explore. I agree. My co-authors feel free to, yeah.
Just to add to that, we do have some correlation in the sense that the network is the same across the issues, and so there's a lot of built-in, some implicit correlation there, and then more generally one could think about developing that further to do.
Yeah, one can do this exercise in more refined ways in thinking, there's one network on climate issues, there's another network on different set of issues. So for different issues, network may themselves look differently. That would be another way to fine-tune the exercise we do. On your point about similar countries on some issues may even more likely to diverge, that's built into the model as well, in the sense that we're not requiring that countries that share preferences must be more strongly connected. We're saying the set of cleavages that the preference covariance is formed based on are the set of underlying bases for the network, but the loading can be negative, can be weakly correlated. So in that sense, similar countries may have very different preferences, or connected countries may have different preferences, and so on. That's allowed in the network. It's just that empirically, when we recover, when countries, intuitively, what identifies the network is if we always act very similarly, even though our preferences are not very similar, then the model says you must be very connected, directly or indirectly. That's the identification, but there's no restriction built in. So let me take a few more questions. Yeah.
So obviously, I follow the mathematical structure of the game. Obviously, these linear quadratic games are very, they're very versatile. In fact, they work with the oligopoly version of this game. Now, one usual criticism of this class of game is that they're static, right? And so, in a more realistic geopolitical environment, you have issues of credibility, reputation, the ability to make credible threats. And so it's more of a suggestion, but one way you could incorporate that in your setting is the way we do it in oligopoly games, you have the Stackelberg dynamic. So you allow one player to move first. And so that's, for example, one way you could incorporate hegemonic rules. So for example, China and the USA are able to move first. And so then you can study, for example, what happens if you remove credibility from the US. More of a suggestion than a question.
Yeah, that would be an interesting extension. In keeping the one-shot games, so we are working on an extension where the network actually evolves. That's the dynamics we've been focusing on. In keeping this one-shot game structure, there are various extensions that are interesting that's been exploring other types of linear quadratic games. One would be Stackelberg moves. In this multiplayer context, you can also think about a group of countries coordinating on their actions. A subset of countries form an alliance and collude on particular issues. That would be interesting too. Those are the things that we could explore more, we haven't done.
Just quickly related to that, even in the static setting, there's a sense in which we have a feature which is similar to an endogenous network, which is the endogenous omega. In some ways, you could alternatively think about that as investing to change the network. There's kind of a conceptual issue that the strategic influence is kind of like an endogenous network because you've got this rich set of bilateral investments you're making
let me take a few and I'll answer.
It's even about the measurement. So you use the VDAM to think about preferences. So maybe it's semantic democracy levels themselves are some facts like cultures of influence. So of course, when you give aid or you have loans, typically there are some preconditions that countries are going to be democratizing. So maybe potentially using the World Value Survey to get deeper preferences. So that's one.
Okay.
So I have a couple of questions. It's a really interesting because of many questions. But the G being symmetric versus asymmetric, I think in your asymmetric extension, you make G scale as a country size or country sum metric. I wonder whether that's could be more heterogeneity in that. And second thing is like some issues I might care and my friend doesn't care, right? So in your case, even if I don't take this stance, I'll be punished. Is there any, can we think of some heterogeneity to add to that dimension? For example, I'm Israel, I care about Jerusalem, but I'm friend of Israel, but I don't have a particular issue. So it's going to be easy for me.
Yeah, let me answer this first. I'll go back to these two and take.
Ernest, can you just take like a minute or two to respond?
Yeah. Okay. So, well, the results rely a lot on a property called spectral decoupling. That is the set of eigenvectors shaping covariancing actions is the same as those shaping covariancing preferences. To get that spectral decoupling, one has to impose some restrictions on the degree of asymmetry. What we have is a form of quasi-symmetry. That is, we start from a symmetric network, but allow one vector to be the source of all asymmetry. That's fully handled. More generally, the spectral decoupling would fail. So you can still do all the theory parts, but taking to data would require a different identification strategy. That would be much more complicated. The second is an interpretation question. I think that's fully consistent with how we are viewing things. So we are saying there's one network where you want to coordinate with your allies, but you can draw different issues. There will be issues where your ally cares very strongly about, you don't really care about. But if that issue gets voted in the UN, or if your foreign minister have to go to the press and say something, comment on the issue, you may not care about that issue, but you may still want to support your ally and coordinate with the ally. So that's fully consistent with this setting. On the measurement, World Value Survey, we have to think about whether that's feasible in this particular setting, but that's a great suggestion. In terms of interpreting actions, the model is deliberately reduced form, actions and preferences, because we think the underlying economics represented by this reduced form representation can be fairly broad. You can think about sanctions, military actions, versus, when we go to data, the systematic data source of capturing a panel of cross-country actions, that would be a UN voting. So that's the data that enable us to do this empirically, but we feel the model can be interpreted a bit more liberally.
Great. I think we have to take the rest of the questions over coffee, so thank you so much.
Thank you.
And we'll be back at 10:15 for the next paper.
Put Colombia.
Thank you.
Okay, please take a seat.
All right, everyone. We are very excited to get started with the second paper here. And Tim is going to tell us about hegemonic competition with carrots and sticks. You have 30 minutes.
Okay, perfect. Thanks a lot for having me. So I'm Tim. I'm still at Kiel and Bonn and moving to Columbia and UT Austin. This is joint work with Nicholas, who is sitting over there. He's at UBC and he's going to be on the job market this year. So this is a paper about hegemonic competition. And that's, of course, a topic that's very much on the rise these days. Indeed, since 2018, great power competition has become the primary focus of U.S. national security. What's meant by that is very clear. It means competition with China is now seen as the main geopolitical adversary of the U.S. But as all of us know, in the world there's not just China and there's not just the U.S., but there's many other countries who are deciding on their geopolitical alignment. And the alignment that these countries choose matters. It matters for flows of international trade, for flows of international finance, and of course, ultimately, alignment matters for questions of national security, for example, in times of a war. So perhaps, therefore, both the US and China have been trying to actively influence the alignment of other countries using economic carrots and sticks. In terms of carrots, some of you might know that China has become one of the world's largest foreign aid donors, and there's now considerable concern about the policy influence that Chinese foreign aid might have abroad. And in terms of sticks, on the other hand, we're now seeing sort of administrations repeatedly sort of threatening other countries with sanctions, export controls, other forms of economic coercion for geopolitical purposes. So these are the policy instruments we want to study in this paper. We're going to ask how effective these are at achieving their geopolitical objectives and how they interact with one another when two hegemons compete. Now, these are very challenging questions to answer, and they're especially challenging to answer as this competition is unfolding in real time. So what we do in the paper is we take a step back, we're going to provide some theory, we'll provide evidence that's based on the Cold War, and then at the end of the talk, I'm going to come back to the competition between the US and China. So we answer these questions then in 4 steps. So at the start, I'll have a very simple model in which two competing hegemons use both direct payments, that's going to be the carrot, think of foreign aid, but also economic threats of sanctions, that's going to be the stick, to influence other countries. The key object in that model is going to be a reaction function that describes how these small countries choose their alignment in response to the carrots and sticks wielded by the hegemons, and that's what we'll try to estimate in the data. In the second part of the paper, we then bring data to estimate this reaction function. So we first measure the carrot as US and Soviet economic and military aid provided during the Cold War. We're then going to measure the stick using a model of international trade where it can calculate how much each hegemon can pressure other countries. And we're going to measure alignment as a standard, sort of same data as Ernest was showing you, using voting at the United Nations. In the third part of the paper, we then estimate this reaction function that's at the heart of the model, and we estimate the parameters of this reaction function. We do so using an instrumental variable approach. What we find here is that these geoeconomic tools work, but they're relatively expensive. So, for example, if you take a country that's initially neutral between the Americans and the Soviets, and you double foreign aid to that country that costs $120 million on average for the US during the Cold War, you only move that country by 2.5% of a standard deviation. That's only 1% of the geopolitical distance between that country and a NATO member. So you can move these countries. It just ends up being very expensive. Finally, at the end of the talk, I'm going to come back to the modern times, and I'll speak a bit sort of to the competition between the US and China. And in particular, since we estimated this reaction function, we can also do some counterfactual, like in Ernest's case. What we'll do is we'll study what might happen if the US cuts its foreign aid budget, as seems to be happening right now. We study first the Chinese reaction, and second the reaction of alignment in the rest of the world. In terms of the Chinese, we find that they're projected to decrease their own aid in most countries because influence becomes cheaper to buy. And in terms of global alignment, we find that there's a small shift away from the US, so we don't find these large effects. So it's not that the world order is changing, but potentially allies of the US are moving more than adversaries. So the paper contributes to a number of strands of literature, most importantly, of course, why we're here, geoeconomics. What we're trying to do with this paper is we're trying to provide some quantitative evidence on how effective these geoeconomic tools that we're sort of studying in many papers actually are. That sort of allows us to answer sort of empirically, as we see the world economy shifting, as hegemons are taking different policies, what consequences might this have for how the other hegemons are responding, and what the consequences might this have for geopolitics. Of course, there's also literature on foreign aid that sort of thought about these questions before, and there's a literature on the economics of the Cold War, and there's going to present a nice paper sort of doing similar sort of data, sort of leveraging that setting to understand how geoeconomic competition might play out. So let me start with sort of a simple model. I don't have time to cover all the details and sort of want to get more into the data, but I'll sort of give you the rough outline of how we think of the world and what we're going to take to the data later on. So we're going to think of a world with two types of actors, hegemons and small countries. So there's going to be two hegemons, the Soviets and the Americans. They're going to be using carrots and sticks. What those are comes on the next slide. All the variables respective to the Soviets are have a star on them. There's also going to be a small collection of small countries indexed by I, and these countries are going to choose their geopolitical alignment on the unit line, so they can live all the way with Americans at 1, they can live with the Soviets at 0, and they can live anywhere in between those two. In the background, we're going to think of a standard trade model following sort of Armington, and that's going to sort of be describing the economic environment. Within that setting, we're going to think of a two-stage game. So in the first stage, hegemons make payments and threats to the other countries. What those are comes in a second. In doing so, what the hegemons care about, we assume, is they maximize the weighted sum of alignment of other countries. So here this is written out for the US, so they like it when other countries move close to them. And they don't like paying other countries, and they, of course, don't like, if they were to impose sanctions, they also don't like imposing sanctions. So here, sort of these VIs are sort of the importances of different countries. There's our sort of exogenous, and we assume those are sort of primitives of the hegemon's preferences. Similar, in the second stage, countries move, and they choose their alignment given what's on the table, and they have some preference pi that they sort of balance against economic gains and losses, and then they're going to choose an alignment between the Americans and the Soviets. A bit more in detail, how do these tools work? So for the threats, that's the stick, we're going to allow hegemons to make tariff threats. That's the tariff threat for the Americans. And these tariff threats are going to specify to countries that if they move too far away from a hegemon, they're going to be hit, and they're going to get sanctions. So in this is a one-shot game, so if you sanction as hard as you can, so this is sort of an infinite tariff. So full exclusion of trade with a hegemon, no more imports, no more exports. So for example, like last week, Trump was saying, we'll cut Spain off of trade, and this is that. So it's an important primitive of this model is sort of how much these countries would suffer if they were hit by that. So that's what we're going to define as the power of a hegemon. It's just how much countries would lose consumption if a hegemon were to punish that. You can think of that as being the size of the stick of a hegemon. We then solve for the sort of the optimal threats, and we show that the optimal threat depends on the difference in the power between these two hegemons. So the way you can think about this is in a game with a single hegemon, the hegemon takes away all the surplus from trade from these countries, but now if there's another hegemon on the other side, you can't take away all the surplus, but only the surplus you have in excess of the other hegemon. Second, we're going to allow hegemons to make payments, and this we're going to model following the applied literature on corporate lobbying using a context. And this is going to give us a set of best response functions of the hegemons to one another. So this is the best response of the Americans to what the Soviets are doing. So you can see if the Soviets are doing very little, it's optimal for the US to do very little. As the Soviets ramp it up, the Americans ramp it up as well. But at some point, if the Soviets keep pushing, it becomes too expensive to compete, and the US throws in the top. Similar for the Soviets and the sort of intersectionist equilibrium, here everything is drawn up to be perfectly symmetric. Doesn't need to be the case in the paper, of course. And what we also do in the paper, I don't have time to go through this today, is sort of testing the shape of these response functions and how they align with the data. Next, we set everything up so that we can solve the reaction function of these countries in closed form, and we can write the alignment that these countries choose as a function of their preference pi, how much each hegemon is paying them, where beta and beta star is how much you like money from the Americans and the Soviets, and the difference in the power of the Americans and the Soviets. So this is the reaction function. It looks like a regression, and that's a regression we'll estimate in the data later on. Now let me tell you how we get this to the data. So we get this to the data using the Cold War as an example. And the Cold War is, of course, a nice setting to think about these questions because it's a setting where there was not much direct interaction between the two hegemons, but there was direct interaction between the hegemons and other small countries. So it's a setting where the alignment of these countries matter. So ultimately, of course, on the sides of both hegemons, there's a sort of an existential fear that these countries would slip to the other side, and there could be sort of guns pointed at you from these countries. We also know that the main geoeconomic instruments that these countries were using during the Cold War were aid and trade. So this we know both by reading the classified reports from the CIA, but also by sort of consulting the contemporaneous literature in international relations at that time that sort of writes as these as the main instruments of economic statecraft. So this is what we're studying today. So what historians call the real battleground of the Cold War is the competition of these two hegemons for influence in small countries. Here's an example of what these countries were doing. So this is the Aswan Dam, which is sort of this big dam that the Americans built in Egypt during the 1960s, and the Soviets built it, and they made very nice posters of it trying to influence that country. So in contrast, the Americans don't stand pat. So when the Soviets built this dam, it threatens to flood these temples at Abu Simbel. So they have to move, the temples need to be moved, and the Americans end up paying to move these temples to sort of ward off the Soviet attempt at influence. So these are the kind of things we want to capture, at least in the data. So here's the data we're going to use. First, we're going to measure carrots. So this we're going to measure as economic and military aid provided by the US and the Soviet Union. So for the Soviet Union, the nice thing is that during the Cold War, the CIA was actually collecting this data, and the CIA was sort of tracking in which country were the Soviets sending their money, and here's a snapshot of this data. For the US, this is relatively straightforward to get from what's called the Green Book, and that's the standard source for US foreign aid. So here's a snapshot of this data. So this is for all the countries that the CIA calls non-aligned countries. They have a list of countries which they're tracking. And what I'm showing you is for every country, averaged over the entire Cold War, how much money comes from the Americans relative to how much money comes from the Soviets. You can see there's lots of variations. Some countries are very blue, you get mostly from the Americans. Some countries are very red, mostly from the Soviets, but there's also many countries which are kind of pinkish. So think of Egypt or India in this kind of chart. They sort of get money from both sides, as sort of I was showing you with this example. Just in terms of the economic size of these flows, I mean, we compare them here to GDP. So there's many concerns you have in terms of valuation and the measurement of GDP in these countries. So take these numbers with a grain of salt. But these are very large capital injects into these countries. So for the average recipient, this is around 2.5% of GDP. So to first order, this is likely the main capital inflow into these countries at that point in time. Next, we're going to measure the stick, or the size of the stick. So what happens in our model is that no country gets punished because these punishments are going to be off equilibrium, but we can measure how much each hegemon can threaten the country. So this is what we do using the model of international trade, where we can compute how much each country would suffer if a hegemon were to punish it with sanctions. So that's like a trade dependence measure in a sense. And we're going to use the trade model to sort of obtain the counterfactual consumption these countries would have if a hegemon were to punish it. So here's the power of the Americans. You can see that this looks kind of like you would expect it to look. The US has lots of power over countries in the Americas and Latin America more generally. Less power if you get further away, just because there's less international trade with these countries at that point in time. The opposite kind of holds for the Soviets, where there's more power in the Middle East and in Eastern Europe, where they're more closely connected to the Soviet Union. On average, the Soviets, of course, have less economic power than the US, just because they're sort of a smaller economic hub than the Americans. Finally, let me tell you how we measure alignment, so I don't have to say that much because Ernest was using something similar. So we measure alignment using voting at the UN, using the standard measure from Bailey's Chestnut voted, so this is all off the shelf, which is just for those of you who don't know this measure, this is sort of a unidimensional measure out of all the votes cast at the UN. So we think of one way of thinking the alignment that these countries choose is, there's many actions, some they vote yes, some they vote no, and this is sort of the average action they take, and this is what the average alignment that these countries choose. So it is a reasonable measure of alignment. So in the paper we do some validation. We do some qualitative validation going through case studies. We do some quantitative validation comparing, for example, does it predict whether you attend the Olympics? But I think the easiest way of validating is this plotting. So what you can see here is this measure plotted for the Soviets and their allies in red, the US and NATO in blue, and all the non-aligned countries from the CIA list in gray. And you can see it sort of recovers the central cleavages of the Cold War. So you have the US bloc on one side, the Soviet bloc on the other side. You have the non-aligned countries sort of moving in between those two, which is sort of what you would want from a measure of alignment at that point in time. And it sort of comes out of this UN voting, so this is sort of relatively reassuring. Now let me tell you how we estimate this reaction function, which is sort of the heart of the model. So we actually have a similar chance to what we had in the last paper. So we have this reaction function, which describes the alignment that these countries choose as a function of preferences, how much each hegemon pays, and the relative power of each hegemon. So like in Ernest's paper, we observe the alignment of these countries. We sort of observe how much hegemons are paying and how much they can threaten. That was the data I was showing you, but we don't know sort of the preference. So we don't know what Ernest was calling theta and what's here pi. So that's sort of the key unobserved, that's key sort of threat to identification. And so this is what we'll try to tackle using instrumental variables. We have some strategies also actually more similar to Ernest, where we sort of control for the ideology of the leader, where there's some left-right wing classifications, which you might take of a measure of pi. But primarily I'll show you today an instrumental variables. There's of course other identification concerns you might have. There's measurement error and all these things. This is not a complete description of geopolitics, of course. So there's other tools that are moving around simultaneously. So we estimate this in a standard panel regression using country year fixed effect and year fixed effects. We're going to measure aid in per capita units to account for the size of these countries and control for slow-moving trends, because that's sort of going to help with the regional identification we're going to pursue. And I'll show you the instruments in a few seconds. Here we're going to impose the same coefficient on the power of the Americans and the Soviets that's sort of related to the instrument we'll use. It's going to be collinear between the Americans and the Soviets. So we cannot, at least in the IV setting, identify the effects of US and Soviet power separately. So this is just the OLS regression. So here positive values mean more alignment with the US. And things sort of seem to go the way you would think they would go. If the Americans give you more money, you tend to move that way. If the Soviets give you more money, you also tend to move that way. And so similarly, as the Americans become relatively more economically powerful. So these are sort of associations you would expect. You can also run this dynamically. So this is, like many of these models, it's a static model, but at least in the data, we can sort of do dynamics. So here we run this as a local projection. And what we find is that these sort of dynamics are at least relatively short. So you're not moving countries persistently over a hump and then they sort of fall into your camp forever, but rather after 3-4 years, they sort of go back to the original alignment. So then let me tell you how we sort of try to tackle these identification challenges, which are of course very thorny because it's sort of very hard to get something that sort of responds not to the preferences of these small countries. So for the carrot, we're going to think through the lens of the model. So of course, in the model, how much each country is paid is endogenous. It's a choice by the hegemons. But the choice depends on how much hegemons value different countries and the preferences of these small countries. And so ideally, what we would like is like some shock to the preferences that hegemons have for the alignment of other countries. So we would like some sort of political turnover in the hegemon that leads the hegemon to reallocate money, not related to something that's happening in the small countries. So we're going to try to approximate this as best we can using a shift chair instrument, which leverages that countries are differentially exposed to regional fluctuations in foreign aid. So this instrument is constructed as the average flow to a world region that's been going to a particular country in previous years, and the total flow to that region. So here the argument is sort of that hegemons have some sort of budget allocation, which sort of sends money across different places of the world, and then as these budgets are raised or lowered, some countries are treated more by that than other countries, and they're not sort of doing these budget reallocations in response to shocks in these small countries. So we go through in the papers some checks on these shift share instruments. So for example, one thing we do is we provide some narratives, at least for Latin America, where we sort of show that the major shifts are sort of linked to changes in the US administration. So for example, in 1969, it's a big foreign policy shift under Kissinger, where it's sort of like a big cut of foreign aid to Latin America as US priorities shift towards the Pacific. We also have like an event study for Jimmy Carter, where sort of Jimmy Carter cut aid to Latin America, and then we sort of compare the alignment of different countries. So that's the instrument for foreign aid. For the stick, that's sort of the trade independence of our different countries, we're going to rely on the literature and trade and history of my work with Steve and co-authors. It's done similarly, and using a time-varying gravity equation, we're going to predict flows of international trade between different countries using changes in the cost of air versus sea distance, and we're going to use that predicted measure of international trade that depends on technology as an instrument for international trade. You can see this is going to be collinear between the Americans and the Soviets, because as you move closer in predicted distance to the Americans, you move further away in predicted difference to the Soviets. So you might think, there's other things that sort of responding to these changing costs of air travel, like measures of cultural exchange. So we've checked this a bit in the paper. So the CIA was also collecting this data on, how many students do attend Soviet universities. We can same data for the US. And so we find that these sort of respond differentially to these measures of air and sea distance costs. The way we interpret this is that during the Cold War, the main way of exchanging across countries was sort of using international trade, not so much the movement of people. So let me show you the OLS, and then we'll go through the instruments. So here's the OLS regression. When we sort of instrument the US foreign aid, we sort of find that the coefficient gets slightly larger, doesn't move that much. Similarly, as we instrument Soviet foreign aid, as we instrument these power differences, sort of there's a bigger change of coefficient that's normal in this literature, and the sample shrinks a lot because you can, of course, only do this for countries that are on a coastline. So we also have some weak instrument robust inference for us, if you care about that. And finally, we can instrument everything simultaneously, and this is sort of the coefficients we're going to use. So these estimates are not very precise. They're relatively noisy. We think of UN voting as like a noisy proxy of the true alignment of these countries, and so you wouldn't expect these coefficients to be particularly precise. Going to Ernest's paper, so we have some sort of low-tech version of network regressions as well, where we sort of impose that the network is proportional to trade integration and sort of distance. And so we do find some network effects as well there, but they sort of tend, at least in our regressions, tend to be smaller than these direct effects. Now, what do these numbers mean? These numbers mean you can move alignment using economic tools, but it's relatively expensive to buy alignment. So for example, we find that doubling foreign aid, so that's $120 million on average for the US, moves that country by only 2.5% of its standard deviation. So that's kind of like raising the odds of you boycotting the Olympics by 5%. It's 2% of a Pinochet coup, or 1% of the geopolitical distance between a neutral country and an incumbent. So you move these countries, but it's very expensive to move these countries very fast. Similarly, you can move these countries by making them more dependent on you relative to their dependence on your rival. And so to get the same shift in geopolitical alignment, you can move a country, so you need to raise your power of that country by around 5% of Mexico's dependence, so around 3% of total trade to GDP. Of course, this is going to be preferable from the perspective of a hegemon, because these payments are sort of costly, whereas these threats are going to be off path, so you can sort of move these countries without actually having to carry out the sanctions. Now, are these results reasonable? So the first way of comparing this is to literature and political science that's estimated similar regressions before. And we sort of set the model up to have the exact same sort of specification that these people have been running, and sort of these values that we find are very much in line with what political scientists have found, at least in more modern data. It's relatively hard to shift alignment, at least measured using voting at the UN. But it's also consistent with sort of narratives of historians of the Cold War that sort of are arguing that as the Cold War unfolds, both the US and the Soviets, they start these very expensive adventures in many countries, so there's massive amounts of money poured into Egypt for all these dams and so on. But these countries sort of end up shifting relatively little. So it's none of these countries ever becomes like a NATO member. So even in the Cold War, according to historians, these policies were relatively unsuccessful. Finally, so if we've now set up the model, we've sort of estimated the reaction function of these countries, and we can use that to speak a bit to the present. Concretely, we're going to talk about the shutdown of USAID, which sort of happened last year in February when sort of the US started cutting most of its development aid. And of course, there's major concerns about the implications this might have for global welfare, for global health, but potentially also for global geopolitics. What we're going to do is we're going to extend all the measures we have to the present. So that's become a lot easier to do now than during the Cold War. So for sticks, we can run the exact same trade model. For carrots, we can rely on the same data for the US and the 8 data for the Chinese. And for alignment, we can use the same measure of voting at the UN. We're then going to calibrate this reaction function using the historical data. So that's some extrapolation that, of course, these sort of values of the reaction function are the same, but given a, sort of an absence of better data, it's sort of the first place to start. Given that, we're then going to evaluate the USAID shutdown. This involves 2 steps. So in the first step, we're going to study how does China react. So remember, we had these reaction functions, which were sort of a bit curvy, and we're going to sort of shift around the US function and see how China reacts. In doing so, we're going to sort of hold the preferences of these countries, the importance China places on different countries, and the power fix. You could let things vary as well, but sort of for baseline, it's easiest to see when you hold this fixed. And then finally, we're going to study how alignment reacts. So first, when it comes to the Chinese reaction, that's probably the most interesting part. So for China, there's 2 considerations. On the one hand, that the US is gone, it's become a lot cheaper to buy influence in these countries because you don't have a competitor anymore. But on the other hand, of course, now that the US is gone, you could step in and you could call all these countries to your side, and at least directly after the USAID shutdown, there was lots of concern that this is what was going to happen. So through the lens of our model, this is not optimal for China to do in most countries. So you can see here what's the predicted Chinese reaction in most countries, and you can see in most of the world, especially in Africa, where most of Chinese aid is concentrated, and the Middle East, China's actually predicted to decrease its foreign aid by around 10 to 15%. So there are some parts of the world where they increase. It's usually Latin America, Eastern Europe. What's sort of driving these differential responses is that these countries in Africa are initially already more aligned with the Chinese. So there this motive of you can push these countries to your side is not very strong. Is this reasonable? So you can compare this to the end of the Cold War. There's some evidence that at the end of the Cold War that Americans also sort of decreased their foreign aid budget, especially to strategic countries, because there was sort of this absence of a competitor. And you can also, there's some preliminary work from colleagues at Kiel where they study the Chinese reaction to the USAID shutdown, and they find a very muted reaction, at least. So we read this as not being inconsistent with what we find. Finally, what happens to global geopolitical alignment, we find that it goes down with the US, so that's not surprising. Nothing else can happen in the model. But it goes down relatively modestly. So by only sort of 15% of the distance between France and Turkey in terms of geopolitics for the average country. The countries that move the most, of course, are countries initially more aligned with the US. Finally, you can ask the model, sort of, can you offset this loss of influence through foreign aid by sort of tightening the screws a bit more, by increasing your geopolitical power? At least through the lens of the model, we sort of need very large increases in geopolitical power. So we really need to tighten the screws a lot, in a sense, or increase trade dependence of countries to offset this. Perhaps we can do this in Latin America, where this is sort of, countries are very integrated with you. It's very hard to replicate this in countries in Africa, which at least in trade data are not that reliant on these. So let me close here. So this paper was sort of the first attempt to take these big geoeconomics models and put them to the data, to allow us to speak quantitatively. Are the effects of these geoeconomic instruments, big or small? What can we expect as countries are changing their geoeconomic instruments? What we find is that from the perspective of a hegemon, the geoeconomic tools that these country hegemons are using work. But they're relatively expensive. It's hard to move these countries geopolitically. From the perspective of small countries, there's some results in this paper that suggest that competition might not be that bad, so you can be less coercive and perhaps you can extract some payments from both sides. When it comes to the US and China, at least what our model suggests is that sort of the rise of China in global trade might be a lot more powerful than China's rise as an aid donor, just because it's a lot cheaper to influence countries by threatening them than by keeping to pay them all the time. And there's sort of these dynamics of a competition might be a bit unexpected. It's not the case that when one hegemon backs away from competition, the other hegemon necessarily steps in. So with this, I close here, and I look forward to the discussion, and thanks a lot for your attention.
Our discussant is Alberto.
Okay. Thank you very much for the organizers for inviting me to discuss this very interesting paper by Tim and Nicholas. So let me start by saying this is a paper about how should non-aligned countries navigate the world of hegemons, and how do hegemons influence the behavior of these countries. So let me start with a picture here. This is Juan Perón. He was president of Argentina, late 40s, early 50s. And he was one of the founders of these non-aligned movements, and he had a wonderful phrase. You don't need to understand Spanish to understand it. He says, ni yanquis ni marxistas, peronistas, okay? So basically, how do we stay away from these two poles, and you know, how should we navigate this world? So this paper does exactly that. It asks itself, in this world, how do hegemons shape the behavior of these third countries? In particular, how do we use sticks and carrots, so rewards and punishments, to shape the behavior of these countries? And the paper does basically a couple of things. Basically, it has a simple conceptual framework. It takes then the framework to Cold War data. And what do we learn from this paper? Well, there's two key findings I took from it. There's many findings, but there's two key findings. The first one is that, yes, it seems that this third country alignment was affected by sticks and carrots during the Cold War. And the second one is that we can infer from this that hegemons valued this alignment highly. Okay, so just to put the thing in context, because some of my comments have to do with that, let me tell you quickly what the setup is. The setup is a country that chooses a continuous alignment action between 0 and 1, 0 here being the USSR, 1 being the US, and I maximize a welfare function like the one that you see over here. So I have this phi component that is decreasing in the distance between my actual action and my bliss point. They call it this A bar, what I would like. So I don't want to take actions too far from my preferences, but on the other hand, I also derive utility from the carrots. That's what you see there in blue. They can come from the US or the USSR. This is like a transfer. And from the sticks, these are the tariffs that you see there in red, also from the US and the USSR. Okay? Now, there's two assumptions I want to point out. I will come back to. The first one is that tariffs are either 0 or maximum. So we're either in free trade or they cut bilateral trade with the hegemon. And their definition of power indeed is based on these sticks. So power is measured as the difference between what I would get in terms of consumption in the baseline, say with no tariffs, versus what I would get in terms of consumption if I was excluded from trading with the hegemon. The second assumption, transfers, they give to me, these are the carrots, they're continuous, and actually one thing they assume is that they affect my bliss point. Remember, that's the thing I want to be close to. So my bliss point depends on some preferences that I have, but they're affected by the carrots. When I get money from the US, my bliss point moves towards the US, and vice versa when I get money from the USSR, okay? So that's the perspective of my country. I'm getting these carrots and sticks, and they're affecting my alignment. What are the hegemons doing? Well, you have it there. That's the US and the USSR. So they're basically saying, I want to bring, if I'm the US, the A's close to me. I could have specific valuations for each country. That's the new that you see there. But giving the carrots is costly, and also using the stick is costly, because when I use the stick, I don't trade, and so also the hegemon loses something. Okay? So this is the game. And what's the definition of equilibrium here? Well, the hegemons will choose carrots and sticks. and countries will choose their alignment such that we're maximizing all of these objects simultaneously. One thing to note is that the tariffs here, as I already mentioned, they're going to be looking at kind of threshold or cutoff strategies where they're either zero, if your alignment is close enough, but they jump to this outer key if you don't align beyond a certain threshold. Okay? So what are the key predictions of this simple framework, just to organize the data? First of all, my alignment, if I'm a country in the middle of this world, should be increasing in the carrots I get from either side and should be increasing in the size of the stick that they can use. Okay, so the bigger the sticks and the carrots, the more I should align. Second of all, how many carrots should the superpowers give me? Well, that will depend on how much they value my alignment, on their valuation of my alignment. Third of all, the carrot that the US gives me is non-monotonic on the carrot that the USSR gives me. Initially they increase, but at some point if the USSR is just giving me too many carrots, too many transfers, the US gives up, and then the transfer begins to fall. Okay, so that's the idea. Now they take this simple framework to the data. They use Cold War data. What are the carrots here? Tim explained it. It's kind of official flows. They take them from US sources for the US. They take them from CIA data for the USSR. And actually an interesting thing is that these flows were quite large. So about 1.5% of GDP for the average country during the Cold War, 55 and 85. What are the sticks? The sticks are model-based estimates of gains from trade, essentially. So what would happen if the US or the USSR cut me off completely from bilateral trade? What would be the loss? So that's what they estimate. These are larger for the US because it just traded more. And then the alignment is basically UN voting. It's this ideal point measure based on UN voting. Okay? So what are the key findings? They're here. First of all, like the simple conceptual framework would suggest, alignment does seem to be correlated with both carrots and sticks during the Cold War. Number two, you could think, is this causation or not? They have a kind of compelling IV approach. So for the carrots, they use shift share type of instrument. Imagine the US suddenly decides in this Progress for Alliance to give a lot of money from Latin America. I take what was my previous share of aid I received from the US in Latin America. If I'm, say, Uruguay, and that's a kind of exogenous increase in aid to Uruguay, I see how that changes my alignment. For the sticks, they use change in transport costs as an exogenous shock to bilateral gains from trade and therefore to the size of the stick. Okay, and the results survive. Once we've established this, we can use the model to back out hegemon valuation of alignment of different countries. I mean, given that I'm giving these carrots and given that I see the change in alignment, how much am I valuing it in order to pay that much? And finally, they have an application, which is the one Tim discussed, which is what do I get from eliminating US aid? If the US decides to eliminate US aid, how does China react to that? Okay, so anyway, it's a great paper. It was very interesting to read. Also, as I was telling Tim, I prepared my discussion last night. I've never been happier preparing a discussion after the game of Argentina, so I will forever associate your paper with that wonderful victory, okay? So anyway, and I think it makes a compelling case that both the sticks and the carrots affect alignment. So I'm going to have three general comments. I actually have a fourth one, which I forgot last night in the celebration, so I'm going to add it in the end. But three general comments. One about the conceptual framework. How do we think about carrots, sticks, and powers? And the two other ones, they don't really challenge the results, which I kind of believe, but I want to think a little bit about the interpretation of the findings that they have. Okay, so the first one is about the conceptual framework. One thing that I found a bit odd about the simple framework, which is very natural, is that it treats carrots and sticks very asymmetrically. Okay, so we think, for instance, official flows are carrots, tariffs are sticks, and you think why? Why should an instrument be identified as a carrot or a stick? In the end, they're two sides of the same coin. So I can think I have a basic tariff vis-a-vis the rest of the world. If you misbehave, I'll raise it, and that's a stick, and if you behave, I'll give you a better deal. That's a carrot. Okay. Likewise with official flows. I can give you official flows at some average terms. If you behave, you'll get a subsidy. And if you misbehave, I'll, whatever, tax it. So I'm not so sure why you would want to have this identification of instrument to be either a stick or a carrot. The second one is they're also treated asymmetrically as a source of power. As I told you, in their framework, when they talk about power, they're really thinking only about the stick, only about the tariff. They're saying, what does it mean for me to be powerful vis-a-vis any other country? Well, if I push you to autarky, what do you lose? But you could take a broader definition of power. If you look in the dictionary, it tells you, I have the control or the ability to influence others. I would add also at low or reasonable cost, because if I can influence you, but I need to shoot myself to do that, well, maybe I don't have that much power. If I can do that cheaply, maybe I have more power. So you could think transfers are also a source of power. And I don't know why you don't think about them this way. So imagine I have two superpowers. One is wealthier than the other one is more constrained than the other one. Presumably this happened during the Cold War. Towards the end, the USSR was suffering. Well, it will be cheaper for one superpower to make big transfers relative to the other one. And so you could argue it also has more power, even if the size of the stick were the same. Okay? And the last one is the way they're introduced in the framework. Sticks and carrots also affect things differently. Sticks affect incentives. So I'm deciding, should I align or not? Well, I could be punished. But carrots affect directly the preferences, the way they model it, because this bliss point, that's my reference point I don't want to be too far from, that's directly affected by the carrot. And that I found also a bit not very natural. I'm not sure why you wouldn't just model, I have my own preferences and both sticks and carrots affect my choice, okay? So this doesn't matter much for what they do empirically, but I'm just saying as a conceptual organizing framework, I'm not sure sticks and carrots should be treated so differently when I think of this world, okay? Now, let me go to two of their main results. The first one is that alignment changes with the sticks and the carrots, as I told you, but I want to focus here on the sticks. So the one main finding is that when my bilateral gains from trade vis-a-vis the hegemon are high, well, I tend to align with the hegemon. The interpretation of the paper is that this is like brute force power. I will sanction you somehow unless you align with me, okay? In their framework, I guess these sanctions never happen. They're all off equilibrium, but it's the shadow of the sanction what's leading me to align. Now, that's one possible interpretation, but there's an alternative mechanism, which is, well, alignment is a tool to reap part of the gains from interaction or gains from trade. So, for instance, we have this paper with Christoph and Fernando Bronner and Josephine Meyer, where one of the forces in the paper is that the more I align with other countries, the more are gains from interaction. You could think including trade. And that's a world where if my gains from trade vis-a-vis the hegemon are very high, naturally I will tend to gravitate to the hegemon and I will tend to align because that will reduce the cross-border transaction costs between us. So you could think in this paper what they're finding, you could think of this UN voting as an imperfect measure of alignment. And so what's happening is when our gains from trade are large, we tend to align. Now, is this a stick in the background? Or is this what I call here kind of soft power in the sense that I just want to align with countries with whom I have large potential gains of interacting? So once again, this doesn't question your result. It's just a matter of interpretation. Okay? The other cool result they have in the paper is that hegemons must value this alignment a lot. Okay? In fact, they get that, one of the figures they report in the paper is that the US would be willing to spend 3% of its GDP, so a huge sum, to shift Egypt from being USSR aligned to being aligned with the US. Now, where does this come from in the paper? Well, Tim explained it kind of. The reason where this comes from is that alignment, there's a statistically significant correlation between alignment and carrots, but the response is actually quite weak. And so the model tells you if I'm spending all this money to move the alignment of Egypt and Egypt is moving the UN voting kind of very little, it must be that I value that a lot. Okay? And that's where this number comes out of intuitively. Now, an alternative interpretation is that, of course, UN voting is a very noisy or not maybe the most relevant part of alignment. And actually, what I'm getting when I give money to Egypt is other things, military alliance, intelligence, military bases, etc. So UN voting is just a very noisy measure of this. and I'm capturing only a small part of what I'm getting. So it could be that that valuation is actually quite lower, but I'm inflating it just by focusing on UN voting. And to some extent, I think this must be true, because imagine a world where all I cared about was UN voting. Well, in this world, I don't care whether it's Egypt vote or Fiji's vote, because one vote is one vote. And so in that world, I'm not sure it would make sense to think that some countries are more strategic than others. Okay? And in fact, since I have 1 minute, this brings me to my last point, which I remembered this morning, which fits very well with the previous paper, which is the following. Here, everything is bilateral. So I give money to Egypt because I value Egypt's alignment, and Egypt's alignment is independent of Libya's alignment and of Algeria's alignment. So another measurement thing that may be lurking here is that actually by moving Egypt, I'm affecting countries close to Egypt, and that might also affect how I back out this valuation. Okay, so bottom line is I found it to be a very interesting paper, a great paper. I think makes a very compelling case once again that these sticks and carrots matter, that they moved alignment. And as I told you here, one thing, a few comments is how would you think about these carrots and sticks in a more symmetric fashion, and how do you really think about interpreting these results, these empirical results. Thank you.
Thanks so much. Tim, you want to collect some questions here? Steve?
Super interesting paper. I just had a few comments. On the A, I was wondering about arms sales. Another way the US exerts influence is over the F-16s if you agree to sort of be part of my coalition. And I know you have sort of military and economic aid, but it wasn't clear to me you captured all of those arms sales. That could be interesting, could be another sort of stick or threat that the US uses. And then I wonder whether your paper has implications for another area of economics, namely that the literature looking at the causal effect of foreign aid on growth finds it really hard to find big effects. Maybe part of the story is when I give you money, I'm not really giving it to help you grow, I'm giving it to buy power, and maybe projects that transfer resources into the president's pocket are good for power but bad for economic growth. So I wonder whether your findings have some implications for that. And then on the trade side, the effects of trade are quite subtle, right? I'm thinking about the Philippe Martin paper on bilateral versus multilateral resistance. I think you're doing GE counterfactuals where you cut these sanctions. I mean, the presentation went quick for me, but it could be nice to kind of tease out those conflicting effects of trade. You really want to create bilateral dependence versus multilateral dependence in terms of exerting power. That could be really interesting to tease that out. Super interesting paper.
Let's go Kristen, then Jaya.
Really interesting paper. I did one easy question and then one harder one. For the easy question, how lagged is the data on China lending and China aid? It'd be really interesting to compare your predictions to what has actually happened. And my guess is we're getting pretty close to having that data so you can actually see how it performs. The harder question is, your main carrot is aid, which is important in some periods, but some periods, a main way that the U.S. has shown support for other countries and try to get them in their block is not direct aid, but it's things like debt restructuring and other supporting bank money. Like with Pantomime, particularly during the era you focus on of U.S.-Russia competition, there was the Baker Plan in the 1980s, where main form of U.S. support was to basically use carrots and sticks for banks to restructure debt to give debt relief. And then the Baker Plan, it was debt restructuring, which was, again, the U.S. government was heavily involved, so it's not going to show up as your numbers as aid, but it was pretty substantial commitments that really did aim to build geopolitical support. So could you include some of that or extend that? You might be actually missing some pretty substantial payments that the U.S. made for this period.
So given that the USSR and later China are likely responding strategically to changes in U.S. aid flows, I think that the instruments you're using might be a little bit complicated in the sense that they're actually inducing variation not only in U.S. foreign aid, but also the rivals foreign aid, particularly since you have longer periods. So one idea might be to think of the relative instruments between the two hegemonic powers, inducing changes in the relative composition of the foreign aid flows by origin. And I have a suspicion that that's one reason why your local average treatment effect is on the small side, because your instruments are actually inducing the thing that they're also counteracting.
Okay, thanks also Alberto and to all the questions. I'll respond sort of first to some questions on the aid and also sort of to Alberto's discussion. So I've lost lots of sleep on how to model things, and there are some asymmetries which sort of help us get this to the data in a very elegant way. So if you do this like perfectly symmetric, you have like a function where if you move here, you get money. If you don't get money. What you end up having is in equilibrium, only one hegemon pays the country. This is sort of like, there's some papers which model like this, but it's not what we see in the data, so that's what we went with in the end, and sort of it can be microfounded in different ways. You can think about, like we have this in the paper, where you have multiple votes, you have 0 or 1, you bid on every vote, and then these countries sometimes vote with the Americans and sometimes with the Soviets. On Steve's questions on sort of arms sales, so these are in there insofar as they're sort of in the Green Book, which sort of would be a subsidized arms sale in some sense, which sort of, there's these aid flows are a bit tricky because, it's not like literal transfers, but they should be in there. Effect on aid and growth, it's well taken. I mean, if you just look at the allocation of foreign aid, if you would think this should support growth, it would all go to the poorest countries, but it looks very different. And similar to sort of the, Kristen, so China, and so we've sort of, there's some data trickling in right now. So I was talking, so there's a paper by Andreas Fuchs, Andrea Presbitero, and co-authors, which looks at precisely this questions. So they only see a small slice of Chinese foreign aid. What they see is very little response. So they find like mostly, which, one way of interpreting this is China doesn't care that much about alignment, but cares about, other things, for example. Other tools, debt restructuring. So it's a good suggestion. We should have that sort of, there's like a never-ending toolbox of IMF loans, and you can put more and more into this reaction function. We have specifications where, for example, control for lending by the IMF, which gets a bit at this, but yeah, we should get these other forms of making the transfers as well. And finally, Jaya. So if the other hegemon responds very strongly to what the US and the Soviets are doing, this would attenuate our effects, because we would see, oh, they're not doing very much, but really it's because the Chinese are pushing back or the Soviets are pushing back so strongly. So it's been a while since I've run these regressions, but at least when you correlate just, how much, where is the US spending with the Soviet spending, how correlated are they? They are somewhat correlated, but not that much. So it's not that when you see one country goes in, the other country necessarily goes in super strongly. Could be that they have lots of other things that they care about other than alignment. Should I go more questions?
Giovanni?
There is a recent paper by Eric Madsen and Andrea Bra called Competing Powers, where they have sticks and carrots. They model them in a more symmetric way. You may want to take a look at that. Could suggest, maybe just
Yeah. Max?
I would be curious about is whether the estimation of behavioral rules breaks strongly to changes, like those differences, as opposed to levels. So the fundamental of the world says we want to sort of bring people with a third level into our population. The other thing sort of breaks to the dwells direction. So that would be like
Mm-hmm. Lena?
Political scientist confession. There's a lot, I think, of talk going around about what it means to vote similarly in the UN General Assembly, and many of us use this measure, but I think we're also frustrated with really maybe not capturing alignment and sort of costly actions in the way that we would like. There are some papers by Dreyer and colleagues where they look at what they call horse trading in the UN Security Council. And they exploit, sort of the temporary rotating memberships to see whether or not that aligns with things like foreign aid, but also World Bank loans. They actually find the World Bank projects that are received by temporary members have worse kind of project ratings, right, than non-members. So that might be one place to look, would be sticking with the UN, but thinking more about Security Council voting as maybe costlier indicator of alignment.
Should you more? Okay.
Very quick one, it's related to Lena's point, thinking of putting other variables on the left-hand side as well. There's a bunch of new stuff. There's the cool new measure by Tianyu Fan and Zhang and Guo. The other thing, we just saw state visits in earnest in Steve's paper. I thought that was really cool. You could also look at military basing. I think that just putting more things
Yeah. Okay. Thanks a lot. I know the paper. I should. Yeah. I'm sort of we're reading into it to see if we can sort of take something from that. There's lots of sort of questions on how do we think of alignment more generally. So do we think of this like being, you care about the change, or maybe you just want some people to be in your camp? I mean, it's very hard to tell this sort of from the scarce data that we have. We've sort of run sort of non-linearities, like do you like countries, do you not care if they're like 50 or 55, but then if you really care about making them 90% aligned, you don't find that much, but you find a bit of that. Similarly, for these other measures, we were sort of working on incorporating them. The challenge we face is sort of this like super data scarce. So like even in state visits, the US is not undertaking many state visits to Zambia in the 1950s, or there's not many newspaper articles discussing how the US thinks about Zambia at that point in time, let alone the Soviet Union. So that's sort of the challenge we face, is we need something continuous which covers really many countries on which there's not much data. And finally, the UN Security Council. So we've thought a bit about how to interpret these papers through the lens of what we're doing. So of course these papers find that, when you get onto the Security Council, there's this really large effect on how much aid you get. The way I think of it is consistent. If you think of, it's very expensive to buy countries, you would think this is like a marginal shift in how geopolitically important you are, but you see this massive effect on aid flows. I think that's sort of consistent with the story we're sort of trying to tell. But yeah, so if we've thought about, how do we sort of discuss this evidence in our paper. So thanks a lot.
Well, one more question from Mohammed.
So I was following up Alberto's comment about sticks and carrots, because when you look at the history, I don't think US used a lot of its import restrictions or for a stick. We were in the receiving end as Turkey during Cyprus 1974. What was on was embargo of arms, as Steve alluded to. I wonder whether you look at the sticks that were used and come up with some other measure of sticks, because some of the carrots were used as getting you hooked up, and then you just by withdrawal.
Yeah, we should look. So we have some specifications where we control for realized sanctions, so that would be in there. And so we find that, these measures have predictive power over and above, when you actually exercise the stick. Of course, in this model you never do. But yeah, it's sort of, the data is very scarce, so it's kind of hard to get this like sector level. You would ideally, do something more sophisticated, but size of total trade flows is sort of what you can get for many countries relatively straightforwardly. Yeah.
Well, thank you so much, and we're back at 11:30. All right, we're going to get started in a second here. All right, we are very excited to have Ina presenting on optimal tariffs under geopolitical risk. You have 30 minutes.
Great, thank you so much for putting this paper on the program. We're really excited to be here. This is joint work with Ahmed Lashkaripur, who's sitting right over there, and will gladly take your questions. Okay, so the motivation for this paper is twofold. So first, we've seen overall a shift in the global trading system, and specifically in the global trade policy system. So on the one hand, over the past 2 decades, the export restrictions have effectively quadrupled. So what I'm showing you here is different types of export restrictions. It's a count, so it's an extensive margin, it's just a number, and you can see that they've basically risen from about 3,000 to 13,000 in 20 years. And a lot of these are concentrated in inputs, some critical inputs such as rare earths, semiconductors, medical supplies during COVID, etc. And then on the other hand, from the US point of view, we have seen a what appears to be a response. So focusing on the first Trump war, so 2018, 2019, an interesting observation arises. So these were the Section 301 tariffs that were introduced in China. And if you look at the growth of China's import share 5 years prior to these tariffs, we've seen that for the Section 301 tariffs, that growth has been a positive 4%, whereas for the non-301 tariffs, so the non-China tariffs, we've seen a decrease in the import share by 3% or so for the United States. Okay? And this looks at categories that were traded in both the beginning and the end here. So this started to get us thinking about whether the US is imposing tariffs in order to deal with strategic foreign supply disruption. And one way to kind of summarize that is something that somebody that we admire said herself, Janet Yellen. So this is not just rhetoric coming necessarily from politicians, it's coming from economists. And she said, we cannot allow countries to use their market position in any one raw material to disrupt our economy or exercise unwanted geopolitical leverage. So therefore, we're going to try to formalize these types of discussions in a model, and we're going to try to ask whether the US tariff policy is a welfare-improving response to geopolitical risk. So let me lay out the details of the background of the model and how we're going to answer this question. I'm going to lay everything out with 2 countries and a single sector, and then I'm just going to extend it to multiple sectors because the extension is going to be very natural, but I wanted to kind of derive all the results for you in a simple environment. So we're going to have 2 countries, home and foreign, CS demand aggregator with trade elasticity epsilon, and we'll have roundabout production. So what does that mean? So suppose you're producing variety omega in country N. How is that produced? So you have the productivity level in that country, and then you have labor, Ln, and inputs, a set of inputs, Mn, that are combined in a CS fashion. So beta, here's the labor share in production. And there's going to be 2 wedges. So the first one is something that we don't have control over. So these are your iceberg trade costs, DNI. They're technological. And then we're going to have 2 policy instruments. The first one is the import tariff. So tau NIM here means that it's the import tariff that country I, so think of the home country, the United States, imposes on imports from country N. And then export taxes, tau NIX, which are the taxes that the foreign country, country N, imposes on exports to the home country I. Okay? So just to kind of summarize how the model is going to work before I show you some equations, we have retail firms that are purchasing and bundling consumer goods, so that's our aggregate consumption. Production firms will purchase and bundle the intermediate inputs, so that was the M that we saw previously. And each firm is atomistic, meaning they treat aggregate variables as given, so think monopolistic competition, okay? Now here's where the interesting part is going to come in. So there's going to be geopolitical sourcing externality. And the way that it works is as follows. So the unit prices for consumption and intermediate inputs depend on the foreign export tax, tau NIX, which itself will optimally, as I'll show you, depend on the foreign's aggregate market share. But this aggregate market share is, of course, determined in equilibrium by each firm's individual sourcing decision. However, an individual firm, being atomistic, does not internalize the fact that it affects the overall aggregate market share, which then drives export taxes. So therefore, tariffs will potentially have a corrective role here. Right, so let me go through a little bit of details of the model so we can see how this intuition plays out. So this is standard CES, the buyer's prices for a good from country N sold in country I are driven by the productivity, which is a summary of the firm's productivity and country's productivity. And then we have the two policy instruments, which are the import tariff and the export tax. And then we have the input cost. So what is the input cost again? It has the bilateral trade cost, which is the iceberg. And then naturally the wage rate and the price of inputs, because labor and intermediate inputs are both used for production. The aggregate trade share is very standard looking, coming from a CS demand system, defining lambda NI, meaning this is how much country N sells to country I. Again, just to make sure that everybody remembers the notation, because these are objects that are going to show up. This is the import tariff, and this is the export tax. So I'm going to skip through this because it's very standard. So nothing interesting here. Aggregate equilibrium, general equilibrium conditions apply. We have the aggregate price index, labor market clearing, and I just want everyone to make sure that they understand that we're looking at balanced trade. So no kind of deficits, no nothing interesting there. Okay. All right. Now, in order to lay out the results, two objects are useful for me. So the first one is the export supply elasticity, epsilon FHS. The export supply elasticity in this literature measures the degree of the importers, so the buyer's market power. It'll be an object that will be showing up a lot when we look at our optimal tariffs. But I want to also bring in the import demand elasticity. So the import demand elasticity, on the other hand, I think of as the mirror image of the export supply elasticity. And this object measures the degree of the exporter's market power, which in traditional trade theory does not show up in the optimal tariff. But as we'll see in our model with geopolitical risk, it will. Okay. So I'm going to lay out the problem as follows. I'm first going to show you what the home country, so the United States, will do if the foreign country is completely passive. And then we're going to bring in the interesting point where the foreign country may or may not act strategically and solve everything by backward induction. Okay? So starting off with the simple, or think of it as the benchmark case where the foreign country is passive, the only thing that the home country is doing is to maximize its own welfare, which is just the real income, right? So it's income over the price index. The first proposition that comes out of this is something that should look familiar to people who have studied this literature, which is that the optimal tariff is just the inverse of the export supply elasticity. The only thing that's perhaps different from what you've seen before is that here the export supply elasticity is reflecting this extra term, which comes out due to the input-output structure of the model. Okay, so buying the fact that we're buying foreign goods for in order to produce our home good, that means that we're going to, when we impose a tariff, we're going to effectively raise the price of the foreign good relative to the home even more, okay, than we would otherwise. So this formula is very familiar in terms of intuition, and it basically captures the terms of trade effect. So what are the terms of trade effect saying in these models? Is that because there's just a single factor of production, which is labor, the only way that we can manipulate these terms of trade, or the only way that we can maximize our utility, is to just change the relative price of our one factor, which is labor, or the wage rate, compared to the other country. Okay? Now, let's bring in the strategic part. So the way that we set this up, and we're kind of open to comments here, but this is how we started thinking about it. So we're going to set it up as a Bayesian-Stackelberg game. Okay, so I'm going to guide you through two steps that we're going to use in order to set up the model, and then solve everything by backward induction. So let's kind of see if it makes sense. So we're going to have nature draw the type of the foreign country that's going to be captured by a parameter eta, which is drawn from a probability distribution, which is drawn from a distribution G. And this eta basically represents the non-pecuniary cost of non-cooperation. So think of as like a penalty for being bad, right? For not cooperating. And then the timing is as follows. So in the first period, the home country will commit to an import tariff, denoted by T. Of course, it observes the distribution of this object eta, but not the realization itself. And then in the second period, after this realization takes place, so after the type of the foreign country is revealed, observing the tariff and this type realization, the foreign country will pick a regime. This regime can be cooperative or non-cooperative, which basically comes down to the following. If it's cooperative, then the foreign country chooses to not introduce an export tax, so the optimal export tax is 0. If it's non-cooperative, then it chooses an export tax that maximizes its own welfare. And let's set up the problem of the foreign country so that we see what that looks like. So what is the foreign country trying to solve for? So they're simply trying to maximize their own real income, net off that non-pecuniary cost of non-cooperation, which only occurs in the case that they're non-cooperating or they're bad. So then the foreign country is effectively playing a best response, which is a bundle of the export tax itself and the probability of non-cooperation, or the probability of being bad, which is effectively the probability that the realization of this non-pecuniary cost is such that it is lower than the net welfare that the foreign country will earn by introducing an export tax versus not. Okay? So I'm going to show you some properties of this solution in a second, and I just want to make one definition before I do so. So lambda FH, which is the amount of goods or the share of goods that we, the home country, are purchasing from abroad, is going to be a key element here that will show up in the solution of the foreign country's problem and therefore in the home country's problem. So let me call that object lambda. So think of lambda then as being the import share. 1 minus lambda must therefore be the domestic, the share of expenditures. Okay? So what we show in the paper is that if the foreign country ends up taking an adversarial stand, then it'll set an optimal export tax that is given by this expression here, which of course, if you go back to our definition of the export supply elasticity, it exactly mirrors that expression. So why is that? So that's the familiar Lerner symmetry result, which is that you're setting an export tax that is equivalent to an import tariff. In this case, the resulting welfare gain for the foreign country is just the increase in welfare that they get from introducing this tariff over none. And this export tax will be applied, as we said earlier, if that difference is bigger than the cost of non-cooperation, which itself is parameterized by the function g. Now, we show two things, which is that both the export tax itself and the probability that a country will end up being bad are increasing in the import share of the United States from China. So the idea here is that the more that the US is buying from China, the higher is the optimal export tax that China is going to set, and the higher is the probability that China will do so. So that's true under the following conditions. First, under parametric assumptions that make a lot of sense empirically. We show that greater dependence will strengthen the foreign's market power in the bad state of the world, or the adversarial state, raising the optimal export wedge. And then We also show that as long as the foreign country's welfare is like supermodular, export taxation gains increase with lambda, and therefore the probability of an export restriction will also increase in lambda. Putting those two things together allows us to solve then the problem using the certainty equivalence principle. So let me define the certainty equivalent foreign wedge, tau bar L, to be the deterministic export tax that leaves the home country as well off as it would if we were to solve the problem in a stochastic space. So remember, this is a stochastic problem because we don't know whether the foreign country is going to be good or bad. Okay? So we'll be solving this using the certainty equivalent, which is basically solving it in expectation. So the certainty equivalent we show can be approximated by the following quadratic function. And when we go to the quantitative part of the model, we'll be parametrizing it and putting some numbers on it. Okay? So this then allows a foreign policy problem of a country that does take an adversarial stand to basically be to maximize it allows the home country's problem in this case of a bad foreign country to simply be to maximize their own welfare subject to the same equilibrium constraints that we saw earlier and the additional constraint that the foreign country's export tax is equal to this certainty equivalent export tax tau bar that we just defined. Now, remember that I showed you that it's true that both the probability and the export tax itself are increasing in the import dependence. Therefore, the certainty equivalent is also increasing in the import dependence, which then means that due to this increase, it's going to be the case that lowering the exposure of the home country to the foreign country will reduce the foreign export wedge, and therefore, we will want a tariff to accomplish that task for us. So that gets us to the optimal macro tariff under geopolitical risk, which is made up of two components. So the first component is the standard one that we already saw. It's the terms of trade component. And the second one is the geopolitical risk correction, which reflects two things. So first, it reflects the elasticity of demand, which, as I defined earlier, is reflecting the market power of the buyer in this case. And the second one is the change in the growth in the certainty equivalent tau bar. So this second term is the new term relative to standard theory, and specifically, as you can see, depends on the exposure of the home country to the foreign country, unlike the terms of trade component. Now, what's interesting about this result is that when we take it to multiple sectors, everything goes through, very easy to set up and solve. But the result to us, or to me at least when we first started working on this, was surprising. So what is surprising about it? So the first part, which is the terms of trade part, is uniform. So it's not sector specific. Why? Because we're just trying to manipulate the terms of trade through the wage effect. But it is the second part here, the risk correction part, that is sector specific. And looks exactly like what we saw earlier, except that it has sector variables. So it's reflecting both the sectorial elasticity of trade, and this is something that we've seen in Matteo's work, right? It reflects the sectoral demand elasticity and this correction, which is due to the export tax. So what we're going to do next is to try to take this to the data and see, first of all, what types or what the optimal tariff should look like for the United States. We're going to do it for Europe as well. And then second, we're going to take this to data and see what the tariffs have actually looked like for the United States in 2018 and see whether they match up with the theory that we propose. Okay? In order to take the model to the data, a lot of the data is standard. We just need import shares, GDP expenditure, but we do need one parameter, which is a parameter that relates to this geopolitical risk, and that's the parameter zeta. So what is zeta? So it's the geopolitical risk elasticity, which is basically measuring how fast the probability that the foreign country restricts trade or puts an export tax rises with the home country's import dependence or import share lambda. Where is that coming from? So it's coming from straight from our assumption on what the probability is, or what the distributional assumptions that we put on the cost eta. So just inverting that gives us a hazard function pi, which is a power function of lambda, and zeta is just measuring that elasticity or that coefficient in the power function. So naturally, when you log it, it gives us a very easy estimating equation where we can estimate zeta by regressing the log of the hazard on the import share. We're going to take the log import share here because we want to say what type of a restriction has China imposed given the import share that we observed the previous year from the United States import share from China in the previous year. And we're going to run this simple linear regression where we're going to have importer, sector fixed effects, and time fixed effects. And the hazard data is going to come from the GTA and OECD export restriction database. So given the level of aggregation that's available in that database, we're going to aggregate the hazards to the HS6 by, we're going to aggregate the hazard to the HS6 digit level data by using export shares, export sale shares for each good within that category. And running this regression, we're going to do several specifications. I just don't have time to show you all of them. We're going to do OLS. We're going to do PP, PPL, sorry. And we're going to do it for the US and for Europe. So the number that comes out of it in the baseline year of 2018 for 16 aggregated sector for the United States and for EU is 0.29 and 0.23. So we're going to combine these numbers together with import shares for the United States vis-a-vis the rest of the world, the European Union vis-a-vis the rest of the world, and a total expenditure in GDP, together with a common trade elasticity for now across sectors of 4, and value-added shares for intermediate inputs that we compute from the input-output database for both the US and the EU. The result is as follows. The optimal tariff for the United States and the EU without the geopolitical risk correction amount for roughly 26%, and the geopolitical correction for each country adds another 5 percentage points, so about 16% of the optimal tariff. So it's not trivial. But what's interesting about it is when we take it across sectors. So doing the exact same exercise and calibrating the model to generate optimal tariffs at different sectors, what I'm plotting here is the result for the United States and the EU as a function of the foreign market share in that sector. So recall that the optimal tariff, excluding the geopolitical part, which is just the terms of trade portion, is roughly 26%, and it's the same across sectors. And then the optimal tariff, including this geopolitical risk, ranges from about 27% to all the way 36 or 37% for some sectors. So this is about 50% extra extra kick that comes out of the geopolitical portion. So it's quantitatively, it's quite large. And more interestingly, it's really accounting for this cross sectoral variation. So then the big question is, okay, you have this model. This is how you think about the world. Does it make sense? Is this what we see in the world? So in order to test the predictions of our model vis-a-vis the data, it's important to recognize that there are alternative theories to what optimal tariffs look like. So the two leading alternatives here being the first original one, which is the terms of trade theory that basically says that you're setting tariffs that are exactly equal to the inverse of the export supply elasticity. Therefore, tariffs track importer market power. Broda-Lima and Weinstein tested this in 2008. So we're going to take the export supply elasticities at the sectoral level that they estimated in that paper. And then the second one is, of course, protection for sale, where the theoretical model that comes out of Grossman and Helpman was tested or taken to the data by Giovanni Maggi and Penny Goldberg. So this test would say that protection should reflect lobbying, so therefore for sectors that are organized, the optimal tariff should fall with the import penetration of the sector or of the country relative to the other country. So that is effectively going to say that the tariff should be related to the import demand elasticity, epsilon D. Once again, it's something that we take estimated from the data. And finally, our model will tell you that you have the export supply elasticity, you have the export demand elasticity, but it should really be the growth in this dependence or the growth in the import share from China that should drive the optimal tariff. So therefore, we run the following regression. We're going to take the change or the growth in tariffs during the 2018 episode. Specifically, we're going to start by focusing on the Section 301 tariffs, which are the China-specific tariffs. So just to make sure that everybody's on the same page here, during that trade war, we had kind of 4 different stages of tariff increases, right? There was the first 2 stages were not China-specific, so they were kind of the same for everybody. So those are your Section 232, 201 tariffs. We're going to add them back in a second. Then you have the third tranche, which is the China-specific one, and then there was the fourth one that was kind of threatened, but then it was pulled back. Okay, so we're really focusing on that third one, which is 301. Okay, so we're looking at the change in those tariffs or the growth in those tariffs from before to after they were implemented, and we're regressing that on the growth in the import share from China in the 5 years prior to 2018. Controlling for, of course, the export supply elasticities and the import demand elasticities, which would be predicted by the alternative theories. So the baseline here is the result that where we're looking at the change in China's import share out of total imports for the United States. And in fact, that's positive significant, which is what our theory would predict. Interestingly, the export supply and import demand elasticities are not being picked up at all. So the estimates are very small and insignificant. We're doing this both at the HS10 level and HS4 digit level. A caveat here I should make sure that everybody understands is that for export supply elasticities, we only have observations at the HS4 digit level. That's what Broda and Limao have estimated. So then when we go to HS10 digit level, which is where we observe the tariffs, we basically have to assume that it's that same, the number applies to all the categories within that bracket, okay? And then on top of that, we run, I'm not sure that placebo is the best word for it here, we're still going back and forth, but we're basically looking at tariff changes on these same goods, but from non-China suppliers, okay? Because in principle here, how much or what our import share is from China should not be telling us how we're changing tariffs on other countries in this episode. And indeed, we're seeing that those are not significant. So then in panel B, we do the exact same thing, but we're now on top of looking at the change in the import share of China out of total imports. We're also scaling by the total import penetration in order to get the actual scale effect. Okay? And indeed, the coefficients still line up. And then finally, what we do is to add back those tranche 1 and tranche 2 tariffs, which are the Section 232 and Section 201 tariffs. So remember, these are not China-specific. So what we're seeing here is that relative to the baseline, the coefficient falls and becomes weaker. And indeed, that is what we expect, because these are not China-specific tariffs. So they should not be correlated with how much we're buying from China. Okay? So overall, we see these results as showing support for a theory that builds on strategic decoupling due to supplier risk. And finally, we do one more exercise where we use USTR communications during the 2010 to 2025 period. So here we're taking every USTR release, and we are classifying it into 6 economic frames, where the ones that are specific to our mechanism are geopolitical risk and strategic exposure. And what we're seeing is that pre-2017, the mentioning of these terms was relatively low, so 6 and 3.9%, and in 2018 that jumped by roughly 4 or 5-fold. And indeed, that jump is roughly concentrated in the March to July 2018 window, which is the window between the Section 301 announcement and the first wave of Section 301 tariff list. This, so we find this a rhetoric to be moving with strategic risk together as the tariffs themselves. So to conclude, what we're showing in this paper is that the optimal tariff is made up of two components, the standard component that we're used to seeing, which is the terms of trade manipulation, and a strategic risk correction term. This risk correction term is larger in sectors with higher import dependence, which seems to line up with what we see in the 2018 tariff war data. And a takeaway is that trade wars are therefore potentially more disruptive than we previously thought due to these strategic interactions across countries. Thank you.
And the discussant is Matilda Bombardini.
All right, so this is working, and this is the other. Okay, well, thank you so much for inviting me to discuss this paper. I had a lot of fun thinking about it, and here are my thoughts, and I apologize for if they're confused still. Okay, so I love papers that start with the sort of fact that you know, we cannot explain with other theories. You know, we'll see. You know, I'll tell you whether that's the conclusion I reached, but that has the China import share here and the tariffs that the US has imposed on China. So meaning that you impose higher tariffs where the China import share, by the way, this is, as you know, Ina rightly pointed to and sort of becomes more obvious in the paper, is really the imports from China divided by total imports, is not imports from China divided by absorption. So that's something that I'll come back to. So, and Ina kind of described that, yes, if you think about import over absorption, it's true that Grossman and Helpman sort of predict sort of the inverse because it's Ramsey taxation, so it's inverse and so on, and the standard terms of trade with Nash doesn't predict that. Okay, so. All right, so just a very quick summary of, so that sort of motivates their, that together with the increase in export restrictions motivates this paper, the model where, as a reminder, you have two countries, it's an armament and CS with a trade elasticity of epsilon, and then you have roundabout sort of production, and you have atomistic firms with no market power. So, and then they have this Bayesian Stackelberg, it's called sort of where instead of doing sort of simultaneous moves of home and foreign, home moves first and sets the tariffs. And then nature draws this non-cooperation cost, and foreign either cooperates or doesn't based on that. And then they derive this sort of hazard and so then both the hazard and, so the main result is that both the sort of export tax that foreign imposes and the probability of imposing this export tax sort of are increasing in what? In home's dependence from foreign. And so they say this is a new sort of term that sort of they call a geopolitical risk that adds to the standard terms of trade, sort of Mill-Bickerdijk formula. And then the nice thing is that they have a lot of really kind of interesting data that they bring to that, which is sort of to estimate this hazard function, the probability of foreign export restrictions increasing with home dependence, and then they do a quantification. And importantly, they go back to match that pattern that we saw at the beginning, sort of showing that this model predicts that you sort of impose higher tariffs on sectors on which you're more dependent from abroad. Why? Because you anticipate that that's where the export tax are gonna be higher. Okay, so that's the paper. All right. So I'm gonna make 2 points only. I mean, I'm gonna sprinkle sort of smaller ones along the way, but the first is really the nature of this geopolitical risk correction. I'm going to ask the following question, which I didn't have time to ask them because I didn't prepare in time. Could we just see this as a first mover term that arises in a classical tariff war with just Stackelberg game? No risk, no intermediates. Okay, so I'm going to sort of solve that model. And then I'm going to kind of push and kind of suggest that it'd be useful to have all that sort of imports from China versus total import dependence. You should have more than one country, because then the predictions are probably going to be different when you have the option of putting a tariff or friendshoring, which is what happens in reality. So first, okay. So I was really trying to figure out what was going on here, sort of see how far, what do you really need to get that result of this dependence. So I sort of stripped down, I removed intermediates, no roundabout, no hazard, forget about the extensive margin of whether you impose or not this. And now foreign places an import tariff instead of an export tax, which by Lerner symmetry is the same thing. And I'm going to preserve the timing, which is the key here, which is that home sets a tariff, then foreign sets a tariff. What would this deliver? I think it would deliver sort of a similar thing, meaning that when you have foreign will still set a tariff that's the inverse of the export supply elasticity of home. And the key is that the export supply elasticity of home is still going to depend on the sort of import dependence of home, okay? And so you still get that result that the foreign tax tariff, whatever you want to call it, is increasing in home dependence, same as the full model. Why? So this kind of reveals that you don't need intermediates. You just need consumption. Consumers are atomistic by definition, and so they don't internalize all this externality, which is why we have a terms of trade motive for having tariffs in the first place. That's my interpretation. Maybe I'm wrong. So that's stage one. So what about, so the second mover, sorry. And then home will also try to anticipate this by setting a higher tariff on sectors in which it has a higher dependence, because it anticipates that the tariff is going to be higher on those sectors, okay? And so, again, the term, so I've just re-derived in a very simple version. I mean, it's just a collapsed version of that model. Essentially, a sort of a Mill-Bickerdijk terms of trade part, and then what I'm really calling a first mover premium, which, I mean, it's not geopolitical risk, but it's sort of it's just due to the fact that instead of a Nash, you get to move first. And that can anticipate, can undo some of the damage that foreign will do later. And so I think, but again, I didn't have time to ask you, I think this still delivers figure 2, sort of the motivating figure. And so I asked Claude to draw it for me. And so I just said, solve this model, and so it did deliver it. So, and so the similar slope to the model, and so I think you can fit that. So I guess my question is, can we just call this a Stackelberg premium? So, can we call this sort of the Stackelberg first mover premium, which is absent under Nash? And then, so then it really is about timing, which we know matters a great deal because it's all about commitment and all that, and so we know it matters. So it's just, is this the right assumption? Is this the right assumption? If you think about the timing of the China tariffs versus the first rare earths export restrictions, maybe, I'm not, but in any case, playing with the timing and being sort of clear about what delivers what is great. This slide is not to the fact that the organizers are who they are, and so this so here I think the second paper, the one that Matteo's taught me to call the outside option paper, which I think everybody else calls concursion and something else, and fragmentation or something like that, yeah. But I think of it, it's useful to think about it, the outside option, and the first econometrica one is the inside option one. That's the, yes. I think that would deliver a similar thing, because in their paper, remember, the outside, so what's the story there is that, let's say, the non-hegemon, I mean, here you would have to decide who's the hegemon here, but let's say that US moves first, and then China moves second. China there would have let's say China now is a hegemon. It could cut, if you make yourself dependent on China, then China can withhold their inputs. and extract various wedges from you. And so then they would, then you would try to reduce that ex ante. So if you then, you make yourself less dependent on China because you want less to be extracted later on. Then there's a whole issue whether China can commit to not extract it later on, which is something that you guys have to deal with, so I'll just leave that to you. But I think in that case, you would still get that the tariff would be increasing in import dependence. So that kind of goes back to the question of whether the existing theories explain figure 2, which I think it would, but I didn't have time to talk to both these guys, and so, okay. Oh, and then, how am I doing with time?
5 minutes.
Oh, I may not even use them all. So, okay, so one thing, actually, oh, let me go back. So what I like about the fact that relative to the CMS paper, that you do have retaliation. In a sense, you have on-path, not punishment, but you have, on-path export taxes, which in your paper is sort of, it's a threat which shouldn't materialize. And so that's a nice thing that in Ina and Ahmad's paper, you do have the export tax gets placed on exports. And so, and that's why they can estimate all this hazard function and so on. And so, and I mean, also the difference is that here it's a welfare maximizing choice to input the tax. So you do it because you're just exploiting in terms of trade. Whereas, when it's a threat to cut off inputs, that's a cost for the hegemon. So you don't want to do it, and you don't do it because you hold it as a threat. Whereas here you actually do it on path. Okay, so I guess then you can sort of try to distinguish, because figure 2 is delivered by, I think, both sort of theories, but this on-path punishment or on-path sort of aggression of some sort is realized. So maybe one could try to distinguish the two theories in that way. Okay, so I could use more discussion of sort of the extensive versus intensive dimensions of these threats of like. Because they both the probability of non-cooperation and the size of the export tax are both increasing in dependence. And so I would, and eventually the problem is described in terms of certainty equivalent. So I wasn't so clear. It'd be great to know in normative terms whether these two have, sort of conceptually different roles. Of course, in positive terms, it's important to know. We want to explain the world, and so we want to explain both the probability of imposing something and how much you're going to impose if you're going to impose it. But I guess normatively, it'd be nice to have a discussion. And then I had a quibble about calling X equal to 0 the cooperative regime. I guess the word cooperative always has a flavor of efficient or joint utility maximizing, which X equal to 0 is not, given that you put a tariff, but that's just a quibble. And then finally, I'd like to sort of comment on this sort of with 3 countries, I think it becomes more interesting because then you have all this dimension of, you have a friend, you have an enemy, and then you can play with not just putting, having a domestic share, but it's a share, I think, of what's produced in the friendly countries that really matters for the export supply elasticity. And so I think there you get to break this sort of, which you do in the empirics, which you absolutely do in the empirics. So, but I think conceptually it'd be useful to do it in the theory as well, so that you can break sort of the import share of China from the import absorption overall. Okay, this is again sort of another sort of little toy model in which this is with 3 countries where if you have sort of 100%, so I mean if you have sort of three countries, this is where it's all China, and then that's what you have right now, which is sort of essentially it's only one country. But here if you have 2 countries of which China is about 1/3, then you get term, the risk-driven tariff premium would be smaller. So I think quantitatively it makes sense if there's another country. All right, so interesting paper. I had a lot of fun, and I look forward to having my many questions answered in what follows. Thank you so much.
If you have a microphone, you can also keep the mic right there. Whichever. Let me go to that question. So, Giovanni?
So this feature that the terms of trade component of the tariff is uniform and the other is sector dependent. Seems you're emphasizing it quite a bit. Seems important, but the fact that the terms of trade component is uniform seems very special. Depends on I don't know the department structure. That seems very fragile. So I was wondering.
Andre?
Yeah, so a couple of comments. So, I mean, in the end, you're regressing the variations of the Trump tariffs on the import share from China, right? And the explanation is that these are tariffs that were put on because Trump was afraid that China was about to put export restrictions on them. I mean, I guess it would be good to get some direct evidence of where China was putting export restrictions to see that these are, because, I mean, casual appearance would suggest that that's not the case, right? The most famous export restriction is rare earths. I don't remember the U.S. import tariffs on rare earths being like very, very prominent. So it would be good to get some evidence that these are actually the sectors where China was putting export restrictions, either exposed or to other countries or whatever. And then another, that's more of a question. So is there another equilibrium, which is a repeated gain cooperative equilibrium, where U.S. doesn't put a tariff, and then China doesn't put a tariff, and then like in a typical bilateral stagger, the free trade is sustained with the repeated gain cooperation? And if there is one, then is there a way to like rationalize the breakdown of the cooperative equilibrium at that time, perhaps due to some shift in the distribution of Chinese capital G? Maybe there's like an increase in the Chinese export restriction use. Maybe that's some evidence that China like started getting draws that make it more prone to deviate, and that will break down the cooperative equilibrium at that time. If there's like a time series of these restrictions.
Emily?
Three questions, closely related, I think. So on the Section 301 tariffs and the empirics, the Section 301 tariffs were imposed on these big lists of goods, but the coupon rate, the official ad valorem add-on, was the same within each one of those buckets. So it was 25% or 10% or then 35%. So there wasn't any differentiation within those buckets across goods, which seems problematic. And I'm actually wondering, are you looking at the percentage increase in the tariff rate or the percentage point increase in the tariff rate? That could explain what's going on. And maybe related to that, also when you're looking at the benchmark tariffs, so I think this is pre-301 if I understood correctly, that's a really cool result, but it would seem to be closely correlated with the pattern of what are labor-intensive products and where does China have comparative advantage. So that's a horse race I'd kind of like to see run.
I'll ask one, and then we should give you time to answer. Mine is a little bit like outside of the models, but I'm wondering what you think about it. It was pretty cool to see that the increase is on the import share. I think Matilda mentioned you would have imagined in a model it should have been the share over total absorption, including domestic production. What I suspect, my curiosity is, it could be that politicians are spending a lot of time and attention on just how much do we import from China, irrespective of whether we have a huge capacity to produce it domestically. And that becomes salient, even if that probably is not what a model would predict. And that generates an artificially strong correlation. The Europeans, for example, are obsessed about what we import from China, irrespective of how much of that are we actually producing domestically anyway, which for dependency or for fear of retaliation later should really be the right concept. And I'm wondering, what your thoughts are on it.
Should we answer? Okay, that's a lot. And I've already forgotten. forgot most of it. So, good thing Ahmed's here. Okay. So should I just answer you, or also, I don't know what the rules are, because it used to be that you. Okay.
You can pick and choose.
Yeah, so a couple of things, and then Ahmed can take over. So Matilda, thanks for a great discussion and for raising all of those questions. So the simplified model that you showed makes a lot of sense. That's kind of how we started thinking about things. Absolutely, the input-output stuff doesn't matter. We put it there for quantitative purposes because we just want the tariffs to make more sense. And this also gets at a little bit of Giovanni's question, which is like that first part, the terms of trade part, why it's uniform. So actually, Giovanni, you could potentially break that if you made these betas, like the input-output things, to make them sector-specific. But the variation that you would get is very, very small. So it turns out that it's like actually really hard to get a lot of variation in the terms of trade effect, even with fixed factors, et cetera. So quantitatively, that's not easy. In theory, yes, but when you put the numbers on it, it's pretty difficult. So we're finding that we do really need this, what we call the geopolitical part, or maybe Matilda has a different word for it, to get the variation, okay? And that kind of gets to the first mover premium, and I think Ahmed wanted to say something on that, so I'll let him do that. And then regarding, the connection to Matteo's work, which we do with co-authors, which we do cite, but today I was not citing because of time, of course. So I would say that, yes, on the intensive margin, we share some of the predictions, but we do have this extensive margin, this probability part that actually does matter. It matters both in theory and quantitatively. And I'm going to let Ahmed say something about the theory, but on the quantitative side, again, it's like generating a lot of the variation. Once again, it gets to the same answer to Giovanni. Like, it's just not that easy to get this type of variation that we see in the data. Okay, I answered Giovanni. Andre, lacked import share. So we had a big conversation with Ahmed yesterday while I was flying. I would love to do the part where we're trying to test it from the China side, which is what you're saying. We have not been able to find the data to do that because this GTA data and stuff, it's a count. It's not an intensive margin measure, but if you have suggestions on that, I would love to know, because yes, I also would like to do that. And then, Ahmed, do you want to handle the part about the cooperative game, because this is your baby? You know this stuff better than me. Then Emily. So the the stuff about China having comparative advantage. So again, like here, the way that I thought about it was that we were really doing that through the protection for sale part. But I guess maybe you think otherwise. So perhaps we can talk about it a little bit more after. But it means throwing in another control, which I would love to know what that is. So yeah, go ahead.
Yeah, so again, thanks a lot for all the comments. Just one point on the choice of the model. I think it needs clarifying that having the input-output loop has this added benefit that it gives a clear sense that input-output linkages lower the optimal tariff. So we know the gross formula very well, and this is kind of a interesting new amendment to that formula that shows that input-output loops have this effect. It's not necessary really for the mechanism, but it just makes it more general. But in terms of the extensive margin, the pie, the risk part, so we were concerned about two things. One, in reality, we see tariffs that are applied on goods that never experience an export restriction. So we want to be able to rationalize this in the data. So our model does predict that. So you will see goods that are subjected to a tariff because ex ante, they could have received an export restriction, but ex post, the draw doesn't justify that. The other thing is that the extensive margin actually gets you this big variation with the intensive margin across sectors. And going back to Giovanni's point, So if I had added specific factors, heterogeneous betas into the model and then simulated this optimal tariff problem, I would get very little variation. So these GE implied sector level export supply elasticities typically are not going to be very large. So what is nice about the model is that we get this like meaningful variation across sectors. In my experience, it's difficult to break uniformity. You kind of get quasi-uniformity, but this kind of breaks the uniformity result. But I think going back to Emily's point, I think one thing that we really do need to add is what you mentioned, because in your paper, in your restud paper, you guys show that this input-output stuff mean that you want to have targeted protection based on comparative advantage, and we don't have that. So I think as another covariate, I think it would make sense to add like factor intensity or some measure of revealed comparative advantage to kind of control for that mechanism. So that's a great point. Thank you.
Why don't we collect a second round of questions, and you still have a few minutes.
Okay.
Peter.
Thanks very much. I know that that things can get very complicated very quickly, but in much of what we've discussed today, we've omitted concerns about domestic politics, right? And that, of course, we all know that specifically with the tariff, it has tremendous domestic distributional consequences. There are gainers and there are losers. What was particularly interesting about the 2018 tariffs was that the domestic politics of these were acute. That in fact, the administration followed what was at the time relatively standard procedure by holding hearings, allowing firms to lobby for exceptions to those tariffs. Okay, and indeed, there's plenty of evidence to suggest that politically connected firms located in Republican districts that were making large amounts of contributions all received exceptions from these tariffs because they wanted to keep the price of their inputs low, right? So my question, I guess, to you is in what sense, what direction is that bias you're finding, right? Is by ignoring the politics, do we feel stronger about the story you want to tell, or are we omitting an important part of the analysis here that should be taken into account?
Shao?
I was interested in maybe a slightly narrow point on estimation of zeta. You're estimating this probability that foreign restricts with respect to import dependence at home. So that would suggest that you want kind of targeted for this country but not that country data on and variation in export restrictions. I worked a little bit with the Google Trade Alert data that you use, and I think at least in agricultural markets, which could just be special, part of what happens is that domestic prices go up, and so Indonesia, for example, will put in a palm oil ban for exports no matter where they go. And I think that to the extent that you have this common across all trade partners action, that might dampen actually and cause you to understate potentially the elasticity that you have.
So why don't we stop here? We give you 2 minutes to wrap it up, and then.
Yeah, so let me come back to your point, and then I'll give Ina the microphone. So I think one thing about the surge in imports from China that I think that's definitely part of the story. So one of the goals was, can we rationalize tariffs that mitigate strategic risk without adding any extra preference to the government's objective function? Like, if the government just simply values real GDP in both countries, can we still rationalize what's happening? Yes, but absolutely we're going to miss out on a lot of, going back to the other question, political economy motives for policy that are also playing in the background and also driving these tariffs. So I think we think that this doesn't give a big picture, but it does give a nice positive picture of why even purely welfare maximizing governments who do not care necessarily about the surge of imports from China or another adversarial partner may want to restrict imports because firms fail to internalize this excessive dependence issue.
Yeah, so thank you for the comment on the GTA. Maybe we can talk offline, but did we not exclude I think we had specifications where we exclude the agricultural goods. And so that did not seem to matter a lot. And then, of course, so the big question, the way that, so Ahmed and I did some back and forth on what you were seeing yesterday. So exceptions indeed were granted, especially for inputs. right? And this is something that we could potentially actually model, and there is data on it. So I think that it was a hairy kind of thing that Ahmed had dealt with before, but absolutely, I actually think that what you said is important, so I'm glad that Ahmed gets to hear it, because now we can do it, because I do actually think we should bring it in. But I cannot answer to you how it's going to play out, because I know that the data is there, and we can put it in the model, and I want to do that next. So thank you for bringing that up. I appreciate it. Thank you.
Okay, fantastic. Thank you. Okay, so now we're on lunch break, which is outside, and we reconvene at 1:30.
All right, everyone, we're going to get started with the afternoon here. Michael, you ready to go? All right, we are very excited to kick off the afternoon with digital choke points. Michael, you have 30 minutes.
Hello. Oh, is this on? No, that one, no. That one. All right. Hi. So thank you very much for having us in the program. It's a pleasure to be here, of course. So today I'm presenting an ongoing project with Christoph and Benjamin, who are here in the room with us. And the project is called Digital Choke Points. So the project is motivated by the criticality of data flows to the modern digital economy. Indeed, it's hard to overstate how much things like AI, logistics, finance depend on the speedy and uninterrupted flow of data. And of course, there is a large literature showing that countries at all stages of development do in fact get high welfare gains from having high speedy connectivity and large data flows. This project, though, is focusing on the physical infrastructure that carries this data. So I'm talking about the network of cables and satellites that makes this flow of data possible across borders. And in particular, this is surprisingly concentrated kind of infrastructure, both geographically and in terms of ownership. And concentration, of course, is often associated with risks, and this is something that policymakers in Europe and Asia worry a lot about, especially thinking about the cable cuts that we see in the Baltic or in the Taiwan Strait. And also in general, they worry about how much concentration in ownership and control can give the possibility to countries to weaponize this network to coerce them. This paper is trying exactly to study this. We are quantifying the dependency and vulnerabilities that are associated with this global telecom network. In other words, we're studying how much countries and in general the global economy would be affected by disruptions in this critical set of infrastructure. So let me convince you that indeed this is a vulnerable network. So why is it so vulnerable? Well, first of all, for three reasons. First of all, because these cables are very easy to damage and very hard to defend. So a ship dropping an anchor can accidentally sever a cable. And of course, monitoring 300 million kilometers squared of seabed is very, very arduous. Second, this infrastructure, as I said, is very rich. There are cables and satellites, but really it's about cables because capacity means that satellites are no substitute for cables. Indeed, all of Starlink, so 7,000 satellites from Starlink have the same capacity as a single submarine cable built in recent years. And this this is not accounting for the fact that satellites themselves can be jammed and tampered with. And as I was saying, there are only 500 of these cables in the seabed carrying international data flows, but the geographic concentration is even more sharp when you look at single countries. Just keep in mind that South Korea, for example, is connected by just 10 cables to the rest of the global internet, Taiwan 14 and Japan 28. So these are very concentrated kind of infrastructure. So these three facts make cables a clear and prototypical choke point of the global modern economy. And this is the first paper to study them in this light. Specifically, we make 4 contributions. First of all, we provide a public good. We provide a new database covering 175 years of telecom infrastructure. So we start from the very first telegraph line built from France to England under the Channel, and we collected all sorts of cables and satellites and radio towers that were built since then across oceans and in the sky. So this data set called GlobeTel will be, of course, made public, well, soon. Then we use this data set to answer the questions I was mentioning before. So first of all, we propose a new model and estimate it to try to link this physicality of this network to the welfare of countries. Specifically, I will show you the model very briefly, but it will be a traffic assignment model accounting for cables and satellites and data flows in them that will link how the topography of the network, meaning its disruption or new buildings, is going to affect the welfare of countries. Then we use this model to do counterfactual analysis and to quantify the risks associated with potential war-like scenarios. I will show you today a potential conflict in near Taiwan or a more broad one in the South China Sea, what consequences that would have for the global internet. And finally, a fourth contribution that unfortunately I won't have much time to talk about today is we study responses to these risks in terms of cable building. So that is where history really comes into play in this project. We show that historically, whenever there were increases in risks, conflict-wise or geopolitical risk, more specifically, countries and especially great power would engage in cable building to self-insure against cable cutting and to become less dependent on the current hegemon. Yeah, but as I said today, unfortunately, I will just focus on 1, 2, 3 for time. Okay. So let me start by briefly introducing you to this new database. This is a bit of a pity because this was 4 years of work, and it's going to be 2 slides. But so this is the GlobeCell dataset. It's a comprehensive new infrastructure. We put together sources from archival sources to modern sources that are on the internet. I think we really did a good job at merging all these sources together and getting a truly dynamic picture of how this network evolved over time. There are available there are websites that propose a snapshot in time of how the network looks like today. We really focused on getting the dynamics right. From 1850. So this dataset is not only about the geography of these cables, it's very broad coverage, so we hope it will be interesting for many people because it covers not only the geography, but the ownership, the dynamics of ownership, and also the capacity and the technological feature of this cable, which, as you might expect, in 200 almost years of history have developed quite a bit. As an addendum to this dataset, we also propose a history, an archive, let's call it, of digital coercion events, from cable cutting events to sabotage to embargoes. Okay, here is the mandatory picture of how the original sources look like, and this is what and this is what we did with it. Okay, so here you can see the reconstructed network for a specific year in time, 2022. It looks like a mess because it is. So the black lines are terrestrial international communication lines. The blue lines are submarine lines. And the red dots, the many red dots are, the small one are Starlink mostly, and the bigger ones are other types of satellites that have a different kind of orbital properties compared to satellites, to Starlink. But anyway, this is how the physical network looks like in 2022, and we can do this picture since 1850 with this data. All right, so now I told you that we can measure and observe this network. Now, how do we link it to welfare and how do we quantify the cost related to disruption in this network? For that, we build a model of data flows on a physical network. So this model is fairly simple, and I will try to present it in 1 slide only. The idea that we borrow from the knowledge spillover, knowledge externality literature is that there is a factor of production that we can call, you can think of it as information or knowledge that increases the productivity of firms. The difference we have here is that this factor of production is not just something that arrives to you. You have to source it. And the way you do it is that you connect to the source of this knowledge via data flow. So you import data from the source of knowledge, and that data is what this X and J is going to be composed by a CES aggregator into this measure of productivity that affects firms. So that's the link between data flows and productivity. But as I said, these data flows are not just have to go through this physical network. And for that, we simply assume that these flows have 2 costs. One, you have to pay the price to a telecom carrier to actually establish the connection between London and Sao Paulo. And second, there is a shadow cost, let's say, which is that the slower is the connection, the longer you have to wait for a response, so the less efficient it will be. So these are the 2 costs associated with importing data flows: the cost you have to pay directly, and the worker's cost of waiting for the data to arrive, which is what in this literature is called latency. So with this idea, both of these features are linked to the distance across the network between the source of knowledge and the position of the firm, and therefore we can derive a simple gravity demand for data flows based on this distance or latency. And given the importance of congestion in this network, we cannot just do shortest path assignment, but we have to apply employ a model that takes into account of congestion. Think about the last time you were in a concert or in a soccer stadium, your phone wouldn't work. That's congestion right there for you. So the idea is that the cost of data flows, for example, the time it takes for the data to reach you from Sao Paulo to London will depend on how busy it is the route compared to how capable the cables are on that route. Okay, so with these features, we characterize the full model where we just have an equilibrium where demand for data flows, the routing on the network, and therefore latencies will all be jointly determined. And this finally gives us a link that I promised between the welfare of countries and the characteristic of the network, because the characteristic of the network give us latency and costs. Fantastic. So this was the model. Now, we take the model to the data, and we estimate some of its key parameters. So first of all, we have to say, what do we need for welfare counterfactuals? Well, as you all know, we need bilateral demand flows, which you can observe. We have data on that. And we need some parameters on demand function and on congestion. Now, I'm not going to bother you with how we estimate the elasticity of production or the elasticity of substitution. We use standard I/O and trade methods, but the more interesting part, I think, was to estimate the congestion effects. For that, we simply use, so what are the congestion effects? Is the relation between how much when capacity fills up, latency goes up. So how much cost increase when capacity increases, when capacity is filled up, utilization increases. And here we use intraday within path variation, because what you can observe is that as countries, during the day and night cycle, countries will use more or less data flows, but capacity is fixed. So what you can observe is that this rhythm of the day-night in capacity utilization reflects the rhythm in latency that you observe across the same path, and we use that to estimate these congestion parameters. All right, so armed with all of this, we also can validate the model. I'm not going to bother you with that, but the model predicts for the few cases and years in which we can observe routes actually taken by data flows. The model is fairly good at predicting where these routes are going compared to other models of like geography-aware random walks and things like that. So yeah, and not only that, but the model is fairly solidly reproducing what we observe in the data. Okay. Now, let me tell you about the findings, now that I told you about the data and the model. So the finding number one is that global data flows are very, very highly concentrated, specifically in traditional maritime choke points. So here you see just the model prediction on where traffic goes overlaid on the actual cables. You can see that there are some cables across the Atlantic and the Pacific, as you would expect, that capture lots of these flows, because there is lots of demand between the US and Europe. And this is very, very concentrated. As I was saying at the beginning, 10 cables only carry 25% of all global traffic. Another way to quantify this concentration is to look at this picture, which shows instead, rather than the single piece of infrastructure, it looks at, in every grid cell of 2 by 2 latitude, longitude degrees, which is the size of Maryland or Sicily, if you prefer. It captures how much data flows on that grid cell. So this captures a more geographic kind of measure of concentration. And you can see here there are certain areas that light up, especially in the English Channel. You can see the Suez and the approach to Suez and the Malacca Straits are dark red. In fact, 20% of the world data flows in the English Channel only. Okay, so of course these are just traffic numbers. These are the model prediction of where traffic goes. It doesn't tell us anything about the cost of disruptions. For that, we need welfare exercises, and we need to allow for rerouting, because if there are two cables very close by, you can just move traffic, shift it around, and go around it. And in fact, this intuition gets some traction if we look at the picture on the left. On the picture of the left, the exercise we do is we remove a single cable, and we see the effect on global welfare. And you can see a fully white picture. And this is very intuitive with what computer scientists say, which is that the network is actually fairly robust to accidental cable faults. All of the time, like there are 200 cable faults a year, cable faults happen, cable breaks, and the network just reroutes around them and nobody notices. However, if we look instead at the choke point kind of view, the geographic grid kind of view, we see, of course, that these impacts can be very large, and especially if we look at the typical maritime choke points that you might be thinking about. Okay, now, I showed you the two views on geographic concentration and their impact on welfare. Let me go to more, let's say, doomsday kind of scenarios. Let's look at war-like scenarios. And before I just make assumption on what a war-like scenario looks like, I want to show you some historical examples. So this is Cuba. These are cables drawn according to the historical part of our data set, and you can see that Cuba is connected to Spain, with the cables going all the way up north, and also to neighboring countries. This is Cuba in 1898. Now, this is what happened, what the US did at the breakout of the Spanish-American War. The objective of the US was to isolate Cuba and the Spanish garrisons that were located in Cuba from receiving orders from the motherland. And they did that by just severing all cables that could allow Cuba to communicate directly or indirectly with the motherland. Yes. A more dramatic episode of cable wars is World War I, and World War II is not very different, but here you see an episode of all-out cable telecom wars between Britain and Germany. There were more than 61 cable cuts during World War I, and World War II is the same magnitude. And here you can see that they mostly focused on the English Channel and the Baltic as they tried to isolate each other from the rest of the world and force each other to use their own technology that they could monitor and surveil. This war was won, the cable war was won by Britain, and as you know, this played a crucial role in both world wars, actually, as it allowed Britain to intercept communications, as in the famous Zimmermann telegram episode that you might be aware of. Okay, so we have seen what could happen in history, and this is the ship that made it possible. This is the British CS Alert ship that was the first to cut the 5 German cables in one go. And of course, technology has only improved since then. And here you can see media rumors of what cable cutting capable submarine drone would look like. This is a Chinese prototype. Okay, so inspired by these grim episodes in history, we do 2 scenarios. One is a full digital blockade of Taiwan in the spirit of what we have seen happening to Cuba. And you can see here we're cutting, I think it's the 14 segments that that lands in Taiwan. You can see that they are highlighted in black in the picture on the left. These 2 pictures show welfare effects on the left and internet speed on the right. So you can see the welfare effects is barely touching anyone but Taiwan. Taiwan is completely isolated from cables, so they have to rely on Starlink, which, by the way, here we allow use of Starlink, but in the real world, Starlink is negotiating with Taiwan for granting access. It's not done yet. Anyway, here we see that Taiwan would be very severely affected by just relying on satellites, because they have to shrink their demand to squeeze it into the Starlink's capacities. And you can see below a comment that without satellites, actually, the welfare losses would be double, even if satellites only carry 7% of Taiwan baseline traffic. They do absorb quite a bit of the shock. And well, a more interesting, more global, let's say, exercise is to think instead of a more World War I-like scenario of cable cutting in the South China Sea. Here again, you see on the left welfare effects, on the right internet speed. You can see welfare effects being very high in many countries. You can see Myanmar and India and the Philippines having effects between 10 and 15% of their welfare. Here, many things are at play, including the problem of congestion, all of this demand being displaced and congesting everyone else. And in fact, these effects are global, are not only regional. We can show that global welfare shrinks by 3.4%. The US is around 2% for an episode of this magnitude. And speed, which is maybe more relatable as a kind of measure, would fall by 1/3, and in the US, a half. Okay. So, finding number 3, we talked about geographic concentration. We talked about war-like scenarios, so let's talk about ownership for a bit. And another type of concentration I mentioned at the beginning is that this infrastructure is controlled by very few players, mostly from the same countries. And this is true also historically. You can see here the map, again, with our data. going from 1850 to today, where we show the distribution of, like in every year, like you can think about every year as showing the distribution of ownership of this infrastructure, where it's scaled by kilometers length, so that a transatlantic cable counts more than a small domestic one. And you can see the incredible dominance of British firms and the government in the telegraph era. And you can see that in the late 90s, with the fiber optic revolution and the dot-com bubble, the US is taking up a much bigger role. You see also lots of other emerging. That's because the kind of market structure changed. Now it's rare that one firm owns the whole cable. They typically have consortia that bring together local actors. It's a way to obtain access to landing points, but the idea here is that if we just zoom in and look at great powers, it's a story of displacement where the US became the dominant player, and this figure is dramatic for satellites. I don't need to show it. It's the US has essentially a monopoly on satellite technology at the moment. And here, what we can do with the paper, with the model, is to do a scenario, an embargo scenario, where we take here every country, imagine that every country is targeted by an embargo or a sanction regime where the US forbids that country from using their cables. So everyone else can use American technology, just that country, colored here, is targeted. And you can see the effects that this embargo would have on that country's welfare. And you can see, as you would expect, that Latin America is quite heavily affected, especially Central America, given the, in black you can see the American-owned cables. So you can see that the US has a very, very major role in connecting Latin America, and you can see, in fact, that costs are highly concentrated there. And I think, relatively surprisingly, we also see that China is quite dependent on the US, despite 10 years of investments in this technology to try to get a more independent foothold in the world. Okay, so in conclusion, we contribute to the understanding of this problem in three main ways. So first of all, we provide this public good, this new data set that will allow everyone, and us to start with, to study the history of telecommunications. From the very first telegraph international line to telephones, to satellites, and to the internet systems of today. We then propose and estimate a new model that takes seriously the idea of traffic assignment, of routing on this physical network, and of the congestion that might emerge. And we use this model to run counterfactuals, and we can indeed use it to do any kind of scenarios that policymaker might be interested in. And the main takeaways for what concerns the modern period, I would say, is that these cables are real choke points of the modern global economy. They are geographically very, very concentrated, and while the network is indeed resilient to small cable faults, it is by far very uncomfortably exposed to potential coordinated cable cuts events. And it's also prone to hegemonic coercion, given the major role that the US has as a provider of these services. I actually hope I still have the time to open, because I said I wouldn't talk about the response to these kind of risks, but I really would like to show a picture. How long do we still have? A few minutes, amazing. All right, okay. All right, so as I was trying to say, at the very beginning, there is a fourth set of results that I'm happy that I can share, which is to study the response to these risks of investments, of cable building. So here what you can see is the old red line. This is a famous infrastructure investment that Britain did just before World War I. And the objective here was to make themselves immune, or well, let's say insured, against potential attacks from the German submarines or Navy. And the logic here is to build a network that would allow them to reach the world by only touching on land that they controlled, that was colonies or protectorates. And the reason for that is that back then, it was much more difficult to cut cables in the middle of the sea. You needed to reach land. And there are locations where Britain could just put the army in front and scare ships away. So this is, for example, how Britain dealt with this major risk. And, oops, okay. I have the other story to tell you. Okay. And here you see instead how the other countries respond. So you can, as I told you at the beginning, Britain was the undisputed monopolist of cables in the 19th century. And here we see when that monopoly started being questioned. Here is after the Spanish-American War, when it was evident to everyone that this technology was very, very crucial for military success. After this episode that you can see highlighted here by this line, you see that all major powers started building their own network, often parallel to existing British cables. You see here on the left, the United States, France, Germany building most of the new cables in that period. And you see on the right where they built these cables, mostly in corridors that were dominated by British investments and British presence. Okay, so we see this as evidence of, well, these two pieces of information together, we see them as evidence of policymakers being aware of this risk and responding to them. And in fact, there is actually a recent article from The Economist showing that this is also sort of happening already today, where there is a drive to build the cables that try to avoid the Malacca Strait and things like that, that is recently ongoing. And that's something very exciting that we might be adding to a future iteration of this project. Okay, so again, thank you very much for having us in the program. And yeah, looking forward to comments. Here we go. Thank you.
Thanks so much. Discussing is Chenzi Xu.
I think I'll just lean on the podium. Thank you all so much for inviting me to discuss this paper. I injured my back, so I'm just going to lean here. So this is a paper where I learned a lot. So I learned that the data that we all depend on for all of our work basically travels through little garden hoses that go under the sea and across the seabed, and that these little garden hoses, while they form an incredibly effective and efficient network when things are good, also have characteristics of being having very highly concentrated ownership, of going through some geographically concentrated areas, and in some senses being featuring limited substitutability, that actually, the data that we depend on is very vulnerable to what we here would call a choke point. Okay, so the reason we know that now is because the paper has this really incredible new data set that has literally all the ways in which continents have been connected to transmit data from 1850. So the telegraph network, the telephone network, the modern the fiber optic cables, as well as satellites. And a sort of fact that comes out of all of this historical data is that specific countries dominate that global network, both historically as well as today. That dominance has a lot of implications for countries around the world, as Michael showed. And the way that they quantify these implications are through a very tractable or a very straightforward model where you have cables carrying valuable information, but of course there's congestion and there's the possibility of needing to be diverted across different lines. And so because of the way the network is set up, an individual country who is not the hegemon is going to be exposed to different, essentially, sources of pressure from the hegemon because of that control over this network. So one of these is this notion of coercion, where you could be bullied because you depend so much on this cable network. And so you might be forced off of this network, and what would you do if that were the case? Another is this notion of surveillance, which becomes incredibly important during the historical episodes that were discussed, but also, you can imagine how that would also matter today, where if you're transmitting your data over someone else's cables, then that data can be intercepted and used against you. Okay, so both of those elements of pressure from the hegemon who actually owns the cable network in the presence of geopolitical tension will induce countries to invest in their own cables and invest in ways to avoid these pressure points. However, that also comes with its own vulnerability, which is that you build new cables, but those new cables can be cut. And so the multiple historical episodes of sabotage and cutting, or today, I guess, investment in sabotage as well. So what I'm going to do in this discussion actually really complements what Michael presented, because he focused a lot on helping us to understand what's going on in this global network. I'm going to focus on the extent to which decoupling happens from given each of these different sources of pressure, and then how, in reality, countries would be able to do it. And I'm going to also lean on the historical narrative to do that. Okay, so these are the pictures that I had from the paper where we are actually able to see how in the British dominant era you had these sub-sea cables that were all primarily controlled by the British, and today that network is primarily controlled by the US. All right. And throughout everything that I talk about, but also that Michael talked about, in the background you should keep in mind that, you know, data is traveling around these different paths where when you divert a path, it both is costly directly because you have to go through a less efficient path, but also it imposes this externality that's the congestion on the rest of the network. And so, you know, in the welfare that they showed you, that's all incorporated. Okay. So now I'm going to talk about some measures that were in the paper but not in the presentation, which is the ways in which the hegemonic domination of this cable network makes countries vulnerable to the hegemon. One measure is this surveillance exposure. Okay, so this is the extent to which you are using cables and your information is passing through those cables, and that information can be intercepted. And so it's this dependence that is about how much of your data is actually being transmitted on another country's cables. Another is this notion of coercion, where you might be forced off of the network completely, and therefore you have to find a different way to go around it, and so it's essentially a measure of how substitutable are a given country's cables from the alternative. What's interesting here is that even though the two of these are in many ways very correlated, and especially if you think about it, they feel like they should be almost the same thing, they're actually very different, because they're all about, one is about the least cost path, and the other is about substitutability and the degree of substitutability. So just in a, you know, very simple two-node where country N wants data from country J, well, you can see one element where there's a substitute, it's more costly, but you're still okay because it's not that hard to divert, whereas in the other version, you would be incredibly poorly off because it's actually, you know, in, for example, the Taiwan case, what you have as an alternative is something like a satellite that can do very little. We can see this globally in terms of these measures that actually Michael, Christoph, and co-author have in the paper itself. The first on the left here is basically how much of a country's data is plausibly surveyed by the US, which is basically what share of your data is going through US cables. And it's a very dark picture because the US has a lot of cables. The second picture, though, this point about coercion and basically the degree to which you can leave the US network, that looks pretty different. And I think here you can really focus on Australia. So Australia right now has a lot of its data going through US cables, but were it forced off of US cables, there's actually quite a lot of richness of alternative cables in the South Sea area that it could use, and therefore it's less prone to coercion than, say, South and Central America, where geographically they just have fewer alternatives. Okay, so then what does this mean if you are susceptible to these different sorts of pressure points? So this is where you know, my presentation really focused on decoupling, which now really nicely complements what they showed. One of the ways you would decouple is to build a new cable route. And that's going to lower your exposure to coercion because, you know, you're literally on your own cable as opposed to on someone else's cable. And it also lowers the amount of data that's going through somebody else's surveillance. But once you build it, it's also a physical object that's vulnerable to being cut. And depending on where you've built this physical object, it might have very strong vulnerabilities because you might be in physical locations where if someone were to sabotage that physical location, they can do a lot of damage. So this slide is where I'm emphasizing the 3 ways in which actually not having control over the international cable network is costly. And this slide then is to summarize what you would actually have to do if you wanted to decouple from it, right? So the first channel of being subject to corrosions means you just need to find one good enough alternative path. But if you're worried about sabotage, then you might want to actually care about where these cables are geographically and that they're diverse enough from the current sensitive spots. And if you really care about data protection, which I think one can argue today, China, the US does care a lot about that, then you would want to have the hegemon off of every part of the route that you need. Why does this matter? Well, actually, I think the example of Germany in the 19th century captured this dynamic pretty well. So in the late 1800s, Britain decides to kind of weaponize the fact that it has built the most comprehensive telegraph network. And first, it uses that to tell France it can't use it. And then it blockades some of usage during the Boer War. And as a result of these actions, Germany says, we need to build our own network because we cannot, as the Reich, be dependent on Britain. But what Germany does is it builds exactly where Britain actually already has the cables. And that makes a lot of sense from an efficiency point of view. Like, these are the paths that are the least cost. But most of the building is in these brown areas where the British already have cables, right? So then what happens is that the Germans expand along these red cables. Now they have all this new ownership of these new cables, but during the war they get cut. They rebuilt them in the interwar years, and then during the Second World War they got cut again. Every time they were cut, they had to divert their data traffic to other cable networks where they were then surveyed. And so one could argue that a turning point of World War I is when the US joined the conflict. And one reason the US joined the conflict was because it learned of something called the Zimmermann telegraph, which was when the Germans messaged the Mexicans and said, hey, if the US joins the war, we'll help you take over the southwest of America. And so this angered America and was part of the reason they then joined the war. Okay. So, what the paper does actually is it quantifies the response, the decoupling that a country can do in response to exposure to these different sorts of pressure points. In particular, if a country is worried about being coerced off of a network, then it can build its own lines. And so the paper actually estimates, and this is really cool, the amount that a country will build, so the kilometers of new cables that it will build, in response to rises in global threats. And so this gamma parameter that's in the paper is capturing basically how much countries are already thinking about decoupling and how much they're responding to those pressures. What I think is really cool, though, is that the global network that we have and the data and the methodology here allows you also to think about where that new cable is being built and how completely the new cables reroute away from the potential of being surveyed, okay? And so it is actually possible to see where are the new cables or where they are, they would be going. Are they in vulnerable corridors? How complete is a new network? Can the hegemon survey any part of the network? And it's, again, with the methodology that they have in place, it's possible to price each of these responses separately and resolve the model and the welfare implications along each of the new routes. So actually, not only do you have the sense of what are the welfare costs of the current status quo, but also if you were particularly worried about surveillance as a particular country, what would it take to get out of that? Okay. And I think this is actually what the world is kind of looking like it's going to today. So in 1900, we see from the data that there's a lot of duplicate ownership. So when an area is contested, like the English Channel, countries just built in that same English Channel, but then they were vulnerable to attack. Today, countries and firms are investing in cable networks that are in completely different areas precisely to get away from the potential of being caught up in, for instance, a conflict in the South Sea or a conflict in the Suez or in the Red Sea. And that's a list of projects that are basically either in works or are being proposed, where you can see these are paths that are longer, they're more expensive, they're less efficient. And so there's really no reason to do that if all you care about is coercion. The reason you want to do this is because you also care about vulnerability to sabotage. You also care about being surveyed. Okay. And I think this is also an area where, you know, because we know so much about the new projects being proposed, it would be cool to think about combining both what the model predicts and what these new projects say. Okay, so I'm going to conclude. I think this was a really nice paper where I learned a lot. I mean, it's an incredible data set and a really transparent methodology for just quantifying everything that's contained in that data set. And I think what's really cool is that the paper has the ability to separate all these different sources of network dependencies and quantify how hard or easy it would be to decouple from them. And, you know, we always say things have policy implications, but clearly this is where the world is actually investing a lot of money. And so thinking about it with all this data and framework of where the connections currently are actually does have really first order policy implications. Okay, thank you.
Actually, let me kick it off here for questions. I feel like I have 100 questions. They kind of come down to some version of how does the internet work, but I'm going to zoom in on like a specific one, which is at what level of who in, you know, say the United States or other countries actually makes the decision of where data gets routed? Because you could imagine that as an individual, I may say, I don't want my data going to a Chinese cable, but that decision is made upstream. And so one of the questions I would have is, suppose you didn't actually want to invest in a new cable, but a country or a firm said, I'm going to try to internalize my customer's desire to, you know, move this shipment, to move this data. Who would actually make that decision? And is it possible to kind of use your framework to say, you know, if the U.S. were to say we're going to avoid Chinese cables or vice versa, kind of where does the costs actually get shared among the world? Steve?
Super interesting paper. Sorry, I was a bit late, so I missed a couple of things. I was wondering, in the background, there could also be the story that sort of trading goods happens for other reasons, and whenever you ship goods, that generates data flows, right? And so if we didn't have a cable, it might be a bit more costly to ship the information, but the goods trade would still happen, maybe slightly lower volume, but it would still take place. And so in the cross-section, when you look at the relationship between data and distance, it's partly influenced by this underlying relationship between distance and trade flows. And so how do I separate out those sort of other determinants of other types of interaction that generate data flows? I guess the ideal experiment would be a cable cut with nothing else changing. During wars, obviously that's complicated because other things are changing, but maybe like Russian sabotage of cables in the Baltic Sea between non-competent countries. There could be some interesting experiments like that.
So given the specificity of the application, I thought you could go deeper into the outside option, not just being I read out on the existing network, but I can repair the cable, I can lay a new cable. And to me, it was particularly interesting where a lot of the activity might be between two neighboring countries, so the English Channel, but the English Channel is short and is relatively shallow, and so it's easy to recable. And so thinking about how hard it is to actually repair a cable depending on where it's cut, and how easy would it be to, you know, in a pinch, lay a new cable would be pretty interesting.
Yeah, so, yeah, very cool paper. I guess in the model, every bit of information is like undifferentiated, productive knowledge. In real life, it's like mostly entertainment, streaming videos, things like that, right? Like one idea could be like, suppose that my cables are cut, and so I need to reduce congestion. Maybe I just like slow down streaming or something that's slow down some parts of my traffic that are not productive. That's another response.
Want to answer these, then we collect more?
Yes. Okay. Yeah. Let me answer these. Many very interesting questions. So let me start with the idea of routing preferences. So this is so we know, for example, that there is a cable that connects Russia to Europe. Beijing to Europe via Russia, and that cable is not used by internet service provider in Europe. And that suggests that some of these geopolitical preferences or concerns are reflected in routing decisions, also upstream. We do have in mind one thing we can do to talk about that specifically, because for a few years we observed the routes the data packets flow through by country. So we can in principle back out the preference that you might have into avoiding specific territories. So that is, another massive data problem that we have to handle, but we're doing steps in that direction, because for sure that's at least, for big things, it's important, it seems to matter. So in terms of trade costs and data, so the first version of the model we wrote was actually exactly that data flows were meant to reduce iceberg costs, and that was how we linked them to welfare. So it's a very valid point. So what we find when we do our gravity estimation, actually, if you control for geographic distance, you find that geographic distance doesn't matter for data flows, but what matters is the network-oriented distance. So we think that is that tells us that at least the network matters more than just the co-founders, that also can be cultural proximity and things like that. But yeah, of course, this is not a perfect response, and I think there are many ways in which data matters for welfare, and we are capturing one that is relatively simple and easy to estimate to say something more concrete. Which leads me actually to the question on entertainment. So it's true that the share of international traffic that is entertainment is growing, but it's not a major part of data flows internationally, because most of Netflix and things like that, they have their own data hub, their own server in some country, and they use the domestic network rather than the international one. But of course, part of it is indeed low-value data flows that we're capturing, but it is sort of captured by the curvature of the production function a little bit. That the extra, when you're already importing 1 terabyte, the extra terabyte is valued much less than the first. So we have in the background a way to think about that. And finally, well, Matteo's not here, but repair cables. What we have in mind, so it's true, there are ships that are dedicated to repairing cable, but it's only 70 of them in the world right now. And thinking about the episodes in the Hormuz Strait, it's very strange let's say it's not obvious to think that you can send a repair ship and repair a cable in a strait during an active war zone. So we have that concern that it's not obvious that repairs can be done in the scenarios that we are conditional on the scenarios being triggered. So that's why we don't give too much attention to repair. In principle, we could think about characteristic of straits and their ability to be conducive to repairs. That's for sure, but we just don't do it at the moment. Let me just say a word about the discussion also, which, of course, I'm sorry that we focused on a completely different part. It must have felt like 2 papers, because indeed also to us it feels a little bit like 2 papers at the moment. There are two very different ways to sell this, and we just happen to focus on different things. So thank you very much for complementing the presentation with also the other stuff that is in the paper. Okay.
I tried to look it up. It's basically because you assume that the dollar weight of the data sector is 50%, which I'm guessing you're going to have trouble justifying in the long run. I don't know why you need that. You could get like a smaller number, it would be reasonable. And a question I have is there ever a purely economic rationale for cutting a cable here? Like multi-country trade models have this feature that actually raising trade costs in one part of the trade matrix can make some countries better off somewhere else in the trade matrix because of the market access. Is there something like that here where a country may actually want to cut a cable or deprive some country of connectivity because just purely on economic grounds, it's better off.
So a couple of points. One is, I remember an old web page. It used to require way less data to be sent. A lot of the data that we send is not really necessary just to make this. It's pretty. I remember when I was in the army and we need to transmit, we have a microsecond to kind of compress the information. It's not pretty, it's not interesting, but we transmit everything. So I imagine we are in Taiwan, we suddenly have a problem, we only have 40% bandwidth to the satellite, the area is not going to send the second point, so that will kind of reduce the impact there.
A little bit louder, please.
Sorry. Yeah, on the other hand, on the other hand, there is another part of why. Better now? Okay. So there is another part of why the United Kingdom cut the cables in 1914, which is it gave the United Kingdom control of the narrative. So everything is happening in Belgium, the Germans invade Belgium, and the United Kingdom starts spinning out a story about the Germans being very nasty in Belgium. Not that the Germans were that nice, but the British are really able to put things in a much worse way that they were probably are. So I could imagine that one of the problems that Taiwan may face if China cuts its cables is that China is going to be able to dominate the narrative, China is going to be able to send photographs, it's going to be able to send videos, and the average person out there is going to see a Chinese video, not a Taiwanese video about what is going on.
Carolyn? Yeah, so very, very interesting. I did not know anything about these cables beforehand. I was just wondering, so you were very clear about some of the costs. I was just wondering whether you could put some numbers on, how this would compare to the cost of laying new cable. I mean, Chenzi had some numbers, but how would you think about the cost benefit of laying new cables? Another policy that might be useful to analyze, and that might even be relatively costless during normal times would be to have users pay per gigabyte transmitted, which would reward efficiency on the data side and presumably give a tool that can be used in these sort of situations. How would you think about that?
Thank you. So I think what a few questions have been touching on and what I've been sort of wondering is what is the nature of these international flows of data? So does it have to do with trade? Does it have to do with finance? What sort of communication is it? And I think that would help me understand what the nonlinearities would be in a stressed time. So imagine, it's nice for the US to talk to England usually because I can call up a friend there. But if there's a war and I need to make plans because we're attacking Germany, then it becomes really, really important. And so how do you think about that nonlinearity?
Okay, so I think some of these questions are making sort of a variant around the same point, which is a little bit the idea that data can be compressed or shrunk. What's what's the nonlinearity in the value of data, and also okay. So let me address these points. So I guess that so we do have these nonlinear effects in the value of data because we know that these data are partly redundant, partly not particularly productive, partly not very valuable. So we do think that being able to transmit a small amount of gigabytes per second is very, very valuable compared to the extra gigabyte per second that you can transmit after the millionth terabit you send. But still, there is a fundamental way in which the network is wired, for which it's very hard to all of a sudden switch to a very compressed kind of communication. Perhaps for the military, that's what the military would do, be very efficient. But for the average person in Taiwan that opens their phone, they will find that they just cannot access the websites that the Wikipedia, for example, which is hosted in Singapore, for example, of what these data flows are. So what these data flows are many things, including, I think, trade and finance. AI, for sure, is a big part of it now, and these are all valuable and productive inputs into countries' economies. I agree that we might be, at the moment, we are probably being a bit exaggerated on the dollar weight we put to that input of production. It does come from an estimation exercise we do, which doesn't mean that it's the right number, but it means that we are indeed working on disciplining that specific parameter, and I think we have a good methodology. We just have to nail it down, and then we will have a defensible number. 0.5 is on the upper bound, but the lower bound of what we started doing is still 1/4, sorry. So that still suggests very high welfare effects, similar, well, not similar, but in line in terms of magnitude to what I presented today. Just another thing, controlling the narrative, yes, that's an unmodeled cost of losing access, and we know how important that is. And I think that actually speaks to a potential even further effect of why you actually want to send videos of cats during wartime, right? Because you might be able to send things that become viral on the internet to push the narrative and rally support around a specific cause. And cost of laying new cables, so that is for sure something we're moving towards. For the part of the paper that studies investments and decoupling, we do observe costs, so we can do a cost-benefit analysis for sure. We of course need to, as was suggested by Chancy, to simulate the model to estimate the added value of the extra lines. That is extremely computationally costly to estimate all, but we'll get there. It's feasible, and we have the machinery to study also that, so why not? Okay. Well, pricing per units of data, the question of why don't telecom companies price? Well, they do. They, you typically pay a fixed price for accessing a certain amount of gigabytes per second of connectivity, and this also scales up to the level of companies where they typically actually have to pay per route. So if you want to establish a route between London and Rio de Janeiro, you pay based on how much you want to send on that route. So pricing does indeed reflect the cost that we talk about. And in fact, one of the validation exercises is exactly to show that our latency measures can predict prices essentially with an elasticity of 1, which is one of the restrictions that we assume, and that is good to see that it's burned out by the data.
Okay, one more question from Mary.
Thinking about the traffic along the cables can be controlled more than just the congestion through the electronics, but who is able to move data through the line. So something you think about air traffic control, you don't bomb airports or terminals or runways necessarily very costly. You do a full stop on air traffic and ground planes. So in principle, it's getting much more nuanced in terms of the flow rate. I don't know if Starlink is sort of the neutral arbiter of world communication organization, but they have an ability to decide who accesses and when and time. So think about that multilateralism and how the traffic flow might be less rigid and won't protect the infrastructure that would be implemented intentionally.
I'll let Richard understand.
Yeah, something like the last question, but with data encryption, I'd imagine that the value of surveillance is less. The most sensitive, financial, or important information is going to be sent encrypted, so maybe the value of surveillance or effectiveness goes down. And then if there's any instances of satellite sabotage, but not the satellites themselves, the transmission system, saying you don't have to, enable the satellite, you just have to interrupt the signals going back and forth. And I've got some sense of, call it the Russians may be trying to do that with the Ukrainians and their Starlink systems. So,
Yes.
So there, any instances of satellite sabotage.
Last word?
Yes, thanks for this amazing question. So about the routing, it's an automatic system of routers that are coordinated around the world via very complicated, it's called the BGP table, I think, where they have, immediate routes and alternatives if that route is too trafficked. So it's a very automatic system. In fact, our assumption that rerouting goes immediately to the optimum is probably too optimistic about how the network is actually routed, but there is an element of automatic routing and less control of routers on where traffic actually goes. It's something pre-specified, let's say. Data encryption, I agree, that limits the value of espionage. Still, it means that if you intercept data, you can put code crackers into it and get information out of it, just like the British did during World War I and II. So encryption, is valuable, but it also has limitations. For sabotage in satellite domain, yes, that's a very hot topic right now. First of all, it's relatively easy to jam satellites. You have to be in Taiwan to jam satellites that Taiwan can access, but that could happen. And but the second kind of sabotage that is worrying about satellites is that both China and Russia are experimenting with capabilities to actually directly attack satellites. So that kind of things, there is a lot of redundancy, especially in Starlink. We're talking about now, I think, 12,000 satellites in orbit, and each of them is relatively not particularly important, but these capabilities are, of course, worrying and, of course, reflect the importance of satellites as a strategic value that we highlighted with the Taiwan case, right? I think the point we try to make with the Taiwan case is that satellites have a lot of buffer value, and therefore they are valuable targets for adversaries. All right.
Thank you so much. Back at 2:45. Listen, we're 4 papers in, and at most we're gonna be 2 minutes behind. Let's actually just relax a bit. All right, 6 to 8:30. All right, Chenzi, I'm looking at you. All right, everyone, come on. Chenzi, come on. All right, we are very excited to have Andre here to tell us about geopolitical payoffs. You have 30 minutes.
Great. Thank you very much for having me. It's a real pleasure to be here. This is joint work with Henry Young, who is right there, and Nitya Pandalanayar, who is not. Let me just say that, you know, this conference has reminded me a bit of this cooking show on TV where 4 chefs are given the same 4 ingredients and they're asked to cook something. And they inevitably cook different things, I hope. So we'll see. I promise you a different dish, but we'll see. All right. So we're entering a new era of geopolitics, in which, you know, there's increased great power competition, and during this competition, countries engage in costly actions, such as, you know, sanctions, foreign aid flows, forming alliances, and so on. These actions have a cost of an explicit one to the countries doing them, but it's not always clear what are the economic payoffs of costly actions. So, you know, this literature has been very active, but it's very often the case that the benefits of these actions are put kind of directly into the utility function, right? I may have preferences of another, sort of welfare of another country explicitly my preferences, or I may experience a dislike shock for some country in the next period, and so I'm going to do something costly today to prepare for it. And so we want to kind of depart from that a little bit and try to understand with some measurement what are the economic payoffs of costly geopolitical actions. And we're going to evaluate a particular hypothesis, which is that these geopolitical actions increase the market access of the country that's undertaking them. So, you know, we're going to then focus on one particular geopolitical action, which is foreign aid. The foreign aid is, in a sense, the lowest hanging fruit because it's directly measurable and it is in dollar terms. So we can observe, in a sense, a cost to a country of doing something with respect to another country bilaterally. And that leads us, of course, to a secondary motivation behind the paper, which is that there's big things happening in the aid world. The US has dismantled USAID, and we can also kind of see what aid does to the welfare of the countries that are disbursing them. So we're going to do 3 things in this paper. The first is we're going to put together some data set on bilateral aid. This is actually going to be some of the same data that the paper earlier this morning had. So we're going to go to the same CIA handbooks and get the data for USSR and China. But then we're going to have also aid from the Western countries that's coming from the OECD aid database. So that's going to give us 26 donor countries and 133 recipients, and we're going to focus on the Cold War period. So our data are going to run from 1960s to the fall of the Berlin Wall. Then, kind of a necessary condition for aid to improve market access is that aid increases trade. So we're going to run some regressions to see whether aid from a particular donor to a particular recipient also leads to increased exports from the donor to the recipients, right? That's the notion of increasing market access of the donor. And we do find that that's the case. So $1 of aid increases donor exports to the recipient by something like 46 cents contemporaneously, and by something like $1.40 at 5-year horizon. We're also going to show that aid reduces the bilateral geopolitical distance. We saw that earlier today in a different paper. And then we're going to have some results that suggest that also it may crowd out market access of a rival bloc. So when the US gives aid to a particular country, it seems to also reduce somewhat, the recipients seem to also reduce somewhat the imports from the rival bloc, so from the Soviet Union, controlling for the usual multilateral resistance terms, so it's kind of over and above the multilateral resistance. Okay, so that's a bit the necessary condition. If we're going in search of market access, it better be the case that aid increases trade, so we find that it does qualitatively. But then what we really want is some evidence that it may be self-interested from the donor perspective, that the benefits of this market access are large enough to justify the aid outlays. And that we cannot do purely with data, so we're going to set up a multi-country trade model that calibrated to this data set of 26 donor and about 100 recipients during the Cold War period. And we're going to simulate what happens when aid is cut. So we're going to take an 86% aid cut just because that's what the US did just now. And it turns out that there is some benefit of this increased market access, but in the end, it's not enough. So the direct cost of aid is higher than the market access benefit that the US gets from this aid. In a baseline result, the market access benefit offsets about 25 to 30% of the direct cost of aid. Then we're going to kind of perform a broader search for these benefits. So we're going to look at also USSR and all the other 24 donors. And we're going to look both kind of at the donor level. So, maybe the US aid doesn't pay for itself, but maybe Belgian aid pays for itself. We find that there's essentially virtually no countries that disburse aid in such a way that it pays for itself. We're also going to look at country pairs, and there isn't any sort of relationship where countries give more aid to recipients with whom the market access benefits are particularly large. So we're going to kind of do a global search with all the donors and all the recipients, and we're essentially going to find that it's almost never the case that aid pays for itself. Then we're going to look at the impact of aid on geopolitical alignment, and we're also going to find that there's not a ton of large changes in geopolitical alignment that aid can engender based on our estimates. So, in a sense, it's a negative result. I was hoping for a number 100% or greater, but we're nowhere near that. So it's not nothing, but in the end, I don't think we have a theory or a quantification that says that this particular geopolitical actions aid is self-interested in the way that we can measure. So the search continues. Okay. Let me skip this. All right, so we collected this data for aid. Most of it is the standard source, which is the OECD, supplemented with the data for the Soviet Union. This is the aid, the absolute dollar aid disbursed by donor country on the left. Maybe it's a bit hard to see, but the U.S. is by far the largest disburser of aid over this period. USSR is in the top 4. But the other countries in the top 5 are somewhere around 1/3 of the US dollar volumes over this period, and then there's a tail of countries that in dollar terms don't distribute that much. If we did it as a share of the donor GDP, this would look different. Then the Nordic countries are going to have the highest aid disbursements as a share of their GDP. But in terms of absolute, I think this is, in some sense more useful. On the right is the aid received as a share of total global aid. Here, the big players are India, Pakistan, Egypt, Turkey. These are kind of middle income, strategically important countries, as you might expect. Again, if we did it as a share of recipient GDP, this would look different. This would look more like the poorest countries are receiving the highest amount of aid as a fraction of their GDP. Okay, so the next thing we're going to do is we're going to run a gravity-style regression in which we regress trade from origin O to destination D. So O is the country disbursing aid, D is the country that's receiving aid. On aid, between that origin and that destination, with the usual fixed effects. So there's going to be something slightly unusual here, which is that this is a gravity regression estimated in levels, or in levels normalized by the GDP of the destination country, the lag GDP of destination country. And there are two goals behind this slightly necessary specification. The first and probably the less important one is that aid has a lot of zeros. It actually has way more zeros than trade. And so, you can do PPML to sort of take care of the zeros problem on the left-hand side. So we know how to do that. That's not the problem here. Actually, trade is not that empty. But aid is empty, and we don't have a natural way of dealing with the zeros on the right-hand side. So if you do it in levels as a share of GDP, that takes care of that problem. And the second reason is that we're going to show that the path of the trade increase following an impulse in aid at some year t shows continuing changes in trade for up to 5 years. And so when we estimate the total market access benefit of an $8, we're going to need to kind of like cumulate the changes in trade over a period and divide it by the changes in aid over a period. So that puts us in the fiscal multiplier literature, basically. We're going to take this method from Valerie Ramey, and that method cannot be done in logs, right? Because you cannot add logs over time. So you cannot add, the log fiscal stimulus from year to year, but you can add the dollar values. So that's what justifies that. Having said that, in the paper we'll repeat the entire analysis from beginning to end with your typical log linear trade specification that people are much more used to, where we do aid. So mostly we do inverse hyperbolic sine for aid in that specification, and everything basically goes through. And then we need to instrument for aid. So here we're going to rely on a Rajan Subramanian style instrument where we take total aid outflows from some origin country O, obviously dropping the particular destination country, so leave one out. And we're going to cross it with the predicted share of aid from country O going to destination D, this lambda hat here, where lambda hat is going to come from auxiliary regression, where we regress aid flows in the data on various predictors like bilateral distance, colonial ties, past political alignment of the governments and so on, and generate an aid prediction that then we turn into a share, this lambda OD, and so it's kind of an interaction, right, between, so it's a kind of a shift share, except there's no summation, right? So where the shift is the total aid coming out of country O, and the share is this predicted share of that total aid that's going to go to country D. But because our sample is bilateral, so it's at the OD level, there's no need to sum over the O's. Okay, so there's 3 regression tables. First is, does aid increase trade? And the answer is yes. So the key coefficient is this 0.46. So $1 additional of aid increases trade contemporaneously by 45 cents and by $1.37 5 years later. So there is definitely an impact of one on the other. Aid also seems to increase geopolitical alignment. So this is going to be a regression that is going to overlap with what we saw earlier. Except here we're doing it at a bilateral level. So this is the geopolitical alignment between O and D. Since we have 26 donor countries, we can do that here in this exercise. So aid does seem to increase geopolitical alignment. That's result number 2. And then result number 3 is that aid decreases the market access of the other block. So here the regressor is the trade flow from the other block to destination D, right? So if US gives aid to Egypt, then aid from the US to Egypt is over here. And the left-hand side is exports from the Soviet Union to Egypt, or from, indeed, like the few Soviet bloc countries we have in the data set to Egypt. And we see that, on the impact, there's nothing, but 5 years later, that trade goes down by about $2. So this is over and above the usual multilateral resistance terms, right? Some of that is going to happen naturally with changes in the market of the destination country. But that's not what that is. That's already controlled for, so it's over on top. This is the bilateral dimension of the trade with the other bloc. All right, so as I said, the necessary condition for aid to improve market access and deliver potential benefits to the donor is satisfied. Aid does seem to increase donors' market access to the recipient. But then we cannot go further with the empirics because the empirics don't tell you what are the benefits to the donor of this increased market access and how do they compare with the costs. So here we're going to set up a plain vanilla trade model in which there's going to be a bunch of countries. So in our case, it will be like 130 countries. There's going to be a few sectors. So for us, it's going to be 4 sectors, pretty aggregated because, we're talking about, the 100 poorest countries in the world in the 70s. There's not a ton of detailed sectoral data for those countries. So we're going to have 4 sectors: agriculture, commodities, manufacturing, and non-tradables. And the household is going to maximize this Gauss aggregate of all the possible consumption sectors J. And the budget constraint is going to have aid in it, right? So the household is going to consume, so this is the consumption spending, is going to consume out of the labor income. Labor is the only factor of production. And then is going to consume this aid that it received from all the possible origin countries O. Right, so aid is essentially a transfer from the recipient to from the donor to the recipient, and the recipient gets to eat it. And then if you're a donor, right? So if you're a poor country, you get this plus aid OD summed across all the origins. If you're the donor, then basically you are subject to the lump sum tax TD that then pays for your aid flows out into the world, right? So if you're a donor country, you're directly reducing your consumption here by this amount, which is the total aid that D disburses to the rest of the world. And then there's an exogenous trade deficit to match the data. And then we have the standard input-output structure that we also saw a bunch of times this morning. So the aggregate of the sector J In country F, in country D, sorry, is Armington in the imports from all the other countries with the Armington elasticity epsilon. And then these varieties are produced with the Cobb-Douglas production function that takes labor and then inputs from all the other sectors in the economy. Okay, so a completely vanilla model. Just we have this aid inflows and outflows. Okay, and then there's like really one crucial parameter that we need to calibrate, which is the elasticity with which aid decreases trade costs. So we're going to say that there's these iceberg trade costs, tau OD, to go from origin to destination that are made up of some exogenous component, and then the aid flows from O to D and to the power of some elasticity chi. Well, here, if we had a log linear gravity regression that we've all seen hundreds of times, we would basically take the coefficient on aid from this gravity regression and divide by the trade elasticity, and that's going to give us chi. And again, if that's what you like, we have that in the paper, like essentially all the results that I show you here are going to be replicated in the paper with that. Here, because we're doing it in levels, this elasticity is not constant. And this elasticity is going to need to be multiplied and divided by the aid to trade ratio between this pair of countries to turn this into an elasticity, which would make the trade benefit of aid heterogeneous across country pairs in this particular way, which is that if you give a lot of aid and you don't trade that much pre-shock, the model is going to say that this elasticity is high. So, $1 of aid is delivering you like a huge trade benefit because you're starting from a low base of trade, and vice versa. So again, we can think of this as a feature or a bug. I'm not really sure, but there is some heterogeneity that gets induced there. Just as a benchmark, though, this chi-OD for the US is something like 0.3 at the mean, and for the USSR, which it doesn't trade that much, with the rest of the world, it's like 0.6. Okay, and then I'm going to show you some results where we're going to also have a trade diversion term, where essentially when you give aid, when O gives aid to D, then D increases its trade costs with the opposing block, and that's going to be this term, and this V is also going to come out from the regressive specifications that we're on. Okay, so here are the main results. We're going to take the US in the 1970s, and we're going to reduce its aid budget by 86%, so that's the current US aid cut. We can do it by 100, nothing really changes. What happens in the baseline is that the US's welfare goes up by 0.15%. This is roughly commensurate with just the cost of aid, kind of the direct cost of aid in this case. However, if the US did not receive the market access benefit of the lower trade costs to these countries, the US welfare would go up by 0.21% to 0.205. And the difference between these two numbers is essentially the extent to which market access benefits offset this direct fiscal cost of aid. So that's something like 27%, right? It's the comparing 0.15 to 0.205. In case where we do trade diversion, so the Soviet Union's aid, the Soviet Union trade falls when the US increases aid. Actually, the welfare changes for the US don't really budge that much. There's not enough interdependence in the trade network to really have a big impact. And perhaps what's a little bit more surprising is that it doesn't really change the fortunes for the Soviet Union that much. So that's the last column there. It's essentially 2 decimal points behind the impact on the US itself. So even with this trade diversion effect, putting out aid does not really allow the US to hurt the Soviet Union that much. I guess one more thing I should say is that actually the change in trade share is quite massive here. So the US trade share to the recipient countries falls by something like 37%. So what is this? This is not, it's not that aid does not change the trade share that much. Aid changes the trade share a lot. It's that, you know, most of the time these are small countries that are not important for the US market access, and so the welfare benefits are small because of that, or the market access benefits are small because of that. Okay, so I'll skip the Soviet Union since I'm almost out of time. Okay, so now let's do all the countries, right? So we can do donor by donor and see how much does welfare change when this donor reduces aid by 86%. Those are the white dots. So in every case, the donor welfare goes up, meaning that the market access benefits do not compensate fully for the cost of aid, except for Spain, Portugal, and South Korea. These are countries where aid essentially pays for itself, but these are also the least important donors in some sense relative to their own GDP, right? They're not big donors. So that's at the donor level. Then we can go down to the country pair level, so donor recipient level, and ask, you know, what is the fraction of either aid dollars or aid relationships, like country pairs, for which aid pays for itself? That's the right graph. So the blue bar is the share of aid dollars where aid pays for itself worldwide in this all donors column, and it's basically 1%. So 1% of world aid pays for itself, and only something like 10% of donor recipient pairs aid pays for itself, right? Again, there's some heterogeneity, so Portugal manages to have 50% of its aid dollars or recipients pay for itself, but for the most part, these are tiny numbers. So in that sense, it's a negative result. Okay, let me skip this. Let me say a word about the recipients. So this paper is not recipient focused, but here's something on the recipients. Just two graphs. The first one is an attempt to break it down into spheres of influence. So what we're plotting here is the change in real income of the recipient following a US removal trade on the x-axis and USSR removal of aid, sorry, not trade, on the y-axis. And what you see here is that countries that are above the 45-degree line are ones in the US camp, meaning that the US aid for those countries has much more impact than the Soviet aid, right? So these are countries over here. And then below the 45-degree line are countries where the Soviet aid makes a much bigger welfare impact. And you see that essentially spheres of influence are dominated by the US. So out of these 100 or so recipients, something like 63 on average over this period are in the US camp and 6 in the Soviet camp. So the Soviet camp, there's not that many countries where the Soviet Union really dominates. And then this is the cost of aid to the donor. This is the US on the left and the Soviet Union on the right, plotted against the geopolitical distance. So this is the cost of aid inclusive of market access, right? Not just the fiscal cost. And what you see is that the costliest aid is actually, with the exception of Israel for the US, the costliest aid is actually for countries that are that have like a mid-level of alignment with the US or the Soviet Union. So these are countries like India, Turkey would be emblematic here, right? So it's just another kind of data point to say aid is mostly not about market access. These countries that are very expensive are countries that are not particularly aligned with the US geopolitically. Okay, and finally, this is going to be very similar to the exercise that was done earlier today. We're looking at the geopolitical alignment change when we cancel aid. And what we're plotting here is the observed geopolitical alignment on the x-axis and the geopolitical alignment in the left graph, where you completely cancel US aid. And the countries that are on the left in red are countries in the Soviet camp. In the blue on the right are countries in the US camp. And what we're hoping for is something in this quadrant. If a country was in this quadrant, it would mean that US aid had moved it from the US camp, from the Soviet camp to the US camp, right? And we find nothing there. Essentially, the before, with no aid and aid geopolitical alignment are on the 45-degree line, and it's the same in the Soviet Union. Okay, so I think I will stop here. Hopefully it was pretty clear. Yeah, thanks.
The discussant is Jesus Fernandez Villaverde.
Okay, thanks for inviting me to discuss this paper. So what I want to do first is to quickly review the main results, since the paper has many of them. The first set of results is purely empirical, and I will say there are 4 things that you want to take away. First, that aid buys you market access. The authors implement what I think is a plausible exogenous rise in bilateral aid disbursements, and that significantly raises the donor's exports to the recipient. The second one is that the effect grows over time, is $0.46 for every dollar that you spend on impact, grows all the way to 1.37 5 years out. That aid seems to buy you friends, but not really best friends, in the sense that they will vote for you a little bit closer in the United Nations, and that it seems that if you give to someone, then they will get a little bit less from the other side of the Cold War. The second set of results are quantitative. The paper builds a full model. It's a, kind of a state-of-the-art multi-country trade model calibrated to the Cold War, and 26 donors, including the Soviet Union and China, and 101 recipients. And then they add the aid channel, measured as aid flows plus the market access benefit estimated from the previous regressions. And the main thing is that market access matters, but it doesn't pay for itself. Okay, and I think this is very nice, because you always hear this idea that, hey, we are going to give aid and we are going to recover it through the back door. Well, there is something to the argument, but it's not all the argument. The same thing happens for the Soviet Union, and as Andrei was mentioning at the beginning, you have these interesting cases of Spain, Portugal, and South Korea, that I will come back to them a little bit later, because even if you were trying to say that they are not that big, I actually think there is something interesting about the 3 of them. And finally, the paper also has a component about geopolitical alignment, which is that doesn't seem to be the case, that there is a lot of relation or link between cost and alignment, and that who you really want to give money to is people who are in the middle. That kind of makes sense. It's like when you are doing campaigns, I'm Republican, I'm not going to campaign in Utah, they are going to vote for me anyway. I'm not going to campaign in San Francisco if I'm Democrat, they are going to vote for me anyway. I go to Pennsylvania where, all my neighbors are not quite sure who to vote for. And that was a little bit the case of India. In the one hand, India was a democracy, and it was basically a market economy, and they were more or less aligned with the West, but on the other hand, it got a lot of Soviet hardware. If you actually take a look at the Indian Air Force, you will realize they fly MiGs. And this was important. The Indians were able to get money from the Soviets and the Americans, but no one really switched camps. Okay, this is like a friend with benefits. At the end of the day, you don't really cross the line into something different. So once I have summarized a little bit the results, let me give you an assessment of the paper. And I really like it a lot. It was a really nice paper. I enjoyed tremendously because of several reasons. First of all, because of data collection. There was another paper this morning doing a similar data collection, but that doesn't take anything out of the value of going there and figuring out how much money the Soviets and the Chinese were giving to people around. The interpretation is very clear and intuitive. It's not one of those papers that you read and you go over, page 7 times because you don't quite get what is going on. It's very clear, it's very well written. And that's something that I always tell all my graduate students you should always do, which is have a good empirical section and a good quantitative model, and both of them speaking to each other. And it puts hard numbers in a literature that often has been too narrative. I don't have a lot of time, only 15 minutes, but if you go to political science and international relations, there are tons of monographs about aid and what aid does to you and what you can buy with aid, what you cannot buy with aid. And you read the books, and you're like, okay, whatever. This guy has written 300 pages, but at the end of the day, so what? And this is good. This is changing the literature to a completely different level, where instead of having 300 pages, what you do is you have hard numbers. And that's really very nice. My comments are not really criticisms of the paper, but extensions. And I think that the paper really opens the door to a lot of stuff that can be done very nicely. So my 4 comments are going to be about data, what counts as a dollar of aid. The second one will be at the point estimates, both in terms of indirect and strategic effects. Then I think I would like to understand a little bit better the mechanisms that the paper underlines in terms of why does a dollar of aid come back, the effects, static versus dynamic effects. And finally, as I was mentioning before, I'm going to have a coda with Spain, Portugal, and South Korea. So let me start with the data. So I was trying to read in the appendix. I wasn't 100% sure about these things, so please correct me if I'm wrong. But I know a little bit about military hardware. And I know that the problem with military hardware is that the price that you put to it is a price, a cost. But that doesn't really tell you much. Okay, so this is a photograph of Daedalus. This was the aircraft carrier that the Spanish Navy, the Spanish fleet, operated for around 25 years. This was aid by the Americans. And this was a pretty old auxiliary carrier that the US Navy was about to disregard. They gave it to Spain. You can see that the landing is actually pretty small. You can only operate very small planes. These are Harriers. And how does this show up in the USA? Does it show up at the price it was accounted for when it was built during World War II? Does it show up at its real value in 1963? In 1963, this pretty much had only scrap value for the US Navy. The second thing that is very important is that the aid many times will need to be computed by hedonic prices. Let me give you a very simple example. The US goes and exports F-15s to Saudi Arabia. And you look at the photographs, and they will look like the F-15s that the US Air Force is operating. No, they are very different planes. So the really, really sophisticated stuff is not on the version of the F-15 that you are exporting to the Saudis because you don't trust them. So the export versions of everything, all military weapons, are actually very different than what you are actually doing. And in addition to it, often you sell below, you don't really give grants, but you have below market loans. And how do you actually account for that? Access to credit. For instance, imagine that the only thing I'm doing is giving you some lines of credit. This is particularly important in Comecon. What do prices mean in a socialist economy? You told me once that your mom used to work for Gosplan, no? So what does it mean, a price in a socialist economist? So imagine that you're the Soviet Union and you want to keep the Cubans happy because they are a pain in the butt of people in Miami, like down there. And what you have over there is that the Soviet Union bought Cuban sugar well above the market price and sold them oil well below the market price. And that was the real transfer. Does that show up in the data or not? And that means that maybe the denominator is going to be a little bit too big. Maybe not. But it will be interesting to understand this a little bit better. Now, there are indirect effects. And this is the purchases from friends. So let's think about one of the big recipients of aid in your data set is Egypt, first from the Soviet Union and later from the United States. So Egypt during the 1960s got tons of military aid from the Soviet Union. This is a T-54-55. It's kind of difficult to tell from this photograph. This was destroyed in 1973 in the Battle of the Chinese Farm. And these were sold at a below price by the Soviet bloc, but they were not manufactured in the Soviet Union, they were manufactured in Czechoslovakia and Poland. So yes, they were paid by the Soviets, but they were accounted in a very different way. And this happens all the time. The US gives aid to someone, and maybe it's not that this someone is buying from the US, it's going to buy from Germany or from France or for the United Kingdom. Also, I think it will be interesting to think about aid as a best response, not as a return. And over here, I think there is a fantastic paper, and the best thing you can do in a discussion is to praise the organizers of the session by Clayton and Jesse and Matteo, sorry, I'm blinking now. And basically what they try to think is about this strategic interaction between two hegemons. And my favorite example is Vietnam. So during the end of during the last kind of 6-7 years of the Vietnam War, what North Vietnam will do will be the following. They will go to Moscow and say, oh, the Chinese are giving us more money because they are the true revolutionaries. And then Moscow will go, no, take all this money because we are more revolutionaries than the Chinese. And then the Vietnamese will go to Beijing and will say, oh, the Soviets are giving us all this money because they are more revolutionary than you. And the Chinese will go, no, you need to have all this money. So you want to think a little bit about that. It's an extension, it's not something that you would probably need to do in this paper, but this will be really nice. Now, I was thinking a little bit about the mechanisms. Why is the case that aid really makes such a difference? And I think that one possibility worth exploring in a follow-up paper is the technological lock-ins. And it's the fact that aid often arrives as equipment or as technical assistance, and that locks you into future sales, like spare parts, upgrades, maintenance. And this is particularly important in modern weapon systems because actually running a modern weapon system is way more expensive in terms of maintenance than the sticker price. Coming back to the example I was telling you before, I was explaining that the Soviets gave all these T-54s and 55 to the Egyptians, but Sadat expels the Soviet advisors in 1972. So then basically the Egyptians have a problem that these tanks are not really very useful anymore, and the re-equipment on US systems has actually cost billions of dollars to Egypt, and is still not complete as of 2026. This is a modernized version of the T-55. This is called Ramses II. And you can see over here how it's landing actually from a US ship. And this is a joint exercise between Egypt and the US Armed Forces. And this was modernized with US technology. But this is very difficult. Okay, it's like taking an old house and putting a new AC. It's actually quite different, quite difficult. But yet that goes beyond weapon systems. Think about, for instance, the fact that much of modern technology has many QWERTY features. And my favorite example is calibers. Okay, so over there you have two types of bullets. These ones are both of them are 7.62, which was the standard caliber for an assault weapon during the 1960s and 1970s. But this is the NATO standard, which is 51 milliliters. This is the one that I use. And this is the Warsaw Pact standard. This is 39. The problem is, if you get here from the Soviets, you get stuck in using this today. And even today, Egyptians use this type of caliber. So this is the type of things that I think are very important to understand. And I have many other examples. Railway gauge that you get with the Chinese. They convince you to use one particular type of railway gauge, or the Soviets back in the day, and that's going to buy you into buying Chinese stuff in the long run. Electric power, are you going to use 60 hertz as the US or 50 as Europe and the Soviet Union? Nuclear reactors, even today Rosatom tries to sell you reactors at a very, very cheap price because what they really want to do is make money out of the fuel. Think about Hewlett-Packard. Hewlett-Packard sells you very cheap printers because you are going to buy Hewlett-Packard cartridges. The same thing you could think today about telecoms like Huawei, 5G, etc. Another interesting mechanism that will be interesting to explore is changes in taste. And over here, I want to point out the PL-480 food aid, which was basically how the US sent a lot of food to other countries during the 1950s. This is a bunch of grain arriving to India. And what I think is very interesting over there is that by giving food aid, you are also changing tastes of people. And this is an actual photograph of cheddar cheese that was donated by the United States of America to Spanish schools. And my dad always remembers, and he has told me many times, how for dessert at lunchtime in the cafeteria in his small school in a village in the middle of nowhere in the north of Spain in the 1950s, they will have these big fields, and they will give him cheddar cheese. Although, to be honest, that's the reason why he claims he cannot stand cheddar cheese. Anyway, but the point is there is quite a lot of evidence, for instance, that because of the grain shipped by the US to Japan and South Korea, bread became more popular in these two countries, and they still buy a lot of wheat from the United States. So this will be very interesting to explore. The model is static, the empirical results are dynamic. I'm fully aware that computing dynamic models is very complicated, but it will be interesting to talk a little bit more about the relations between the short-run impact, the long-run impact, etc. I already mentioned India and Turkey, and I only have 59 seconds left. So let me use the last few seconds to talk about Spain, Portugal, and South Korea. Yes, they were small recipients of aid, but the three countries were characterized by being miracle countries. They grew very, very fast. So maybe what is really driving is not as much the size of the aid, that the fact that these countries were really growing a lot. And I think there's a very interesting research avenue, which is the interact of aid effect with recipient growth. It is an aid a bet on takeoff. It is about picking winners. It is donors. It is luck, etc. But let me conclude. This is really, really a very nice paper. It opens the door to much follow-up work, which is absolutely the best you can say about something. So please go ahead and read it, because you are going to enjoy it a lot. Thank you.
Fantastic. So let's collect a few questions. Chenzi?
Hi. That was really interesting. I had a question about how, how you tie aid to then ultimately the conclusions about welfare and whether it pays for itself. And it seems like in your model it all lands on the iceberg trade cost, which, and I was wondering if you could talk a little bit more about what it would look like if instead you thought about it as like a preference shifter, or something where it's like looks a little bit more like tide aid. It just feels I just find it interesting that an iceberg trade cost is like really a technological change. Fewer resources are depleted, which feels very different from you give aid to a country, the country likes you more, and they'll just want to buy more of your stuff. Yeah.
Lena?
First, just a comment. There are a lot of aid papers written by political scientists that have theory and data. So I have to defend the four of us who are in the room. So in some of those papers find that aid is affected by alliances, right, and that trade is also affected by alliances. And so it might be the case that if aid and trade are related, it could be sort of a result of their foreign policy preferences and not actually a driver of foreign policy preferences. So maybe one thing to think about. A second one is about this kind of about the domestic political economy in the donor countries, which is that who benefits from market access versus who pays for the cost of aid are going to be different constituencies, right? So once you start to open that up, there might be sort of different political costs associated with it. And then I had the same question about whether or not some of the market access effect that you're seeing is actually just the result of tide aid, like U.S. like PL 480 kind of require you to buy U.S. manufactured or U.S. grown food. Thanks.
Matilde? Was that the one about political science? No, kidding. John?
Following up on the same theme as Chenzi, one natural interpretation is that it's not iceberg trade costs, but changes in policy, either by the donor or the recipient country. But we know from trade theory that it's super important for welfare. Is it the donor who is subsidizing trade with the recipient, and it's bad for the donor's welfare, or the opposite? So if you have anything in the data you can see about trade policy, that would be super useful.
Andre, why don't you take this initial set, and then we'll open it up for more. Great.
Thank you very much, Jesus. This was a great discussion. Certainly, all the points are fair, and we need to chew on them. I don't have anything to object to or clarify. Yeah. So on the question of what is it, we need to think about it more deeply, clearly. So there is this, for some purposes, isomorphism between iceberg trade costs and preference shifts in terms of how they're going to affect trade shares. It will matter, or like relatedly, whether it's a tariff or some iceberg trade cost is going to matter a lot for the recipient welfare. So we completely acknowledge that. But from a perspective of the donor, I think what matters is it shifting my demand curve for my goods in this country or not? And for that, I don't think it matters that much whether it's like a shipping cost or or a preference shifter or even a tariff going down in the other country. So, we don't emphasize the welfare results for the recipient, but for the donor, I think it should be quite similar. Tied aid, yeah, so I don't view this as a problem for what we're trying to do. Again, what matters is this aid increasing demand for the stuff that we produce? And even if it's tied explicitly, I don't view that necessarily as a problem for me. It could be part of the story. Domestic distribution of effects, completely. That's fascinating. We're going to try to think about that more and what we can do in the data context. But yeah, absolutely, that's super interesting. And then alliances, well, so this is hopefully the job of the identification strategy, right? We have this exogenous change in trade, or we claim is exogenous. Some of this might get absorbed by the fixed effects as well. So we have country pair fixed effects throughout. So if it's a country that just fundamentally gets a lot of US trade and aid, that's kind of constant over time, that's going to get absorbed as well. Yeah, I think that's all.
Peter?
Just very quickly, there's a good extensive literature in political science as well about aid by countries like Japan and China, where the aid is designed to build infrastructure, in particular infrastructure designed to facilitate exports from those countries, in general back to the country that gave them the aid in the first place. And so I would be not surprised to find that in those cases, the benefits of aid, or the benefits that came from the trade, are actually as large or larger than perhaps what you find in the United States case. Especially because these countries were resource scarce and were looking for places to find natural resources. And then, of course, there's a wide variety of work on all sorts of other reasons. You've heard a lot of them about why countries give aid, and it's not specifically about the trade benefits, right? The most common answer, right, of course, is to buy geopolitical support. You find some of that in your alliance results. But also, there's this whole notion of what some political scientists call soft power. You want to extend a good image abroad. You want the domestic politics, the publics in the recipient countries to think nice things about you. And so that may have geopolitical returns as well that are of a different mechanism.
Go ahead.
Somewhat related, and maybe this is just a question of interpretation, but it seems like you're emphasizing sort of aiming for itself, and so the benchmark is sort of 100% of everything. I think for development economists, maybe the benchmark is 0. So relative to 0, 27% is pretty good. That's a discount. Just because aid doesn't pay for itself along the single market access measure doesn't mean that. 27% is good.
So I have a question for you, just as much as the other chefs that cook the same ingredients, which is you could imagine that this underreaction of the outcomes could be several things. Right? It could be one that it's really a very nonlinear model, and you're estimating a local linear effect. The counterfactual is not that I wouldn't move linearly a little bit farther up, but that I might have switched massively alliance. The other one might be there are just so many dimensions in which this is paying off that on each one of them it looks NPV negative, but once you sum them all up, it's pretty worth it. Or the last one might be just simply that's why it's aid. It better be that it's NPV negative. Otherwise, we would have said we're just buying something. When you step away from the narrow confines of the paper, what's your gut feeling out of having played with the data? Where do you think this is going?
No, I mean, all fair questions. So the last three questions are kind of like very similar, right? Which is what are the other payoffs, and is it altruism? Is it that we want to be liked, and so on? So those are very similar. Yeah, sure. I mean, I think one way to view the paper is that we're taking a bite out of it, and then there's still 70% left, and if we're kind of allowed to reinsert it back into the preferences, then we can have a preference shift that's going to explain everything, right? Which is, is not a bit the name of the game of that we're trying to play. But there are some economic mechanisms that perhaps for which the data are collectible, like market access for US multinationals, for example, like service export. You can still try to mine it a bit more to see if we're not accounting for all the market access here. So that could be part of it. But of course, like clearly on the table is also the possibility that this isn't optimizing behavior in any way, right? I mean, whoever said that governments are doing optimization? So that that's certainly we have all kinds of narratives about going back to Eisenhower, right? About military-industrial complex, things being captured by special interests and so on. So that's another perhaps thing to explore, following up on this question about distributional effects. And yeah, I mean, infrastructure it would fall very much into this story. Actually, if outside of the hegemons, the effects are stronger, not weaker. So if we were to apply these different coefficients, we'll actually get bigger payoffs for non-hegemonic countries. So that perhaps fits in with this.
Oh, you're off?
No.
Yeah,
Please go ahead.
So I thought about, the COP in aid that's happening, is it more factual? Do you do it uniformly? Like, is there a sense that there's heterogeneity of which aid we're cutting in terms of the ones that sort of, like, there may be different reasons why you give aid, and some of it is actually for market access, some of it is not. And then the Trump administration has been smart. Let me play with it. Has been smart and cut only the one that didn't buy. I mean, that's what they said, right? That's what the quote says, right?
Right.
You gotta be smarter. So if there was some kind of heterogeneity, you cut first the one that didn't buy you any market access,
Right.
and then you leave only the one that does give you market access. So there you may get different welfare.
No, yeah. So there is heterogeneity. There's heterogeneity across all pairs, right? So those are those bar charts that I was showing. But then I skip some scatter plots, and you see there's actually a ton of variation in cutting aid between the recipient A and donor B, or recipient A prime, donor B prime, has very different market access implications. So there's certainly a way to do it smartly, that you cut the aid that is giving you the least market access first, et cetera. No, absolutely. There's a ton of heterogeneity.
That's not how you did it.
We did it both ways. So the first table was like cut all aid, and then the bar charts were like we're cutting pair by pair. We cut every pair. Yeah.
So when you do it smartly, then like when you just cut, so then I didn't get that.
Basically, only 1% of $8 in the world over this period pay for themselves. So, but there's still variation. Some pay 50%, some pay almost zero, et cetera. So there's still a ton of variation.
And is there evidence that they did it smartly?
I haven't checked, but we could. Yeah.
What?
There's a lot of ways, like, this is just a fact. If they say they give you 1 million, there's a lot of money that stays inside. This is even multilateral. Fees, preparation, whatever. So even in the best case of that 1 million, you never get the 1 million. It is even more when you look at the USA. A lot, not just pay, but a lot of
No, I understand, but like.
So it's very hard to do the exercise.
Let's do it over coffee, but let me give you 10 or 15 seconds if there's a last word that you want to provide.
No, I think.
Okay, great. Coffee.
Thank you.
It's working out. No. All right. Okay, thank you.
All right. We are very excited to have the last paper of a great day. So, Tomas, the floor is yours. You have 30 minutes.
Okay, thank you very much for the opportunity to present this paper. Thank you. This is a joint work with my fantastic co-authors, Jonathan Elliott and Alan Xiao, who are sitting right there. I'll be doing the presentation, then Jonathan will be handling the Q&A. So this paper is on the energy transition, which, as you're probably aware, will require batteries to store renewable energy, and in turn, those batteries will require minerals. So the focus of this paper is going to be on the upstream mining of these minerals taking place at locations like this, a lithium mine. Concretely, we're thinking of minerals such as lithium, nickel, and cobalt. These are critical for producing advanced batteries, and they're concentrated geographically in a few countries. This resource concentration is what gives these countries their market power, and importantly, they actively consider exercising it. Whether it's Indonesia as a top nickel producer, the DRC as a top cobalt producer, or Australia as a top lithium producer, all of them actively intervene in the market, often with supply restrictions that have the explicit goal of boosting prices. So the research question in this paper is, what is the impact of this upstream market power on, first of all, aggregate battery adoption? We're going to call that green transition. And second, the distributional impacts across the supply chain. And we're going to link that to geopolitical outcomes. So to answer that, we're going to estimate a dynamic equilibrium model of global mineral markets. Now, in a way, we're asking a very classic question in resource economics, but in this next generation of energy commodities. And there's some distinct features of this setting that have to do with the fact that we're now in a world with multiple natural resources, and that's the minerals, these distinct minerals, and they're complementary inputs in battery production. So what this means is that we're going to have complementarities across resource markets that's going to generate distinct economic mechanisms from what we're typically used to seeing in single resource settings with market power, so for example, the work on oil and OPEC. So let me expand a bit on those mechanisms. At a very high level, the core idea is that market power in a world with complements is fundamentally different than in a world with substitutes. The first way to see this is that complementarity flips the incidence of market power. So for example, in a classic OPEC setting, when Saudi Arabia does an oil supply cut, US oil producers win because they produce a substitute to Saudi Arabian oil. In our minerals context, if we have, for example, Indonesia do a nickel supply cut, the other nickel producers win because they produce a substitute to Indonesia's nickel. But Australian lithium producers lose because they produce a complement. That is, when nickel gets expensive, it has to be paired with lithium, so lithium demand falls, and that makes lithium prices fall. The second way in which complementarity matters is that it's going to flip the role of market power for the green transition in terms of whether it accelerates it or slows it down. So to see this, think of the following thought experiment. Suppose you have a bunch of nickel producers, and they decide to merge into a nickel cartel, okay? We're going to call that within mineral consolidation because that's consolidation happening within the nickel market. This nickel is now substitutable across all these cartel members, so that consolidation leads to the standard result that you have higher markups. That's going to raise battery prices and slow down the green energy transition. By contrast, think of a different setting where you have, let's say, a lithium and a nickel cartel, okay? And now they decide to merge into what we're going to call a multi-mineral cartel that jointly decides on lithium and nickel output. Okay? In that case, what's going to happen? Well, you need to understand that prior to this merger, if you take, say, the lithium producers, they were setting lithium prices too high because they were not internalizing that they were destroying nickel demand through complementarity. And the nickel guys were doing the same thing. So effectively, there was this double marginalization that were posing on each other. So when they merged, they internalized that, they lowered the mineral prices, and that's good for the energy transition. That accelerates it. So that's the key idea. So in short, complementarity has distinct economic mechanisms in this multi-mineral setting that doesn't show up in single resource settings where there's only resubstitution forces at play. So that's the core idea. In this talk, I'm going to go over first on the background of the critical mineral sector, then I'll go into the model, and finally the counterfactuals. So we could probably spend an entire day on just features of the critical minerals sector. So really, I'm going to just boil it down to the bare essentials that are necessary for the mechanisms in this paper. So first of all, we need to define critical minerals. The term comes from lists of raw materials that governments typically maintain with, and they do these lists with both economic and national security goals in mind. The exact definitions vary across country, but all of them typically capture some notion of low substitutability and high supply risk. So these days, about half of the periodic table is on these lists, so we're really going to need to borrow it, boil it down to say something meaningful. And given our focus on the energy transition, we're really going to focus on the subset that are critical in terms of their energy storage properties. So these are what we call battery minerals, like lithium, cobalt, and nickel. We're not going to be focusing on this paper on rare earths. That's a separate subset of critical minerals that aren't used in batteries because they don't have energy storage properties. They have other properties, magnetic properties. They're used in lasers. And they're often associated as well with national security purposes, which are not really going to be in this paper. So really going to be focused on battery minerals here. In terms of demand, we're going to be focusing on demand from the electric vehicle sector, and that's because it's the key demand source for batteries around the world, and also a major demand source for most of our minerals. In terms of data, we're going to be using microdata on both the supply and the demand side. On the supply side, we're going to construct a mine-level panel data set using a combination of proprietary data sources that we validate against official government statistics that are aggregated. And this is going to cover basically the near universe of world production for our three minerals. On the demand side, we're going to have battery consumption, so these are like battery installations by EV manufacturers. So in this model, it's the EV manufacturers which are going to be buying the batteries to then plug into the vehicles. And then finally, we're going to be using what we're going to call battery mineral recipes. So these are basically chemical recipes for each battery that allow us to map battery demand into mineral demand. So I'm going to go over just three stylized facts that motivate the ingredients in our model, and then I'll jump into the model. So the first one is that mineral supply is geographically concentrated. So what I'm showing you here is a share of world production by the top three producers for various commodity markets. And the main takeaway here is that mineral commodities are substantially more concentrated than our traditional fossil fuel markets that we typically worry about because of resource concentration and supply risk. This for production. You can do the same plot with reserves, and the main takeaway still holds. Okay. So one of the reasons why you have this concentration really boils down to geological fundamentals and just differential endowment across space. And that brings me to the second fact, which is that there's heterogeneous costs across mines and countries. On the left, what I'm showing you here is a density plot for the individual mines of the average production costs for cobalt. And you can see, for instance, here that cobalt mines in the DRC have substantially lower costs than the rest of the world. And a large part of this is driven by geological fundamentals, which are shown on the right. And that is that the ore grade of mines in the DRC is about 5 times higher than in mines in the rest of the world. So we're going to be incorporating this mine level ore grade data to get at this heterogeneity at a micro level. Finally, on the demand side, what I'm showing you here is a time series plot of battery consumption over time. So this is the flow of battery installations that gets added to the battery stock each year. So these are like new batteries being produced and consumed. And I'm showing you it here for different technologies. And basically what you can see is that it boils down to two technologies. LFP, that's the blue line, those are lithium iron phosphate batteries, and NMC, those are nickel manganese cobalt batteries. And they vary in their mineral recipes. And that's what I'm showing you on the right. This is a recipe matrix, so it tells you for each of these batteries, the mineral intensity per kilowatt hour of capacity. Okay?
Just a clarification, are the batteries equally powerful, or is one?
No, there's going to be some differential in terms of their driving range, and I'll get into that in the estimates, yeah. Okay, so what our model is going to do is, you can see that basically from this time series plot, that the market shares of these batteries has changed over time. So our model is going to capture that substitution between battery technologies, which is responding to these mineral price changes. Okay? All right, so let's go into the model now. So based on those facts, we're going to have basically these core ingredients to the model, and then we'll jump into the details. First of all, on the supply side, we're going to have minerals indexed M. There's a set of them, capital M. There's some supply S superscript M. And we're going to use superscripts for all upstream mining objects. This is going to come from a dynamic mine level extraction problem. On the demand side, we're going to have some batteries, index J. These are different battery technologies. Demand is D sub J. We're going to use sub-indices for all downstream battery objects. On the demand side, we have the EV manufacturers. Remember, they're the ones consuming the batteries. They're the ones demanding them. So they're going to switch across these battery types when the battery prices change. That's a substitution force. But then each battery type is going to use minerals in fixed proportions according to a recipe, like the ones I showed you in that matrix. And those recipes tells you how much mineral content M each battery J contains. And that's a complementarity force. So we have mineral complementarity within a battery, and then substitution across the battery technologies. Then finally, we're going to have an equilibrium in the global mineral market. So we're going to use those recipes to map the battery demand to the mineral demand, which then is going to have to equate mineral supply to clear markets. So let's jump into the demand model now. So this is the battery demand.
And are batteries most of the demand for these minerals, or are these minerals also used in other uses, or batteries is the main use?
Yeah, so there's heterogeneity in that, and that was the plot I showed in the first in one of the first slides, but I'll discuss that later. Yeah. For lithium and nickel, for lithium and cobalt, yes, it's all mostly going into batteries. Yeah. Okay, so what's the point of this demand side? We're going to have flexible. The point of this is to have flexible substitution patterns across these battery technologies. Okay. So for that, we're going to use an almost ideal demand system in which you can think of an EV manufacturer living in a region K, time T, and it has a budget, XKT, that it has to allocate across different battery technologies. So what this equation here says is W is the expenditure share on battery J, and it's going to depend on this alpha JT term, which is unobservable battery J time T varying characteristics, beta J, which is an income effect, and then most importantly, these gamma parameters, which are the price coefficients. And those are fully flexible in the sense that they're indexed by these JJ prime, so that's the fully flexible substitution parameter. As with any demand system, we have an endogeneity issue because of unobserved demand shocks, and that's these epsilons that we have here. So what we need here is a supply shifter to trace out that demand curve. So what we're going to need here is a cost shifter for the batteries, and that's what we're going to use as an instrument. To construct that cost shifter, what we're going to do is use what we call non-EV mineral prices. So these are inputs, for example, they go into the battery, like, say, phosphoric acid. And the rationale for that is that these inputs, they're relevant for the battery price because they're in the battery recipe, but they're excluded because only a tiny share of the demand is driven by the EV sector, going to Steve's comment. So for example, for phosphoric acid, concretely, it's relevant because it enters the LFP battery recipe, but it's excluded because most phosphoric acid goes into fertilizer. So it's really agriculture demand shocks that are moving around these prices, not EV demand shocks. So that's the idea. So these are the Marshallian demand elasticities that we estimate from this model. And we're looking at the IB results, which are the black triangles. So the first two rows of this plot are the own price elasticities of the LFP battery and the nickel-based varieties. So they're negative. And the two bottom ones are the cross-price elasticities, which are positive. First thing, just econometric observation, is that the IB results are larger in magnitude than the least square ones, which is what you would expect with simultaneity bias. Second, the own price elasticities of the LFP batteries are substantially larger than nickel-based varieties. And this primarily reflects the fact that these LFP batteries are lower end than the nickel-based varieties because they have shorter driving range, and you can think of them as catering to more price-sensitive, more price-elastic consumers. Finally, the cross-price elasticities, the positive ones, are going to capture substitution forces, and that's going to weigh against the complementarities implied by the recipes. Okay, so that concludes the demand side, and I'm now going to move on to the supply side. Okay, so we have this micro data at the individual mine level. For example, we can see the average cost of production. And what I'm showing you here is mine level data for producing lithium, US dollar per ton of lithium. And we could in principle just construct these supply curves directly from average cost data, and that would amount to reproducing this figure. We would just take all these mines, we'd order them from lowest to highest average cost, and then the width of these bars is just proportional to their capacity. But of course, to call this a supply curve, you need to make some very strong assumptions. The first one being that these mines have to be acting myopically. They're just comparing contemporaneous cost to contemporaneous marginal revenue. And second, you need to assume linear costs so that marginal and average costs are the same thing, right? So we don't want to do that. So we're going to relax those assumptions, and we're going to have a model that does that. So this model is going to allow for dynamics and cost convexity. This here is the problem of an individual mine I, which is going to extract some raw ore X, given its reserves constraint, its extraction costs, and its expectations over the future. So the first thing is that dynamics are going to come in because we have finite reserves, and that's going to imply a shadow cost of extraction or a hoteling condition. And what that means is that if you extract 1 ton of mineral today, you're not going to be able to extract it tomorrow because of this finiteness. So in optimizing mine, there has to be indifferent between extracting today and tomorrow, and that's what shows up in this Euler equation, that the payoff for the mine, marginal revenue minus marginal cost of extraction, has to be equal across the 2 periods, subject to the discounting and the expectation. The convexity is going to come through the extraction cost function, which we're going to call here C of x. Here I'm just going to use a simple quadratic in extraction level x, but in the paper we generalize this. So that cost function has 2 things that I want to point out. First of all, it's going to have a convexity parameter, which is this kappa term, which is going to hit the square term. And then there's going to be an idiosyncratic shock, which is this orange term. Okay? So with cost convexities, the average and marginal costs now are going to be different, and that's the bottom 2 right equations. And importantly, these idiosyncratic shocks are going to enter both averages and marginals. Okay? And they're going to generate an endogeneity issue when estimating this kappa convexity parameter. So what we're going to do here is we're going to use that average cost data I showed you in the previous slide to, in a sense, purge for these idiosyncratic shocks. The idea being that these average cost data, these are cost realizations, so they do contain, in a sense, the unobserved cost shock in them. Okay? So I'm going to show you how we do that next. So what I'm showing you here is just the Euler equation from the previous slide, and I've just applied differences to it, and I've defined an expectational error eta, which is going to absorb that expectation term from the previous slide. And this essentially just tells us that changes in marginal revenue have to equal changes in marginal costs over time, where those marginal costs have 2 components. One is the deterministic component, which is given by the extraction decision, delta x, and the kappa parameter, and then the idiosyncratic cost, which is the epsilon. And the endogeneity issue here is that when you get a high epsilon shock, you're going to extract less, so the right-hand side of this equation, the x and the epsilons, are negatively correlated. So rather than using the instrument, we're going to leverage this average cost data. And the idea is the following. This cost data is going to allow us to leverage an additional moment of the model, which is the average cost definition, which is here in equation 2. And the idea is going to be that average cost data here is observed, this delta AC term. Delta X is observed, so we can just invert these epsilon shocks as a function of those observables and this parameter kappa. So we do that inversion in equation 2. We plug that orange term in equation 1, and we've gotten rid of these cost shocks. And this is then the final estimate equation we have at the bottom, which is effectively all data, x and the parameter kappa, and then we have this expectational error eta, which we can deal with standard methods such as lags of x. So in our baseline specification, what we're going to do is we're going to allow each of these individual mines to vary in their ore grade quality. That's this G term. So for every ton of extraction ore you extract X, you get G times X of mineral quantity denoted Q. We're also going to allow the marginal revenue of each individual mine to potentially deviate from the perfectly competitive return. So marginal revenue could be equal to the price of the mineral times the grade. That's the perfectly competitive return. But it can deviate by this amount tau. And this tau is going to capture things like, for example, export restrictions by the country where the mine sits, like the ones I showed you at the beginning of the slides. And we do several extensions to this in the paper. These are the results for the mineral supply elasticities. On the left, we have the cost convexity parameter for different minerals, and these basically reflect technological differences across minerals. So for example, in the case of cobalt, that's the least convex mineral, and you can think of that primarily coming from the fact that a lot of this is mined in the DRC, artisanally, almost kind of by hand. So you can think of that as a technology that's basically linear in labor, whereas the other minerals are much more capital intensive, subject to capacity constraints in the short run, which you can think that leads to more stronger convexities. Okay? These cost convexity parameter intuition is going to translate to the supply elasticities, which are on the right. These are long-run supply elasticities that we get from the model for different minerals, and for each mineral we're showing it for the top producer and also the rest of the world producers. So for example, if you look at the DRC, cobalt versus rest of the world cobalt, DRC is substantially more elastic, again consistent with the fact that there's this low-tech fringe sector of mining that can come online quickly when prices spike. So that's the model and the estimation. I'm now going to go into the counterfactuals. So we're going to take this model and we're going to simulate dynamic equilibrium paths under different policy scenarios. So the first thing we're going to do is what we're going to call a supply chain vulnerability exercise. This amounts to removing the top producer of each mineral market and then solving for a full path of equilibrium price changes. And what I'm showing you here in this table is these average price effects of these interventions. And we're going to do this for each mineral market. So the first thing to note is that we have significantly large price increases for the minerals being disrupted. And that's shown by the diagonal terms in black in the first 3 columns. And those range between 76 to over 800%. The second result is that if we look at the off diagonals, these orange terms, those are all negative. And that's the price effects on the other minerals that are not disrupted. So what this tells us is that minerals are gross complements. If we would have been in a substitute world, those numbers would have been positive because, as for example, lithium gets disrupted, you would have had substitution towards nickel and cobalt. So we see the opposite here. And finally, in terms of battery price pass-through, those are the 2 columns on the far right. We also have some heterogeneity depending on the mineral being cut. So for example, if lithium is cut, lithium is a common input to all batteries, so that's going to raise all battery prices, but that's not the case for nickel or cobalt. So next, we're going to move to counterfactuals that explore the role of market power within a single mineral market. So here what I'm showing you is the impact of Australia unilaterally doing an optimal lithium supply cut. And these are the changes in surplus across the different producers. So on the left, you can see the lithium producers. Australia obviously benefits from this because they're the ones doing the supply cut. But then Chile and Argentina also benefit from this because they free ride on this lithium supply cut. They're producing the substitute to the Australian lithium. The other producers, the nickel and cobalt producers, they all lose from this because they're producing the complement to the Australian lithium that just got expensive. Beyond the spillovers across the upstream producers, we can also look at the effects on downstream green adoption. And this left panel shows you the effects on batteries of this Australian policy. So all battery quantities drop there because lithium is a common input. But instead, if we would have had, say, Indonesia do a nickel supply cut, on the right, we've gotten some substitution from battery N to battery L. Because in that case, what's going to happen is that as nickel gets expensive, within the battery N bundle, there's going to be a decline in demand for lithium because of complementarity. That's going to lower lithium prices, and that effectively acts as a subsidy to battery L. And that substitution is going to soften the drop in total adoption from this intervention. Finally, moving beyond this unilateral supply cut, these unilateral supply cuts, we're going to move to cartel policy. And what I'm showing you here is the impact of a lithium cartel as it gradually gets bigger, as it gradually increases membership. We're going to start off with Australia alone being the only member of this cartel. Then we're going to add Chile and then add Argentina. And the takeaway here is that this consolidation within a mineral market, in this case lithium, is anti-competitive in the sense that prices progressively increase, and anti-adoption in the sense that quantities progressively decline. So this is the standard intuition that you would get in a cartel with producers that produce substitutes among each other. Consolidation is anti-competitive. Okay, finally, I'm going to move on to the counterfactuals that explore the role of market power across mineral markets. So here, the idea is the following. Suppose you have a bunch of independent mineral cartels, let's say a lithium and a nickel cartel. And now we're going to have them merge into a single multi-mill cartel that jointly decides on lithium and nickel supply. Okay? So on the one hand, we have this anti-competitive force because we have a bigger cartel, so we have higher concentration. But on the other, this cartel is now internalizing cross-mineral complementarities, and that's a pro-competitive force. And again, the idea here is that prior to the merger, the lithium cartel was setting prices too high because it didn't internalize, it was destroying the nickel demand. The nickel guys were doing the same thing. So we have some double marginalization before the merger, that after the merger gets internalized. So we do that exact simulation in our model, and we have the results here on the right in this figure. And what we find is that both of these forces, the anti and the pro-competitive one, basically nearly offset each other. So even though we have this cartel that's bigger as a result of this merger, the quantities barely change. And importantly, if anything, the results are pro-competitive. And you can see that by comparing the light and dark blue bars. So the main takeaway here is that consolidation can be pro-adoption when you have these complementarities at play. Okay? So one way to think about this is that this exercise is really a horizontal merger of complements. And that's analogous to a vertical merger in that both eliminate double marginalization. And that's a classic result. I mean, really classic, going back to Cournot, 1838. Yeah, so I think, so Keynes was right. We're all really slaves to a defunct economist. All right, so this multi-mineral idea, you might think, well, maybe this multi-mineral cartel is not necessarily cohesive. And indeed, in the paper, we show that there are defection incentives for each of the individual members from this cartel. But I think the main value of this multi-mineral exercise is that it's more of a thought experiment or an analogy for something broader, which is coordination across mineral markets. And even if that doesn't happen because, let's say, the DRC sits down with Indonesia, it can still happen through another channel, which is through multinationals that own portfolios of mines across different mineral markets. And we can see this in the data because we see the ownership data for each of these individual mines. So what I'm showing you on the left is concentration of world production, but not by the country where the mine physically sits, like I showed you at the beginning, but by the country of the multinational that owns the mine. And what you can see here is there's essentially just one country that has ownership stakes across all three mineral markets, and that's China. So that's Chinese ownership of mines in the DRC, in South America, etc. Yeah. So what we're going to do with the model is do some counterfactuals that explore this role of Chinese market power as it coordinates across these mines that it owns. Okay? And that's what the figure on the right shows. And the main takeaway here is that this horizontal coordination by the Chinese multinationals across their mines, across mineral markets, is basically going to mimic the pro-competitive mechanisms of a multi-mineral cartel. And that's because they also internalize complementarities. Okay? We also do a further counterfactual, which is basically motivated by the fact that China also has a large domestic EV sector, which is a vertical coordination between the Chinese downstream EV manufacturers and the Chinese upstream mines. And that's going to layer on further pro-competitive effects, although for a different reason, which is just the standard elimination of double marginalization in a vertical input-output structure. So finally, let me conclude here with a final counterfactual, which is a little bit more tied to geopolitics. So basically, what the kind of core idea from the previous slides is that market power can be held by sovereign states, and this is typically exercised by state-run cartels within a single mineral market, or it can be exercised by multinationals, which are diversified across mineral markets. And we know from the history of natural resources that geopolitics shifts the balance between the two. So for example, if you go back to the mid-20th century when we had the big oil nationalizations in the Middle East, okay, you can basically think of that as a transfer of control of those mines in the Middle East from the Western foreign multinationals that were operating there to a state-run cartel, OPEC. Okay? So motivated by that, we're going to do a similar exercise with a model, which we're going to call a resource nationalization exercise, which is essentially comparing the market power of these Chinese multinationals across these mineral markets to these state-run cartels, which exercise the market power within a mineral market. And the mechanism here is that what this nationalization does is that it breaks up coordination across mineral markets by severing those multinational ownership links, and it reinforces it within mineral markets by setting up the state-run cartels. And we know from the previous slides that that's an anti-adoption force or an anti-competitive force. So what we show here on the right is the result of that counterfactual, and the main takeaway here is that this market power by these state-run cartels is significantly worse for green adoption than the market power of these Chinese multinationals. So to conclude, Chinese multinational presence upstream can be a positive force for green adoption. So to conclude, critical minerals are going to power the energy transition. These mineral resources are concentrated, much like other natural resources we've studied in the past, like oil, but they introduce these novel interdependencies that have distinct implications for geopolitics and green adoption. Thank you.
Laura Alfaro is the discussant. One time I tried to pronounce it the English way. Doesn't happen often, I get it right. I get it right.
Consider my name has a very Italian sound.
One time I could do it.
So thank you very much for inviting me to discuss this paper. I am now at the IDB, and so I should have put a disclaimer, although it's a discussion, so not sure how that works. So what does the paper do? So the central thesis, and I think this is the key contribution of the paper, is that critical mineral markets have interdependencies from the joint use, which is what they call these recipes. So it is not about the minerals themselves, but they do create a network that could be a complement or substitute, and that is an empirical question. Also, that these recipes can create important asymmetries, and they have this example. So lithium is common in every battery chemistry, so you cannot substitute it away. So restrictive policy, what it does is makes all batteries more expensive, and EV adoption, which is just one tiny form of battling climate change, let me just say that, because there are countries like in the Americas that we have hydro, and that's a different thing, and it's actually a better energy. But so in this particular case of EV adoption, it does reduce EV adoption. Nickel is battery specific, and so consumers can substitute it away by choosing different type of batteries. And so this ability to substitute offsets the effects of restrictive nickel policy. Whether at the end, how it affects the lithium price, it will depend on whether the complements and substitutes. And as I was mentioned by Tomás, in the evidence, they do find that there is a gross complementarity. And then at the end, they do these counterfactuals that they find that a multi-mineral cartel is better than a single mineral cartel because internalizes cross-mineral spillovers. But the fact that we're all dominated by China is the greatest thing that could happen to us. Because, again, it controls many of these things. It is a very ambitious paper. I don't think the presentation did justice of all the things that are in this paper, all the data. They have all these near universe of mines in lithium, nickel, and cobalt. I actually also have the S&P data set, so I know all the good stuff that is in that data. They have costs or grades, capacity, reserve, ownership. They also bring these engineered recipes, EV installation by model, brand, region. Like it does have a lot of data. A lot of this data is using the identification. They have very cool IV. Then they have demand. Then they have equilibrium. So I think the paper does have a very nice contribution to the literature. In particular, it does come from this estimation, and it makes it a very complete I/O paper. Why do we care, though? We do care because there is a concern that these minerals are not just geologically concentrated, because they have been geologically concentrated since the Pangeas started to move. It's because China is dominating a lot of these processes as well. Lithium, nickel, graphite, and don't get me started in rare earths. So I'll stop there. And the instruments that the paper mentions are real. We do know that there has been these changes in the quota in Indonesia, and it has been an issue in Congo, in China. Again, all of these things are real, and resource nationalism is real. So let me go over some of the comments. To the biggest point of the paper, I agree. We need to look at these minerals as a network. We cannot look at them in isolation. This is the right way to look at these rocks and primes. And I do think this is an important contribution. But perhaps some of the assumptions are attack restrictive for some of the questions they are tackling. And in fact, I think the paper reads at times as two nice papers, and I think this is also the outcome that I read the first version, and then they sent me the second version. So the first version does read as a very nice I/O paper that models batteries, recipes, very detailed estimation. And then the second soul of this paper is the geopolitics. Disclaimer, I don't do I/O, and so I'm gonna stay away with that, from a lot of the I/O, but I am now a minerals aficionado, because we're doing a critical mineral initiative at IDB, and I have here like all the details of the lithium. I can tell you that there is the Atacama Salar is the #1 source of lithium in the world. So now I know a lot of details about this thing, which is kind of ironic, because if there's a country that has no minerals, it's Costa Rica. Like tons of insects, but no rocks. So I'm going to go into the geopolitical implications, because that's the game they play. Like if you read the abstract, that's what they're doing. They want to find out the geopolitical implications, and after all, this is the conference that we are. And also it allowed me to think about a lot of things where we're trying to do IDB in terms of critical minerals. So I will use their lens, and so the comments are an extension of the principle. And I think the counterfactuals is using a model that is not per se equipped to changing so many market structures. But to be fair, if you read this paper, the authors know all the comments, they have clarifications, footnotes, and appendixes. But I think sometimes they were just left as a footnote and they were not really internalized into the paper. Maybe a cartel would have been. So for the first soul, that is just the ion, I think they take very seriously a lot of the parts of the minerals, but then they forget about some. And I understand that one has to simplify, but I think some of these simplifications for sure affect the quantitative implications and may affect the qualitative ones. How complementary and substitute the critical minerals are will depend on some of their assumptions and some of the assumptions on the estimations. For the second, I do believe the model neutralizes China, in particular in the midstream. And so this is also likely to overstate the quantitative importance of complementarity and perhaps also some of the implications. So broadly, I'm going to discuss mining, production, and global value chains. Then I'm going to go into some of the demand, and then I'm going to talk about their counterfactuals. So I actually think that Disney and Snow White and the Smurfs have done a disservice to the mining industry. Because everyone thinks that mining is you go with your pickaxe and your shovel and then you walk away. And mining, unless you're doing gold in San Francisco and you were very lucky, is anything but that. Mining is a very complicated process, is a very chemical and physical process that includes many parts. And so you have to do all the R&D, the exploration, the mineral extraction, that is a complicated process, the refining, the manufacturing, and assembly. And these parts, I think, oversimplification may affect results. So mining upstream, in the model, it feels like arrives like manna, and that is not the case. You need a lot of inputs, reagents, chemicals, and all of these inputs basically come from China. For battery manufacturing, what they care is not the rock, is battery-grade lithium and nickel, not the concentrate. And this includes a lot of processing, refining, and that does go through a lot of chemicals. The refining, the midstream, as I said, I think China loses the edge by construction. And in the downstream, the paper is all about the cathode, but they neutralize the anode. And I joke with my array that I never thought I would use cathode so many times in a sentence, but now I'm like deep into cathode, because copper is an important cathode. There's a lot of more common materials, and this affects the network. So let me go into lithium. Turns out there's not one lithium. The paper says this. The paper is aware about this. They do go into mine level heterogeneity, yet equilibrium clears one global lithium market and one price. It turns out that the lithium in Australia is very different from the lithium in Chile. In Chile, basically, you have ponds and you wait 2 years until that thing dries up. You put a little bit of chemicals, and literally that's what you do. That's why Chile and Australia is so very low cost. But it is inelastic in the short run. You cannot do anything. You have to wait for the thing to dry up. And it can take 2 years. So whatever you have at the moment is what you have. The Australian, which is hard rock, is very elastic, but it's expensive. You have to crush it. The Chilean brine, you import the chemicals, but it's basically at the end refined, and once it dries up, you have the lithium. The Aussie rock, they mostly send it to China. In the model, they enter at the same level, but they're interchangeable. Like Chile lithium is ready for the battery, Australia rock is not. Oof. Lithium is not a commodity for the most part. It remains heavily contract-based, is really sold in long-term contracts. The spot market is very small. Like we tend to think that all of the commodities are like oil, sold in a commodity stage. Lithium is not, rare earths is not, many are not. It turns out that ore grades differ. So there is actually not one nickel. So the nickel that comes from Indonesia is actually of a lower class in terms of ore grade, and so disproportionately it goes to stainless steel. The better lithium comes from other countries. By the way, Brazil has also the better lithium, number 3 in reserves, in case you care about Latin America. But this is becoming scarier. So that's why there's effort to try to see how we're going to deal with the other one. But most of the other one actually goes to steel. And so it matters because the model clears one nickel, one price, and one elasticity. And there's also this, how exactly do you map the Larite that is lower class into a battery? For battery, you need high-grade nickel. Then there is the layers of midstream. So basically, in the paper, the price of the battery are the recipes times price, and there is some markup that absorbs many things. And this markup is held constant in all the counterfactuals. So all mineral shocks pass directly to battery prices. And so again, you do have a very passive midstream and a very passive assembly. This is a limitation. It's very hard to get data. And I know that, I understand that. But it does matter because you're looking at strategic reasons, analysis, cartels, unilateral restrictions, and then refining chemicals and manufacturing cannot exercise market power by assumption. Again, then we take it and we do counterfactuals for many years, and it is still fixed. So again, this is why I think sometimes I would be fine if this were the IO exercise. I have more problems when you're changing completely market structure with different and keeping this mu constant. The paper acknowledges this. The paper knows this. As I said, this is there. And the argument is that markups are small. But markups can be small because that is the strategic choice of China to keep them small for a reason. So I think the question is not if they're large or small, it's if they can move. And these markups can move. Then we go to the anode. So it turns out that I found this nice very picture for a battery, you need an anode and you need a cathode. The cathode actually, it could be lithium, it could be nickel, it could be cobalt, it could be magnesium. But the anode can only be one, graphite. And it turns out that is the main part of the battery. Disproportionately, it turns out that copper and aluminum also are more important than anything else. But the graphite is very important. They don't include it because they say now there is a fake graphite, but that fake graphite also comes from China. So I don't think a geological or chemical substitution can undo industrial concentration. So the main input is outside of the model. In this simplification, the paper uses 2 inputs, but it does matter that there are more inputs. And so if you're 2, then it does become very easy to determine the cross effect of lithium and nickel. When you have more that are important, it is a little bit tricky. And so for sure it affects quantitative results, but it could actually also affect qualitative results. So again, the paper argument, and I agree, is that critical minerals differ from OPEC because there is joint use complementarity, but then having a better sense of this matrix, because this matrix does define power, I think it's important, and by that I mean market power. The recipes are fixed. By their own paper page, they do show that they change. In the time span that they use it, they're going to change. So again, this will matter in terms of some of the counterfactuals. The EV demand is a little bit exogenous. It's taken outside, and they do have some forecasts. But for 10, 15 years, it starts to become an issue. There's this other assumption sneaked in there that when the price of one of the inputs goes up, the whole battery demand goes down. That I think it would be nice to make it more evident if you really need this assumption, because it's not for me trivial. Like it's the price of Nike goes up and then we all buy less tennis shoes. So it is there, it is a little bit hitting. I think it gives you a lot in terms of the results. Not all demand in EV is nickel doesn't go to EVs. There is growing demand, changing demand in your sample. And the other one is these markets are segmented. And some of this is taken in consideration, but it does affect some of the results. If I'm already lithium, I cannot substitute into more lithium. So let me just finish with what the cartel is controlling, which is at the end the main part of the paper. The model policy instrument is mine output. But what does supplying restricting the supply means? In Chile, what does it mean? Like I start drying less lithium, I delay evaporation, I break my long-term contracts. In Australia, I don't send the rock to China. In Indonesia, I don't do the extraction, I don't do, again, there is a part of it, what is the real policy? And again, this matters because the bottleneck sits at different places in the value chain. There's another thing, that they don't really control all the production process. So if Chile doesn't send, like, is China going to be so happy to sell them the inputs? Again, there is this dependence downstream, upstream, that may become an issue. And again, owning the deposit is not the same thing as controlling effective supply. It then means that the coalition matters, not just the size, to be able to determine what is feasible. To do a coalition with a player that requires a lot from China, either for refining or to the chemicals, it becomes a little bit complicated to sustain. So I do think the paper needs a little bit more institutional interpretation when analyzing this welfare rank. What is feasible, what is stable. There is a nice footnote that the auditors just want to know if everyone will be happy in and assumes enforcement. But in cartels, the thing that has always been complicated is the enforcement. The idea of having a cartel, everyone has it. But sustaining a cartel is what is complicated. So I have some suggestions within the machinery of what to improve, add a little bit more to the input-output, add a little bit of non-EV demand, but I would handle those counterfactuals with a little bit more care, because there's a lot of assumptions in those estimates that is not clear to me carry over when you're completely changing the market structure. So to conclude, the paper uses the right set of glasses. Minerals cannot be understood by themselves. We need to look at the interdependence. I do like a lot your supply chain vulnerability results. But next steps I would handle with a little bit more care, especially geopolitical considerations. And just because I am truly a macro person, let me remind you that we do know well in Latin America that geology is not destiny. We know that there is a resource curse, and macro management matters a lot for that. Thanks.
Fantastic. Let me open it up for questions. Steve?
It's a cool paper presentation, really, really interesting. One thing I was thinking that's so interesting about the paper is kind of illustrating how the I/O of the supply chain network really matters for assessing vulnerability and choke points. And so one thing I was thinking would be interesting is if there's a way of sort of comparing it to a more simple macro approach to assessing vulnerabilities, which would be essentially some form of nested CES, taking the first order approximation, vulnerability depends on initial shares and the substitution parameters. Now that's going to be a bad approximation in your model for several reasons. One is the sort of richer production structure that you've got a mix of complementarity and substitutability. Another is the active cost dynamics. And so you may not want to go in this direction because it's sort of a little away from I/O. But I thought that's a kind of really interesting implication of your paper. It's actually doing the I/O right can be really critical in assessing national security vulnerabilities. And then related to that, I wondered if this may not be possible, but if you sort of took a first order approximation, you have to think about exactly how to do that with the dynamics, but could you derive something like sufficient statistics in your model where you're giving your estimated parameters, if I know the initial conditions, I can get the first order effect, and then compare that to the full nonlinear effect in the counterfactuals. And again, those could be pretty far apart, given the complementarities of the model and so on. But super, super interesting in many ways. And that was just sort of one suggestion in kind of teasing out some of the results.
Go ahead. Mario.
All right, just a comment, I guess, to start. Have you said that the OSCE's original matrices, I hope a lot of us use intermediate, but the OSCE's rating matrices from 1919, 29, and 39, and its literal interpretation were physical relationships in many contexts. So I think we should back off of that, not to re-prosecute the Cambridge debate, but some things are really physical. And a lot of times we know that stuff electronics about how to go from there. But that I see as the key message to this. Maybe, I don't know where the recipe language came from, but I would just say Leontief. Instead of citing Julia Childs, let's cite Leontief. In terms of the supply, right, I mean, there's a dynamic part of this too. If you look at the oil price shocks, the biggest effect of those was a drilling boom that geographically diversified the pool of oil. That can also happen with these other minerals. So despite their essentiality, what's that dynamic response going to be? That I think is an interesting question. But certainly the prices are responding in a way that says they're critical, and in some sense, you get massive price responses in that shorter horizon. I'd like to see a little more discussion of the longer term dynamic.
John?
I have a related point about the dynamics on the demand side. I think it's great you're talking about the supply side. On the demand side, right, we know from Andre and Laura and so on that there can be dynamic elasticities. One reason that might be particularly interesting here is that elasticities at different horizons can also be endogenous, like to whether I have a stockpile and some policy choice. And so if there's anything that you guys can speak to, that you have a better quantitative model of this market, that would be super valuable.
Why don't you take a few minutes to reply, and then we'll take some more.
Great. Let me first start by thanking Laura. Where is Laura? Thank you. There you go. Okay, thanks first of all for an excellent discussion. Thanks also for reading the paper twice. There's a lot of really great stuff in your discussion. You know this context really well, and so it's great to get your reaction. Let me make just two points, and then we can talk offline about some of the other stuff. So you noted kind of the different types of these minerals. And that's absolutely true. I think there are some limits to exactly how seriously we can take this, but certainly on the cost side we can be quite flexible, and we think it's one of the advantages of the cost approach that we take. Our cost data that we can have very different costs for different types of mines. So we do have that in there, but point taken about how that may influence things on the demand side as well. You also talked a little bit about the midstream sector, which is largely dominated by China. Due to the data limitations that we have, we're a little bit reduced form about what we can do there. We feel essentially we've got kind of like a wedge between what would be implied by the mineral prices and the battery prices. And we feel pretty comfortable with the way that we approach it in the counterfactuals, where we keep it fixed based on work that has different data than we do and has looked at the midstream battery manufacturing and found really limited markups in that setting. But point well taken that that's kind of within the context that we observe today, and we're changing the market structure. We've explored this a little bit in counterfactuals that aren't in the paper, but we've played around with this, where China responds to some policies, and we actually get a pretty small effect there. We can think about that more. Let's see. Okay, so next we've got Steve. You asked if we could compare this to, say, like a more macro approach, a CES approach. I'm glad you bring that up, because we do think that's kind of one of the advantages of what we're doing on the supply side, is we've got this almost ideal demand system. The whole point is so we can have these really flexible substitution patterns, which, is different from, constant elasticity of supply. So we haven't done any kind of comparison, but we definitely do think that that's one of our advantages, and we can think a little bit more about like how we can contrast that. There was also the question about whether we can derive sufficient statistics, or something that is like to a first order, like a sufficient condition. We can think about that a little bit more. It's a bit complicated, but we'll think on that. And there was the point about the Leontief production function. Yeah, we think that's absolutely right in this context, where this is basically coming from chemical reactions. Regarding the terminology of recipe versus Leontief, we're definitely talking about the same thing. We thought that recipe is a little bit more intuitive to people, but yeah, that's the production function that we're thinking of. And then you made a point, and John kind of also made a point on the demand side about dynamics. Let me first address the supply. So yeah, when we think about oil prices, prices increase, we get an expansion in supply. I think we're much more limited in terms of like new entry in this context because mines take a really long time to enter. It takes well over a decade to build some of these mines. We can see that in the data, but we do see in our data kind of like the future pipeline of mines, what mines are under construction and when they're expected to come online. We actually do incorporate that. So that's exogenous, but
Sudbury, which was the nickel capital of the world during World War II, and deep underground, is now filtering through the tailings to extract gold and silver. So there's a bit more of a supply there. The time delay for mines. As the technology changes, and prices also shift with technology.
great. Thank you, and point taken. Then on the demand side, thinking about the dynamics there. So I think, you know, what was brought up was stockpiling. I think there's a limit to how much you can do this, just kind of like the chemical stability of some of these minerals. You know, you might also imagine longer term stuff on the demand side with these batteries. We're kind of taking the technologies as they're given today. We don't really, you know, it's kind of a forecasting exercise, and we do have forecasts that we use on what expenditures are expected to be on these different battery technologies into the future, and we use that for disciplining the expenditure on batteries in the future. So that's what we're doing on the dynamics on the demand side.
Great. So let me ask you the last question, and then we'll conclude. So, I mean, first, I like the paper for the same reason that Steve pointed out, which is it's a really great attempt to say, look, let's take the micro bottlenecks a lot more seriously, and you get pretty different conclusions from what you would just do at a million-mile high of all minerals. It also seems that you're looking for more geopolitics, so let me suggest two things and get your thoughts on it. One is, on the offensive side, when you have complementarities, you might really crank export controls on what you control, not so much because of the direct effect on what you control, but because of the indirect effect that you might have somewhere else in the world through the complementarity. So that might give you a reason why you really go hard on the few things that you control in the presence of complementarity. The other way around, you can think of it as, if I want to exert a given amount of power or control, when you have multiple steps with complementarities, there might be a way to minimize your cost in acquiring mines by just picking the right parts of the chain in some particular combinations to maximize how much you can exert with potentially very little control. So those might be applications to geopolitics or geoeconomics that the paper is, you know, almost there, and they're more words and applications rather than the hard work that you already did.
Great. Thank you so much for the suggestions. Yeah, I think, you know, you highlight exactly the point that we're really trying to hone in on with the complementarity. And, you know, I agree with like some, you know, with some goal in mind. If you are producing something that has some complements, you know, that complementarity gives you kind of greater power, and maybe to the extent that you can choose what you control, you know, the complementarity certainly matters there for similar reasons. So thanks for that suggestion, and we'll definitely think about that. Is that yeah. Great? So.
Thanks. And thank you so much to everyone for coming here. I know it's very hard to get people across fields to come together. And so it's so wonderful to get, you know, a room of people working on, you know, kind of the same topics and from different directions and understand it. So thanks so much to all of you for being here all day, all the presenters, and especially all the discussants for making today a success. And hope to see you all here next year.
Thank you to Jesse.